Hello. Hello. Welcome for another exciting MVA. This is we've done a few together this year. We've got a great day of Unity 5 goodness for you for developing Unity 5 games for Windows 10 Jumpstart.
Oh yeah.
I'm Adam Tuliper. I'm here with my good friend.
I'm Matt Newman.
And we're going to talk about a bunch of cool stuff. So first, let's get rolling a couple of slides so we can kind of understand the audience, what we're going to talk about today, and then we shall get rolling on some really, really cool game development stuff with Unity 5, one of my favorite software programs on the entire planet.
Let's do it.
All right.
All righty.
So I'm a technical lead evangelist with Microsoft. I do a lot on the gaming, of course, and cloud and web technologies. Had a good career in some secure software development areas for a while, and then gaming kind of accidentally took my life in a different direction. Was a software architect for many years before joining Microsoft. You can find me at AdamT@Microsoft.com and on Twitter at AdamTuliper. I always try to tweet out pretty cool things about stuff I'm interested in, especially game development stuff. So, and if you have any questions on anything that you see today, whether you are live or watching this on the net at some point in time in the future, feel free to reach out to me at AdamT@Microsoft.com for any clarification or help. And Matt,
yeah,
let's talk about you, shall we?
Yeah, let's do it. Okay, so I'm Matt Newman. Currently, I'm serving as creative director of Silicon Storm. It's a kind of augmented reality firm based in Orange County. I have my own, I've done actually a multitude of indie game studios. I am an indie game designer. My main studio is Subscience Studios. That's where I do a lot of the games I've done. Last year we did a game for the band Avenged Sevenfold called Hail the King. You can find that on pretty much all mobile markets. I created my first game I ever created was Grave Stomper, so I kind of have an affinity for that kind of dark, whimsical type stuff, which is on iOS and Android. And that was with a company that I first started, Mad Menace Entertainment, a couple of years ago. So bounced around a little bit. But yeah, now been doing video game stuff for years. Started as a Flash designer, now jumped into Unity for the last 5 years, been through all the different iterations of it. So. Yep. Here to basically show you some cool stuff. I've worked with a multitude of different clients and different people, so
and Matt,
exciting.
Matt and I both run the Southern California, the Orange County Unity meetup, so if you happen to be in Southern California, check us out. We do some cool stuff down there.
Absolutely.
All right, today we're going to start out with a Unity overview and our workflow for using Unity, which may or may not match others' workflow. Everybody has their own different way of using it. This kind of builds on another course that we did. There's going to be a little bit of overlap and a whole bunch of new stuff as well. I'll show you a URL for the other course shortly. We're going to talk about integrating Unity 5 features, and we're going to have our good buddy Mark here from Unity, who's going to be joining us, talk about Unity 5 features. In Module 3, we're going to go over some coding and a little bit of AI, which is a funny term because really it's not really intelligence in games. Then Module 4, everything I wish they told me about cameras. If you're starting out in Unity and or even been using Unity for a little bit, hopefully you'll pick up a couple tricks on what you can do with cameras. There's still plenty more than outside what we're going to show, but hopefully we give you some cool tips on there. And number 5, UI, Unity's UI system, so overlaying like HUD elements, I should say, and the wow factor. So doing some cool stuff to make that game stand out just a little bit more. And finally, Module 6, we're going to be talking about building for Windows 10, which is not fully released yet. So is this kind of the chicken before the egg? You know, Windows 10 has been out for a while for public download, so we're going to we'll talk about how you build for that, what to expect there. Unity's done some pretty cool work on the tooling there, which is currently in beta, so we'll get to that as well.
Awesome.
All right, today the target audience, this is going to be beginner and intermediate Unity developers. If you're a beginner, there's going to be tons of new stuff. If you're intermediate, I think Module 2 is going to be especially interesting to you. And ideally, you're a C# programmer. Now you can do a whole lot in Unity without code, and we're going to look at actually a lot of stuff today that is not code-based. We're going to do code as well. The main code module will be in Module 3, but there's going to be some code outside of there as well. But we're going to see a lot of stuff in Unity's interface. And for some suggested supporting material, C# fundamentals, DigitalTutors.com has some great Unity learning content on there. And we also, about September or October, we did a 9-hour course. Matt and Carl from Unity and a bunch of my other good buddies here at Microsoft. And that you can find on ak.ms/free Unity training.
That one's our first collaboration.
Our first collaboration. We did Zombie Pumpkin Slayer.
We got more zombies today.
More zombies today, yep. So join the MVA community. So over 3 million registered users. I had an outdated slide here shortly, and they're like, no, we're over 3 million now. So that's amazing. Get 50 MVA points for this event, aka.ms/MVA voucher. Use the code WIN10UNILY5, and just caution that expires on August 3rd. All right, let's talk real quick about Microsoft's investment for game devs, because we've done a couple interesting things. We're going to talk about the Visual Studio tools for Unity in this module today. We acquired Syntax Tree about a year ago or so, and then we released them for free. We have BizSpark. We give pretty much all of our software to startups for free. You can check it out on bizspark.com. All the code today, we're going to be using Visual Studio. You can use MonoDevelop, which is installed by Unity by default, but we're going to do everything in Visual Studio because it makes the experience a lot better. And there's also the Visual Studio graphic debugging tool. It's a really cool low-level tool that you can use to go frame by frame and break apart all of your shader calls, draw calls inside of there, and help to find some really specific. It's a low-level tool. If you're a beginner, you're probably not going to be using it. But at the very end of the day today, we're going to look at Unity's Profiler, which is now included in their free version as well. So very exciting. Cool. We've got some really cool tools there. All right, Module 1. This is our overview, Unity overview, prototyping, and workflow. Matt's going to show you a little bit on the prototyping side. I'm going to show you some of the Unity asset side, our workflow, how we work together back and forth, a real little bit on Git.
Yeah, this is the perfect artist-programmer scenario.
Interaction.
Yeah, exactly.
Relationship. Long walks on a beach.
Yeah.
So Unity overview. Unity, I was a software architect for many years, and somebody asked me, they said, hey, do you want to talk about Unity to our game dev group and for Windows 8? Now, there's a product from Microsoft called Unity, which is not in any way, shape, or form related to the game platform development system engine that we're going to be talking about today. One is used for dependency injection, a software architecture practice, and one is used for creating games. So when I heard this, I'm like, huh. So you want to talk about Unity and Windows 8 to your group, and then I realized that Unity was a game engine, so I started checking out, investigating Unity, and then that changed everything I did from that point forward. So caution, this is very addictive. This may alter your life's course.
Yeah, I think the first day I started using Unity, I never looked back.
That was it. That was it. Yeah. It's addictive. I did some extremely powerful DirectX. I did my college project. My final project was with DirectX, and then I touched it again for a long time. And then I found Unity, and so that's what brings us here today. So Unity gives you full 2D and 3D support. It is not a 3D asset modeling tool. Matt's going to show a little bit in Maya.
Well, there are some plugins that let you do that. So for the most part, you want to use external tools.
I always like to put an asterisk surrounding that, because built into Unity, you can do some terrain building, which we've done before in some prior MVAs. And as of Unity 5, they introduced SpeedTree. Now, SpeedTree is used actually in movies and other top-end games, so it's a very professional tree system. And then again with the asterisk, because there are third-party plugins like ProBuilder, for example, that you can do modeling inside of Unity.
Which is excellent,
which is
by the way.
Cool stuff. Physics uses Box2D for the 2D physics and NVIDIA Physics. Unity 5 got an update to NVIDIA Physics 3, so a lot more performance there. There's some really neat demos you can find on the net where Unity 4 had, 20, 30 physics objects running the scene, and they've got like 200 on Unity 5. It's pretty crazy. Over 22 platforms supported, so it's pretty much one of the most amazing cross-platform tools I've ever seen. Over 22 platforms. Real-time global illumination and physically based shaders. And if you're wondering what the heck is that, we're going to be talking about that in Module 2 today. Mechanism animation system, we're also going to be looking at in Module 2. The asset store, let me just switch over to that, because that is what kind of hooked me here, because I am not a good designer. That's why I work with this gentleman sitting to my right-hand side here. But on the Unity asset store, you can find things like full 3D models, shader writing systems that will do it for you, zombies. I realize I can get a lot of these assets here.
Oh, man.
Matt, I don't know.
I'm going to have to start putting stuff on the asset store.
So very, very cool stuff. I mean, this is what makes it amazing. At Microsoft, we work, of course, with a lot of game studios, and you'll find that near every single one uses something from the asset store. They might not.
It's a great resource for not only programmers finding resources to develop your own games, but also if you're a designer and you want to prototype a game, or you have a game idea and you're trying to get something to market, or even find people to join your team, it's a great place to go as a starting point. Find a sample project, reskin it, do what you need to do, and then you'll have a base that you can work from to create pretty much any type of game you're looking to do. So asset store is huge.
Amazing.
I highly recommend, definitely kind of just going through it and seeing what's on there. And there's a ton of free
Lots
stuff.
of free stuff.
Yeah, Unity
Yep.
puts out a ton of free stuff, and then there's some great paid stuff too. If you're willing to spend a little bit, you can get some really great low-cost full projects that you can just go nuts with. So
Things,
really,
environment systems, Mountlands,
Yeah.
et cetera, that would cost you probably 10 grand plus if you had somebody
Totally.
write it for you that you can get for, you know, $70, $50, $30.
and like you said before, it's a great resource for external plugins. So there's a lot of really, really great tools. Like you mentioned ProBuilder, one of the plugins that I use. It's absolutely amazing for basically prototyping out levels on the fly. And just like using these different tools, you can actually create within Unity without having to go to Maya or Blender or some outside program. You can actually do it all within Unity, which is really, really cool. It just saves a lot of time. So definitely check out the Asset Store. Huge benefit to Unity. So,
Cool.
Yeah.
Amazing. So let's take a moment and go over a Unity overview. So this kind of builds on the MVA we did previously, but I'm sure there's a lot of folks joining us today who don't have any Unity experience. So I just want to give you a quick run through of kind of Unity's interface and some core concepts before we kind of start prototyping things out and diving in further. So let's go and look at Unity. I'll talk briefly about what we're going to be doing later. We're going to be building out various aspects, looking at some things in this particular project. Matt, what is the name of what we're looking at here?
So this is Vamp Kid versus the Zombie Apocalypse, the 3D version. We've actually done this game in 2 separate versions. I think we're going to be going mostly over the 3D version today. We'll show you, I think, some little bits of the 2D one we did, right? Or maybe?
We are going to be showing some
Okay.
of the 2D version, which will eventually be open sourced on GitHub.
Cool.
This particular one here as well is going to be up on GitHub. I will show you that URL in the second module today. And we kind of had the idea of doing little bite-sized pieces, and we thought, you know what, let's bring you something a little bit more full. Maybe not a complete game that you're going to turn around and sell and make all the money that we would normally make off this.
Huge checks.
But so we kind of changed this up a couple days ago, and we said, hey, let's see if we can't put something a little bit cooler together here.
Yeah.
So we've been working actually in the last few nights,
Yeah.
pretty late on this. So hopefully you'll get some enjoyment out of this today. We've got some pretty cool tips in here, and so yeah, let's look at.
It's kind of a classic platformer with some shooting elements. It was just kind of a fun project that we threw together, and hopefully you guys will dig it. So
Yep.
it's zombie themed with a little bit of a vampire spin on it, and it's fun.
I sense
Cool.
you have this dark side to you.
There is. It's this dark side that's always, but it's always coming out in like these cute, whimsical creatures. I don't know. I don't know what's going on.
All right, so in Unity, let me show you real quick a new project. And again, for the folks that are brand new to Unity here, Unity 5 brings a little bit different interface too. Unity is a 3D engine, but also supports 2D, which really is still a 3D environment. Just it sets up a couple defaults that make it easier to work in 2D. You can always switch back and forth. So let me do 3D here and simple Unity project. You get some asset packages to start, and you can check all these off or not. I highly recommend not. These are essentially, if you've used Visual Studio before, think of NuGet packages that you would bring into your solution. These are all pre-packaged bundles. Think of stuff you would get from the Unity Asset Store. Unity gives you a bunch that are there by default, and some things that you install or add themselves here. So for example, Modern Weapons Pack. You can see all stuff that I've downloaded already from the Asset Store shows up in here, so I can just quickly check them off. You don't have to check off anything here. You can always do that later on. So I'm going to actually just not check off anything here and create this project.
Very cool.
And once this loads up, Unity will always reload its interface. It closes out, so it didn't crash on you. It closes out, reopens again to initialize the environment. And it is a pretty basic looking system, but as you'll see today, we can do some incredibly powerful things in it. Let's talk about the interface very fast. Right here is your scene view. This is your design surface. So the levels that you're going to create, you do it inside of here. And let's kind of let's go back to our default view here. So layout, default. At any point in time, if you mess up your windows, I like to show this to people because some people don't know this is there, even though it's right in front of your face. But sometimes that's the most, I think, hidden area is when it stares you right in the face.
Yeah.
If you mess up your interface, which you are bound to do at some point in time, I'm always popping my windows out in Visual Studio and in Unity on accident. Layout, default, we're kind of back to normal here. So this is our scene view. We click on play. It's compiled our game behind the scenes, and we're running our game. And we can't interact with it. We don't have anything in our game. We're gonna build out a couple things. As I mentioned, Matt is going to prototype out the level a little bit.
Yep.
So we've got some things to look at there. Make sure you get out of play mode here. In any Unity demo, I always talk about this. So if you've seen my other demos, you're like, why is he talking about this again? This is extremely important. Edit, preferences, colors, play mode tint. I like to change my interface a little bit different color when I play my game, because then I know I'm playing my game. And you think, well, isn't that obvious? Not always.
That's a huge help. I mean, there's so many times that when I'm using Unity, if I don't have those colors enabled, where I can kind of see that I'm in a separate play mode, you'll make a lot of different changes and edits, and you won't realize you're actually in play mode. And the problem is, when you're in play mode, I think it's like 90% of the time, most of those changes do not come through. They're just kind of on-the-fly changes to let you test while you're playing the game. So you want to have that color set up so you know you're in a separate mode. It just really helps visually.
Definitely.
You'll forget. If you don't have it set up, you definitely will forget. So it's good to have that color there. So right when you hit play, you know that, hey, I'm in a different mode. I like to use like red. Some people use like a yellow.
Yeah, the yellow shows up, I think, a little better on camera here than the red. I used to use red all the time. And so if we notice, I'm in play mode right now. If I'm not tinting yellow, I might forget about it. And I come in here. I'm going to create just a couple of, I don't know, a sphere, a cube. The important thing is I'm making changes to my scene. I get out of play mode, they all disappear. So play mode is a temporary playground for you to test your game. Very important setting. Down here, this is your Project Explorer. This maps to a folder on your file system. Unity projects always, always, always are in the Assets folder. I typically say don't mess with this folder structure here unless you know what you're doing. If you go to Source Control, which we'll talk about shortly, you really only care about the Assets and Project Settings folder. Don't mess with these folders, again, unless you know what you're doing. So I'm going to close that out here. Everything is underneath the Assets folder. So anything you bring into your project is going to always build in their assets. You're not going to rename assets. Everything goes into there. So this is essentially synonymous to your Solution Explorer, in a sense, inside of Visual Studio. So we have our Scene tab, our Design Surface, our Game tab. This is when we're playing our game. And over here in our hierarchy, this is anything that's currently in our scene. So let me go ahead, 3D object. I'll create that cube again, double-click on it to bring it into focus. Now I have all of its properties here. This is an important concept known as a game object. Everything in your scene here is a game object, with the only exception being this skybox, which we're going to talk about in the next module in the background here, and the changes that came in Unity 5 for those. And what we'll notice is that an actual game object itself is very basic. It has a name, a tag, which is just a text string that you can use to search for objects in code. For example, I can say, hey, Unity, give me the object tagged player. Names can change at runtime, so we typically ask for objects by tags. You can search for objects by name. It's a little bit slower operation as well. But so you have a name, a tag, and a transform, the most important property in Unity. This is a position. Notice as I take my cube here, its position changes. I can rotate it, click on my little lines here, and I can scale it out. So position, rotation, and scale is the transform, very important property. Every game object has those properties. Even an empty game object has those properties. And all of your game objects come to life through components. And we talked about this quite a bit in depth in our first one. Again, this is just a quick kind of a refresher on the Unity interface here. And if I take any other object here and add it, so for example, if I add a button, we're going to talk about UI later on today. So if I add a button to my screen here and I look at that button, that is also a game object. Everything here is a game object. Now, if I want code in my project, create a C# script, test script, we'll call that. And by default, the editor is MonoDevelop. We can take code and just assign it to game objects, just like this, if I want that code to run on that cube.
Simple drag and drop.
There we go, drag and drop it. There's like 4 ways you can add it. You can drag it, drop here. You can actually drag it up into your scene onto a game object. You can bring it over here. You can actually add it through here, or drag and drop it this little area. All different ways you can add it. And lastly, you have this 2D button. So again, Unity is a 3D system at heart. If we look at the project we're going to work with today, we can see this is full 3D. I have this 2D button, which just fixes me to X and Y. Just see, I can't rotate. I can only move left and right. This is very good for when you're dealing with projects like, let's actually show the 2D project.
Yeah.
The 2D version of this 3D game.
Which actually, the 3D one kind of looks cool. In
Yeah.
the 2D version, now that I'm looking at it, a little orthographic view there.
So the cool thing is both of these projects will be open source on my GitHub account. Again, I'll be putting up that URL in the next module here. And let's take our 2D project and just kind of show you that real quick here. Just so you can see, I think it's kind of cool to look at the 2D settings here. Give that 1 second to load up. There we go. maximize on play. My resolution might be a little off on this. You might see some black bars on the side here. But yeah, so that's the...
it's the original version of VampKid.
And one of the things that we're going to be doing in the wow factor module is when our VampKid dies today, notice when I hit a zombie here, boom, blows up in these little bats, these little animated bats. So we actually have that in the 3D project as well. So you'll see some overlap between these two projects. But the point I want to show you here is in 2D mode, let's double click on an object here. Notice it's still 3D. It's just a thin plane in 3D space. So this is just a helper button just to lock you to 2D while you're working this interface.
Yeah, now everything in 2D space, it's essentially flattened on a plane, like you said. I think there's a canvas that actually appears in your project where you can actually put all your elements. But the way it works is it deals with sorting. So 2D elements, when you start applying them, when you start building a 2D project, you can actually add sorting layers. So in essence, they are all flattened, but sorting basically tells the camera on which to render in a certain order. So you get the feeling of depth and different things by using the sorting order.
Yep, very important on cameras. We're going to talk about layers and sorting layers when we go over everything I wish they told me about cameras. I think that was the name of that one. Yeah. Everything I wish they told me about cameras. All right, so real basic Unity overview there. Actually, I'll do one last thing here before we kind of continue on. And let's take that script that I assigned to my cube, was it? Just to show you the defaults, if you download Unity now and install it, let's go back to MonoDevelop here. MonoDevelop is the cross-platform editor that's installed. So if you load this on a Mac, for example, this is the editor that you're going to get. Visual Studio is not available on a Mac right now, so if you load this up, this is what you're going to get. And also, if you install it on a PC, this is what you're going to get by default. We're going to change it up shortly, though. And also, we announced a month or two ago, pretty special relationship that we're going to have with Unity, and one of the options on install is going to be being able to select Visual Studio Community Edition during your Unity install. So that gets all set up for you by default.
Very cool.
All right, so when this starts up, debug.log, starting up. Who's starting up? How do we know who's starting up? Game object dot name. So this says whatever game object we're assigned to, you're going to find this name out right here. So let's go ahead and see what happens when we start. You'll notice there's a brief delay when we go back to Unity. If you saw the icon spin there, the mouse pointer. Let's play this. This super exciting game that we have here. First time I opened up Unity's interface, I was like, now what? Because you can see all these really cool things that you do. If we look in the console window here, which you can always load through Window Console, it's not there by default. Also, if you click on this little line at the bottom of the screen there, that will load up the console window as well. Sometimes there's error messages that you won't see unless you're actually looking at the very bottom of your screen there. You click on them, and it opens up the console window. And it says starting up, forgot a space there, starting up cube. If I take that game object and I assign it to anything else, let's I'll put it on my directional light, and I'll put one on my main camera as well. Click on play, and I should see 3 of those debug statements now. There we go. Starting up camera, directional light, and cube. Real easy to create code and assign it to game objects. And with that, let's move on and talk about using the Visual Studio tools for Unity. This MonoDevelop is here, Unity's here, and it uses a Mono Soft Debugger interface to talk between the two of them. So you edit your code, but then when you want to debug, you can actually attach to this virtual interface running inside of Unity and debug inside that little virtual environment. When you click play in play mode, you can connect the debugger into that virtual environment. So out of the box, that worked with MonoDevelop. Syntax Tree developed a wrap around this for Visual Studio. And they used to sell it, and then we bought the company and turned it on and released it for free and branded this as the Visual Studio Tools for Unity. So in order to do that, you search for Visual Studio Tools for Unity on the net, and you download the version appropriate to whatever Visual Studio you have. It does not work with Visual Studio Express, which I think we've kind of deprecated now because we have released Visual Studio Community Edition. Community Edition is a pretty full-featured version of Visual Studio that supports plugins, which Express did not, and therefore makes you be able to use this with Express. You needed the retail version of Visual Studio. You couldn't use it with Express, so this was a really cool move, I think, that we did here.
Very cool.
So Visual Studio Tools for Unity. This allows you to use Visual Studio to not only edit, because with Unity you can literally use Notepad if you want to edit your code. This allows you to edit and debug your code as well. And I think it does a better job than MonoDevelop at debugging. There's some things that show up better in Visual Studio.
Coming from an artist side who's just starting to learn programming, I have to say that Visual Studio is just it's so much easier for me to use than MonoDevelop. Not to say MonoDevelop's bad. It's just
more full
it's just a little more intuitive. There's a lot. There's features. It kind of even assists you while you're writing code. It kind of gives you the definition.
Good auto completion and IntelliSense.
So really good. If you're starting out, I'd highly recommend it. It's just going to help you a lot with your code and making sure you get your syntax proper and all that kind of stuff.
That's right.
It's good.
And you can get third-party plugins that integrate with Visual Studio, which I use as part of my daily workflow. Some really nice plugins. So Visual Studio tools for Unity gives you shader syntax highlighting. Code templates, which I'll show you in a second. A lot of folks that even use Visual Studio tools for Unity don't know about the code templates. IntelliSense, which is essentially the auto completion for you. The recommendations, code completions. Full debugging support, and in some cases, better debug visualization than what MonoDevelop provides you, and a better debugging experience overall. So, Visual Studio, Unity, two separate products. Visual Studio Tools for Unity is the bridge that goes between them, and it underlying uses the same thing that MonoDevelop uses to talk back to Unity. It's this Mono Soft Debugger interface, so it's not like everything was rewritten again. It's a wrapper around the Mono Soft Debugger interface, and with a plugin that allows it to work inside of Visual Studio. Let's look at Visual Studio Tools for Unity. I'm going to assume that you have downloaded it and installed it onto your system. And let's go over here. Once you install it on your system, it's good from the Visual Studio side. Now, on every single Unity project that you need it in, you need to bring it into that solution. And the way that you do that is Assets, Import Package, and it'll show up here. If you've just installed it, close Unity out and reopen it. These map to just a folder on your file system. You can actually drop any .unity package file in there, and it will show up in this folder. So Visual Studio 2015 tools, I will import it into my project. It brings in just two files here. And we'll see those show up in my project interface here. Give that a second to finish. It's going to import those, compile, and you'll notice a Visual Studio Tools menu pops up there. One note, if you're just starting out using Unity and maybe you're bringing in broken code into your project, you're downloading some code off the net that might not work, and you're dragging and dropping it in your project, both with MonoDevelop and Visual Studio, Unity will not generate the proper project files for you unless your code compiles the first time. Once you've already gotten around that, it's already generated your project files for you, and you can double-click and open code. But it's a common kind of beginner trap. You load Unity up, drag and drop some things that you got from the net. The code doesn't work. You can't open it up. You get errors. Note that you kind of have to have that first project that gets created for you, and then go ahead and bring things in. So I've got a real simple script here. If I had noticed under Edit, Preferences, External Tools, which is where I could configure Notepad if I wanted to edit my code with, if you like painful things like that. MonoDevelop, which was the default, now it's Unity vs.openFile. So I'm going to X that out. If I double-click on my code now, voila. Visual Studio is loading up. Now you'll notice I'm running the enterprise version here. This experience is the exact same with Visual Studio Community Edition as well. There's no difference here whatsoever. This is the release candidate for Visual Studio 2015. This looks the exact same in 2013 and 2012 as well. The process is all the same. Give this a second. It's going to load up, and I have some additional Visual Studio plugins in here, so just take 1 minute to kind of initialize. While that's doing that, I just want to talk about when you click on a script file here in Unity, notice on the right-hand side here, you can see your code. This is just a little preview. You don't edit it over here. This just kind of gives you a little bit of a preview there. All right, let's go back to the Visual Studio side here. And if you notice, there's this Assets folder here. And this, for folks that are used to using Visual Studio, you might be just saying, well, can I just compile my program and run it here? No, because this is meant to work in conjunction with Unity. So let's open up that script, and I'll show you what I mean here. There's my debug.log. I'll set a breakpoint here, so it'll stop on execution. Now notice, instead of like deploy to local machine, there's attached to Unity here. So I can attach Unity and play. I'm just going to attach Unity first. There we go. This is all set to go. All I do, this is waiting for me now. I go over to Unity. I can still design, do all my stuff in the environment here. When I click on play, compiles everything, and then I should see the breakpoint get hit inside of Visual Studio here. You notice a brief delay as it's starting up. There we go. Starting up GameObject.name. Get all the full debugging support here I would expect inside of Visual Studio. Works great. Increase that a little bit. Just continue. Or if I stop, this is important to note, if I stop, this does not kill Unity. This just stops my debugging session. My game is actually still running inside of Unity. So a slightly different workflow than you may have been used to if you're just using Visual Studio to develop an application. Works well. And again, you can come over here and make all your changes and just attach to Unity, and you get all of these game object. Notice all of the autocomplete here, all of your methods, get component. You can see everything here. If you forget code methods inside of Unity, so we created a basic project, and we got a start method and an update. Start gets called on any game object, any game object you're assigned to when that object starts up. Since these objects these code files that are assigned to game objects don't have regular constructors, use a start or an awake method. Awake gets called before start. Awake typically used to find other components within this game object. So, for example, if I wanted a reference to a box collider, I could get that inside of my awake method. Void awake. Get component. So I'm saying, hey, on this particular game object, can you do me a favor and give me in code a reference to that box collider, and then I can alter its properties in code. So very easy to do. Typically, you'll see that done in the awake method. Some folks do that in the start method as well. The important point here is there are no constructors. Update gets called every frame. If your game's running at 60 frames a second, this is going to get called 60 times a second. But one thing I want to show you with the Visual Studio tools for Unity is Control-Shift-M. Think M for mono behavior. Control-Shift-M. So if I want to detect when whatever game object I'm on has collided with something, assuming I have set up physics for that object, I can say Control-Shift-M, and I get all of the Unity mono behavior methods. In other words, all the methods that Unity understands that I can look for if certain criteria are met. So for example, I want to know when this object has collided with something. Now, if you know the method signatures by heart for all of them, you can type them out.
It's really helpful having it.
I forget them, yes, because there's some things get a little confusing. Like, for example, on trigger enter takes a collider, but on collision enter takes a collision object. So kind of remembering which one gets what when, I can just say OK, and it generates the method for me. Boom.
I think it's funny because when I first started coding, that was one of my big problems I was always having was the collision and collider methods. I couldn't exactly distinguish. I was like, why isn't this working? It was because they're so similar.
Yep.
But having that's a perfect example of why Visual Studio Tools it's awesome having all those definitions right there, so you can just see them and click what you need, and it just works great.
And now notice one difference: the Visual Studio Tools for Unity, they make this public. This does not have to be public for object-oriented purposes. I want this to actually be private, so I'm just taking off the public. From a functional standpoint, it doesn't actually matter either way. Behind the scenes, Unity uses reflection, a process where it can inspect its own code, and it will look to see if you have these particular methods implemented and call them if certain criteria are met. For example, in this case, it's when two objects that have a collider on them hit each other. It will look at those objects and look on the code on those objects and say, hey, do any of those objects have on collision enter defined? And if so, we'll call it now. So very, very easy. Again, I don't want to go through all the code methods here. I just want to show you the Visual Studio Tools for Unity and Control-Shift-M. Also a great feature of Visual Studio. Let's say I just kind of mess this all up, especially when you paste in code from the net. Control-K, and while you're still holding down Control, so Control, I'm holding Control down, I press K, and then let go K, and I press D. Formats my code. This is awesome for when you download messed up code from the net. And this is one area I think Visual Studio does a far better job than MonoDevelop and Control-KD. MonoDevelop you can format. I just like the formatting that Visual Studio provides a little bit better. All right.
Cool.
Let's talk real quick about some of the workflow that we use when we develop games. We start out with a game design document. You'll find that folks, if they do game development for others, maybe that might be a statement of work instead of a game design document. A game design document we'll get to in 1 second. Then we prototype out our level and characters, and we'll look at that here. And almost always, it's a mix of stuff that we create as well as other things from the asset store. Again, it's a very common thing that for professional studios to use a lot of things from the asset store. It might not be models, because they might be having their own artists, like Matt, for example, create those models.
Yep.
But it might be other scripts, editor scripts to plug into Unity's interface. You can extend the whole interface through scripts to make your own tool set inside of there.
Yep.
You can get audio files. I mean, really, really cool stuff on there. I don't want to beat that to death, but so after we prototype, we commit to source control and repeat. And we'll look at source control here in 1 second. Let's talk about the game design document. Ideally, it's really good to start with one. This is the blueprint of your game. This can change.
Every game that you design, you always just want to get in the habit of creating that initial game design concept, right? Just putting it down in black and white to kind of really give you a vision of the concept. And then from there, you can start adding your details like, hiring artists or kind of sketching out like the different elements of the game that you want to complete. You want to flesh out all the areas of how the game is going to work, how it's going to control, what type of experience is the user playing the game going to get. All that you really want to flesh out, and it's just good to have it in black and white because as
something
you start
to refer to.
Yeah, something to refer to. That's kind of your
Are we on track?
Yeah, are we on track?
Yeah.
Exactly. Because you'll hear a lot of times in game development, they call it feature creep, right? Where you'll get going, and Unity's one of these engines that you can really start going crazy and doing a bunch of really cool stuff. But that can be good and bad, right?
It's like herding kittens, right?
Yeah, exactly.
You start here, you're like, oh, this is a cool feature. Oh, look at this.
Exactly. So you can really start going off on a tangent, but those take time, right? And so at the end of the day, if you're trying to deliver a product, the one thing you want to do and just get in the habit of doing is keep it on track. And how you do that is with a game design document, right? So, and there are times where, you'll come up with a feature and absolutely we have to put this feature in the game. And that's going to happen. And that's going to happen organically, especially in indie game development. But I would say more times than not, you want to stick to that game design document just to keep you focused and on track. And plus, it's going to give you'll know the vision right off the bat. You know what you're trying to complete.
It's easy.
Yeah, you want
easy to get lost without one. Good idea to have one.
Absolutely.
Describes the gameplay, the mechanics, the storyline. You'll see that some have quite a long document, and that's fine. Some folks prefer a single page. Think of this as kind of a resume. Some recommend that a resume should be a single page, and there are others that say, no, if you have the experience, we don't care that you have a 38-page
Absolutely. And there's a
3-page resume.
And if you're kind of unsure as to how to create a game design document, there are a ton of examples online. I mean, if you just Google game design document, you'll see a ton of templates that people have written, things you can download, just kind of like things to follow along when you create your own game design document. In fact, I have one here on my screen. This was just something I found online. And
as luck would have it.
Started to tailor it to the game we're creating. But this kind of has some key points you want to see in here. So you want to start with the title of your game, game design document, and then put your copyright information.
Boring legal stuff.
Boring legal stuff, exactly. Yep. And then from there, all the things that are pertinent to your game, like your game design, the summary, the gameplay, the mindset.
Can you crank up that font size a little bit?
Oh yeah, absolutely. Let's see. There we go.
Perfect.
So yeah, you want to get in the habit of these are very important things that you're going to have when you start creating your game. What is the game about? How's the game going to play? Getting into the technical aspects of the game regarding the controls, the screen, the devices, the themes of the game, the flow of the game, and then start getting into the actual development, the pieces you need of the game. How long is it going to take? All that stuff, and you really want to define all those elements out. And it's just, like we said before, it's just something really great you want to refer back to as you're creating your game. For example, for the Vamp Kid stuff, I'll just show you real quick. This was kind of some of the initial art assets that we created to kind of get the vision across, right? And these are just doodles, right? These aren't anything crazy, but this is a good kind of starting point. Like, okay, we wanted to create a quick game, trying to come up with an interesting idea for what we're trying to do.
Sometimes they'll have coffee and ketchup on them.
Exactly. Start jotting down some ideas, right? Maybe throwing a little quick Photoshop rework on them just to kind of make them look a little better. And you can use that in your game design document too. I mean, don't be afraid to throw sketches in there. It doesn't have to be like it's not a production piece. It's more of it's a preliminary.
Even if you're not an artist.
Yeah, you don't have to be an artist. Exactly. You just got to get your thoughts down. And that's kind of what I do when I'm creating games. We thought, okay, we want to have this kid vampire who shoots fireballs and he fights zombies, right? What else is there going to be? There's going to be bats and skulls and coins, things like that. You just want to start kind of getting those images down. making them work, throwing them into the game design document, and getting that vision together. From there, you can even go in and prototype, what are some of the level piece is going to look like. So for here, we kind of sat there and said, okay, what kind of stuff do we want? We want platforms. Okay, we've got, these kind of graveyard-esque platforms he's going to jump on with dead trees, and we want castle pieces he can jump on, all that kind of stuff. So you just kind of want to sit there and start, kind of getting these elements down and, take your time with it. You don't have to rush, right? I mean, if it's a really great idea that you want to do, take your time and just kind of put it all together. So in theory, that's kind of where you want to start with the game design document. You want to start with sketches, an overall concept, and then you just want to start fleshing it out and putting it in an actual document and making it all make sense, right? Getting all the elements you need, putting everything together. And, it might seem boring, but at the end of the day, it's really, really going to help you, especially if you're planning on hiring outsources, getting a team together. This is a document that you can give to everybody on your team so everybody's on the same page. It's just kind of that really ultra important starting point for any project.
Very cool.
Yeah.
All right, let me go back to, let's jump around a slight bit here and talk about Unity standard assets. Matt's going to do some cool stuff with prototyping out the level, and I want to talk to you about what Unity provides as a basis that you can start from. Now, there's lots of sample projects out there you can use, lots of stuff in the Unity Asset Store. You'll find some cool tutorials on their site you can use. The sample assets they provide give you something to start out with. In fact, this is what we based our character on today.
Yep.
So let's look at that. There's two ways of getting the sample assets. The first is going through the Asset Store and standard server version update. Okay. Reload that. So notice, and there's two different versions. One is for Unity 4.6, and one is for 5, which we've been at 5 for a little bit now. If you download it from the Asset Store, you can pick and choose which little pieces that you want to bring into your project. If you, let me rephrase that. The other way around, actually. If you download them from Unity's website and you install them from there, they show up as all these different pieces that you can pick and choose from. Characters, cross-platform input, which we're going to look at today, and characters. If you download it from the Asset Store, by default is going to bring everything into your project, which is what this one is here. So if you want to look at how everything is laid out, download it from the Asset Store. So notice here we have a 2D character controller. Let's play this one here, and let me set maximize when played so you get the best real estate possible on your end. So if you want to see how they do the 2D animations here, how they tie this all together, right? It's basic, but gives you a really good starting point. Swap out the assets, swap out your images. If you want to look at, for example, aircraft, jet, 2-axis controller, or even AI, one that kind of flies itself around. They've come a long way. The last one was, the prior version was simply a character controller, third-person, first-person character controller. Now they've got a jet, they've got a car.
Yeah.
Cool particle effects here you can use in your own games. And you can take these assets, use these assets in your own games, of course. That's why Unity provides this to you. We built what we're looking at today on character third-person and character first-person. So you'll notice they have this guy called Ethan, and they give you some animations to start. Ethan can run around, he can jump, he understands some physics. Right? Can't really go through the wall there. And then we have this free-looking camera rig that follows him around here.
Has some basic collision on it.
Has some basic stuff on there, right? Kind of a wall avoidance there, so I can't get really trapped inside the wall. Basic stuff. That's what we use today. We essentially swapped out Ethan. Sorry, Ethan. And then we customized the controller a little bit. So to make it a little bit better for a 3D platformer. Still not complete. We're still working on it. So you'll find on the GitHub site that we're going to post, we'll constantly have revisions out there. There's also a first-person controller here. And to use these, it's extremely easy. So granted, these are fully set up scenes. But if you want to use these, let's do a new scene. I'll create a terrain. On that terrain, let me add just something so we can see it here. One of my favorite basic textures of all time, grass and rock. And under prefabs, prefabricated units that we can use in our game, the prefabs folder, if we look in here, Let's see, we've got, that's our sample scenes, standard assets, prefabs. Under our characters, let's do a first-person controller prefab. So we've got two different kinds here. One understands physics a little bit better than the other one. I'm going to use the first-person controller here and move it up so it's not stuck in the middle of my scene. Literally drag and drop, now we have a guy, we can run around, press space bar, use all the standard ASDW keys, our arrow keys, and now we're just following to our doom. Really, really easy to use to integrate. So those are the sample assets. Again, check those out. It's what we use today to start the level out. In turn, we had Matt kind of prototype some of the stuff on his end.
Yep.
And then, so Matt, why don't you take us over to some of the stuff on prototyping the level out?
Absolutely. So when you think about your level, when you're creating something like a platformer, for example, you want to think about, first of all, optimization, right? I always like to start low when it comes to environment stuff and then kind of pick and choose my details, which is different from characters. Characters, you kind of want to go high and then go low. I like to start low and then go high because it just gives me a good baseline to kind of white wall out an environment and kind of just prototype something quick and dirty, but have it make sense, right? Also, if you're doing a mobile game, it's good to start low too because you're just going to have good optimization, and then from there you can kind of pick and choose your battles or just keep adding stuff onto it to kind of give it more detail. So with that being said, if we take a look at the project, in here you'll notice that we have a bunch of different platforms, right? So we wanted to do a platformer, and so I kind of went crazy with platforms, and we have all kinds of different ones. We have straightaways, we've got curved platforms, we've got little wobbly paths, we have these kind of stacked structures, even these little like jumping areas that are all kind of stacked, all kind of different. But the beauty of what I did with every single one of these, and a great way to kind of initially prototype a lot of pieces that you can use for your own levels, is every single one of these pieces is basically using the exact same texture, okay? And you want to get into the habit of doing that, and that's basically a really good kind of initial fundamental learning for optimization for your games, right? So yeah, we looks like we have all these different pieces and every single one of them has a path and whatever, right? But they're all using the same texture, and let me show you what I did with my texture. So
texture is like a paintbrush.
Yeah, exactly. So in Photoshop, right, I started with kind of my 1024 by 1024 piece of artwork. That's my canvas, right? And then from there, I divided it in half, 512 by 512. I thought about my platforms and how they were going to be constructed and repeated. And so the right side of my artwork, which would be this side right here, is the top path that you would run on, right? And so if I created a structure and I UV mapped this part to the top of my path as I repeated and made that, you know, particular object longer or shorter or whatever, I know I can repeat this indefinitely in the y-axis and it's always going to match up, right? So what I did was I made sure that the bottom and the top in Photoshop, using your polar coordinates, you went in and basically I have stitched this so it repeats forever, right? I did the same on the side right here. So if I think about my objects, and we'll actually go into Maya so I can give you a better idea of what I'm talking about here. But here's my simple object, right? You'll notice from this texture, if I can pull it up here on the side so you can see it, right?
Just real quick, because I know we're kind of running short on time.
Yeah.
I don't want to derail you too much here. When you create a repeating texture like that, how do you make sure that your edges line up?
Okay, good question, actually. In Photoshop, I just go, it's filter offset edges, right? And so if you're using 1024 by 1024, you're just going to set that to 512 by 512, and that will give you a perfect grid that you can just go in and stitch together and use the clone tool to kind of fix up.
Cool.
Right? Let's see. And actually, I wonder if I have Photoshop open. Yeah, here you go. Okay. So this is a repeatable texture right here, right? And let's say I'm just going to mess it up real quick because I want to be able to repeat this, and we'll just paint this green, right? And we'll go off the edge right here, so we know for sure that that's not going to line up, right?
Yeah.
If I did want that to repeat, I would go into Filter, Other, Offset, right? I think this was 2048 by 2048 was my initial size, so I want to set it the half of that to get those grid on the side. So I go 1024 by 1024, and you'll notice once I do that, you're going to see those lines, right? Because I painted off the edge. That was the edge of my document. Basically shifted it over, right? So from there, I know that, okay, I just have to stitch those elements that are, not exactly repeating. So I can go into, let's say, my clone tool, and in here you go press something like Alt, right? Grab another texture from another part of your texture, and then just come in and kind of paint over those seams, right? And really what you want to do is start eliminating those seams. So you can come in and kind of blend this together. And that's initially how you would make a repeatable texture pretty easily, right?
Neat. Cool.
And if you have more extreme cases, right, or more extreme things happening,
and...
yeah, you do a lot more touch-up and stuff like that.
Gotcha.
But, yeah, use the offset function, go in, kind of fix your seams, you're good to go. So from there, if we look at this texture, right, you'll see the top of it is that repeating part right here, and the sides is this kind of rocky pattern that I have repeating around and around, right? Once you get a basic piece like this, I know it doesn't exactly line up on the seams right there, but that's okay. Using your artistic prowess later, you can actually go in and fix those seams by sticking rocks on there, adding, you know, like a transparency, like brush, whatever. Those will kind of fix, you know, those edges. Add more brush, rocks on the side right here. You can really dress it up. But from this initial piece, we got this basic piece right here. I can start adding subdivisions. Right, so I go into my mesh tools, go into insert edge loop, start adding subdivisions, and then from there I can really start tweaking my piece. So if I go in and I'll just grab some things right here, I can start pulling it out.
So why are you adding the subdivisions?
So I add subdivisions so I'm able to modify the look of my piece, right? And by doing that, and the more subdivisions you add, and it started as this basic kind of rectangular block, right? But from there,
kind of like joints in a sense.
Yeah, and the more you add, the more smooth of a line you're going to get, and different things, right? But from there, it gives me the ability to start tweaking those pieces to make a variety of different pieces, right? So, like I said, I'm only using that one texture, but I'm using those repeatable maps to do a variety of things. So this one, I kind of added a bunch of subdivisions and had it go around in a circle, right? This one, the same thing, a little platform. This one was kind of a snake curve I made. You can see all the little subdivisions in there, but they all started out as this
same 1024
basic piece. Exactly. So from there, from one little piece, you can get a whole bunch of variety of different pieces you can use in your game. And then once you get those done and you've started creating these individual pieces, you just export them out of Unity, or out of Maya or Blender, whatever program you're using. Fundamentally, it's the exact same in every program. You're going to do it. I would essentially create something exactly the same way I'm doing it here. But from there, export them out as FBXs, which you want to get in the habit of doing. You can use Maya files.
Or Blender files.
Or Blender in Unity. Yeah, you can. But the problem is if you're working with a variety of artists or you want people to edit it in the future, you might have problems because they might not have the software where they use like 3D Studio Max versus Maya.
It's got to be installed on the machine to be able to.
So you want to get in the habit of using a standard 3D format like FBX, right? I guess FBX you can consider as kind of the PNG of the 3D world, right? So from there, you export your FBX, you bring it into to Unity, and then you'll be able to have all these different prefabs, and I'll go into my folder here so you can see everything I have. All these different prefabs that you can start using to construct your level, right? And we can kind of see them right here on the side.
So those are all the different FBXs that you exported from Maya.
From Maya, brought them into Unity, and now I've got all these really great pieces that I can use to build my level out.
Just take those, drag, drop up in your scene, and...
Yep. And, as long as you're setting these to static, your draw calls, you're going to have a major, major improvement because it's going to batch all this together. It's only using one material and one texture, so you're going to get massive performance gains by having all of these different pieces using one texture.
When we talked about kind of the different paintbrush approach, so to say, every time that you paint a texture, think of your graphics hardware has to switch paintbrushes. And it's an expensive operation. And there's only a certain amount of time that it can do it before you start kind of getting this backlog of batches or draw calls, so to say. And so ideally you want to get as much drawn out that shares the same texture at one time. Now in our last MV that we did, we had about an hour and a half module on optimizing your games and reducing draw calls, things like that. Check that out. But the idea is here that by sharing the same texture, all those different platforms can be painted all at once with one draw call. Very, very efficient.
And one thing to note, too, when you do bring in these 3D objects into Unity, one thing we've noticed, always make sure in your import settings, if you look at my screen here, you'll see on the side right here, you'll have your scale factor, which should be set in your 3D program, whatever that is. I have it set to scale factor 1, which is basically the unit size of I'm using meters for Unity. So make sure you have it set to meters in whatever program you're using. But from there, you always want to make sure that, and I don't have it set on here, but you want to click Generate Light Map UVs on each one of the objects that you bring in. And when you do that, Unity will try to figure out your UVs for you if you don't have that selected.
Define what a UV is, because when I first started, I was like, what is a UV? Ultraviolet light?
Yeah. Essentially, it is the UV space, right? It is essentially the texture space on your 3D object.
Instead of like X and Y, they use U and V, right?
U and V, yeah. And basically, that just is the texture coordinates that are on your specific object. So the faces on your 3D object, you're basically mapping those to a point on a texture. Right, that's essentially what UV mapping is. So from there, you want to bring your objects in, but make sure that Generate Light Map UVs is selected, because when you do that, it's going to use the UV shells that you've unwrapped on each of your models, and you're just going to get a better result in
the stuff you've already created.
Yeah. When Unity tries to figure it out for you, sometimes you're going to get weird artifacts and different things on your...
Light might not show up right. Things might be kind of transparent at times.
Yeah, and you'll notice that too. If you start building a lot of your own assets and bringing them in and lighting them, you'll start seeing kind of weird artifacts when you do baking and things like that. So if you make sure that when you bring as just a rule of thumb, I always do it, but when I use my own UV shells and I generate light map UVs, I just get a much better result when things start getting light mapped. So just a rule of thumb. But yeah, I mean, this is a great starting point. Just by using this simple process, as you can see, you can get all these different pieces, and then from there you can really start prototyping a level out, laying out the pieces how you want. Creating custom pieces, doing whatever. And then if things need more detail, you can always go back into a piece and start adding more detail, right? I always like to just kind of stick more things onto my elements. So, start with a really basic kind of solid shape as your base product, and then from there, then start adding more rocks and detail and fluff and brush and grass and all that kind of stuff. So that's just my process, but I think it works pretty well, and
cool.
I'll share it with you.
All right, let's move on a little bit to a couple tips here. I just want to share workflow tips. So when I work in Unity, there's a couple things that are awesome. There's a couple of things that are painful. So two real basic things that I like to do that I think will make it a little bit easier for you. And this will be posted with the code out on GitHub as well. Again, that URL will come on the next one.
Oh, and a good point too. When we do upload this project to GitHub, those FBI files are there for you. So take a look at them in your 3D program, bring them in, see exactly how I stretch my UVs and repeated things. It's really going to give you a good idea on how to create these.
Drag, drop, feel to reuse, feel to take
absolutely
our content and reuse it however you want.
Use it however you want. Reskin it, make your own textures, whatever.
As part of publicly putting out there on GitHub, it's now available to the world. So
exactly,
take advantage of that. Now, when over here, let me close this VampKit project out and go to my desktop. And you'll notice when you open a Unity project, you actually have to point it to a folder. So if I open up Unity here, and it says, hey, what project am I going to use? If I say open other, you have to point it to a folder. And that's not a Unity project. Oops, I don't want to drag and drop that. That's not a Unity project, that is. But I find that a lot of times, like, I'll keep folders on my desktop and throughout my file system and my file sharing services. And so there's a little register script that I use. Again, this will be posted out there for you guys, that I can just literally right-click and say open as Unity project on any folder. I use this probably 30 times a day, I feel. And that will just, from a command line, spawn off Unity and pass it that folder, and it just loads up for you.
Clever little addition.
Clever little thing. I just got tired of doing it, so just one day wrote it, and now I use it all the time.
That's on your GitHub?
That will be posted up there with this project.
Okay.
I'll have a little folder on there and some directions on there. It is actually on, I believe that's actually on my GitHub right now.
That's awesome.
If you go to my GitHub account, so github.com/Adam Tuliper, let's see here. I did post out some of that code recently because you can actually find it on my, let's see if this is listed up on here. I did a blog post on there. Let's just go right to completedevelopment.blogspot.com, and I think it was the most recent one there. Yeah. So you can get the code there as well. I'll post it up on GitHub too. So check that out.
That's
really easy.
Super helpful.
The second thing there, it saves.
Yeah, no, that's
it
awesome.
Seems simple, but it saves a lot of time.
Yeah.
So even if you get nothing out of today, hopefully that will that will be useful for you. Secondly, this is another script that I got offline, and let's go to the let's go to 3D project for this one. File, open project. Since it's in my history here, VampKit 3D.
So right now, you can't click on a project outside of Unity and say open in Unity.
No, because there's no solution file. There's no single file. It's a whole folder structure that Unity needs to point at. You can open up a scene file.
Yeah.
It's like, but you have to navigate into those folders, double-click on the scene file, and then Unity will say, oh, you've opened the scene file. What project does it belong to? And then it opens it up.
So this just kind of bypasses all that. From the outside, I right-click on a folder, which is my project.
Your root folder.
Open in Unity.
Boom.
That's clever. Yeah. Nice job.
Well, thank you, sir. Secondly, this is a script here, the second one that I found on the net, actually. It goes in your editor folder, and it's save on play. There's an autosave script you can find out there as well. Unity does not autosave. And what this will do is anytime that you are running your project, anytime you make changes here, let's say, Unity, just like any other tool, it's written by software developers, and we're not perfect, so you will find that things sometimes crash. It's a fact of life. It will happen in almost any program you use for a long enough time. It's going to happen at some point in time. Expect it. So idea is save early, save often. This editor script will just make it that anytime you click on play, it will auto-save everything for you. There's also Unity 5, I believe, was added under preferences here. It's probably staring me right in the face here. Hold on one second. So verify saving assets. This was another thing that you can kind of do too, which gives you a little bit more of a list. This can get annoying really fast though. Verify saving assets. So if I come in here and I just, I don't know, let's make one little change here and take something like a coin and drag it into our scene. We play, it says, hey, this has changed in your project. Do you want to save these? It's good to kind of see what you're saving, but this kind of gets annoying very fast. So I'm going to say don't save it. Close that. And get rid of that. So there's also a version of that autosave script out there, which will, or that save script, which will autosave for you every 30 seconds or minute or 5 minutes or however long you can specify. So just a little quick workflow. And last but not least, let's go to our Git workflow. There's really, really great content out there already on how to use Git, lots of it. There's kind of the joke that Git is not a disconnected tool because you need to be online to be able to read the documentation on how to use it. So I think Git's a cool tool, but it can get complicated. So I want to show you a very, very basic workflow. If you are already used to using Git, you might say, you know what, this isn't the correct workflow or this won't work for me because I work in a team environment. Fair enough. I want to show you the very basic version here. It's going to be about a 2-minute demo. There are many other ways to do this. So I'm going to show you the way of, if you go and create a project right now on like Visual Studio Online, or if you use GitHub and you have this Git URL you want to use, how we can use that. So first, when you have a GitHub project, so let's go over to something that is not yet there. So if I just right-click, Show and Explore, that basic demo that I did before, right, where we added some stuff in here. Well, let's even go a little bit more complicated. That whole standard asset demo. This has got a lot of assets inside of it here. So a lot of things in this folder. The first thing you need to do is take a gitignore file, and that will tell Git, hey, I don't want to include library. I don't want to include temp. I know there's a bunch of garbage here that I don't want to save in the source control. And so gitignore will ignore that for you. I have a specific one that I use actually for, where's my gitignore here? I will do under my source, Unity snippets .gitignore. And if you go to any of my Unity projects on GitHub, you can just reuse the one I have on there that's visible online. I'm going to take this gitignore and paste it into my project. Boom, it's there. I've got the Git tools for Windows installed. So I'm going to open that up, go to a command line here. That loads up. I'm just going to switch over to this folder. So I'm going to copy this path out, say cd that location, git init. I have now initialized it. It's created a .git folder inside of here. Git add. Most folks do git add dot, in other words, git everything. I get in the habit of doing -a because if you add and then remove files, you need -a to be able to find those files. So as a general habit, I do git add -a dot. That is telling source control about every single file that you have in here. Once we're done with that, in fact, what we can do is while that's processing, let's go over to like GitHub here and say, you know what, I want to create a new repository. my Unity project. We'll create that as public. They give you the commands. We've already run git init. I'm not going to add my README right now. I have a whole bunch of other things that I need to add there. So we're going to proceed with this one right here, git commit. Let's see if it's finished yet. So it's still adding all my assets into there. As soon as that finishes, we're going to commit. In other words, take a snapshot of everything I have there and name it something. After that, we're going to do this one-time operation to point my local system to my GitHub site. And then when I'm all ready to go, I can push my local changes up there. And then I just essentially repeat. Let's go back to my slide here because that makes it a little bit easier. So we init, we add, commit, push, and then we just repeat these 3 ones over and over and over again. It's very, very easy. Let's see if it's finished, and I will just, yeah. Let's go back to this one here, which was the much smaller one, just because, again, we are kind of getting short on time here. I'll show you how easy it is to set up, though. We go to that other fairly empty project here. We right-click, show and explore, paste in my gitignore, copy that path out, open up GitHub. The Git tool, I should say, not GitHub. cd git init, git add -a. You don't need the -a the first time, but again, I like to do it as a standard practice. Voila, we only had a few files on there. Git commit -m. My changes. There we see everything we've just done. And let's actually point the one I just created on GitHub to that guy there. I'm not going to be able to finish this just because of authentication here. Copy that out. There we go. This is taking my local snapshot I just created, my local commit I just created, and pushing it up there. Oh, actually, I am already authenticated on my Git tools here. That's why it worked. If I go over to GitHub now, look, everything's there already. If I go back to my Unity project and I change something, let me just change this location, save that as my main.unity scene, and close this out. Let's go back to the command line here. If I say git status, it says, hey, we see there's a couple things that have changed here. Let's add that. Commit it. I added a scene and move stuff. Push it up to GitHub. And as soon as this is done, I'm rubbing my hands like an evil...
When it's done.
When it's done, give that 1 second to finish, and there we go. Refresh our changes here. That's it. Simple as that.
Now, for some of you designers out there or other people who maybe are not so comfortable with command line and GitHub, there are several GUI tools available for GitHub synchronization and things like that. So I know command line sometimes can be a little foreign to some people.
Yep.
And if that is, there are tools like GitHub Windows, and I think Subversion and there's other different products out there.
So there's SourceTree. I know some folks that really like SourceTree. The Git tools for Windows, the ones through GitHub are really easy to use. It's a nice GUI, and
Yep.
you don't have to use a command line at all. So, but I just want to show you that if you're using command line, the basics of it, so you understand the command structure.
Absolutely.
The GUI tools essentially do the same thing on the back end. So very basic to use. All right. Well, that takes us to the end of this module, and then we will all see you very shortly for Module 2, where we're going to talk about new Unity 5 features.
Yep.
See you shortly.
See ya.
My name is Mark Schonagle. I'm an evangelist for Unity Technologies. Been in the industry about 20 years. Film, games, visual effects, rendering, all sorts of good stuff.
You've been an evangelist for a long time for various products and pretty cool stuff in the
long
marketplace.
time at Softimage. Spent some time at Microsoft a long time ago.
That's right.
It's great. Now,
Had lunch with Bill Gates.
I did.
Cool story there. Not for today. You have to hit them up privately for that.
Yes.
All right, today, for this module, this is since we're going to be talking about what's new, some things in Unity 5. Not necessarily a whole, not an all-encompassing what's new in Unity 5, but we're going to take some Unity 5 specific features, look at them. We're going to be talking about the standard shader, lighting, and skyboxes. Animations. Now, the animation system in Unity has existed for a while, but there's been a little bit of change there. But we're going to kind of do an animation overview and then talk about the new audio and audio mixer system as well. So I think we've got some cool stuff in this module.
Yeah, for
so
sure.
whether you are a beginner, intermediate, or whoever, hopefully this is some pretty cool new content that we're going to show you.
I think so.
All right, let's talk about the standard shader, because the standard shader is new to Unity 5, and I think it's extremely important to understand. About 75% of what we're going to cover here is somehow involving the standard shader. Why another shader? Well, I guess first, what is a shader? A shader takes typically some either color or image, and basically it's code that says, hey, here's how we're going to draw this. Maybe we want to maybe tunify it, maybe look like a cartoon, or maybe we want to make it reflective or not reflective. And Unity has a whole bunch of built-in shaders. You can see kind of on this image here, there's mobile shaders that were optimized for mobile. You've got like Tune, UI. I mean, there's so many different shaders. Why another shader? Because the idea is now to simplify this. With a standard shader, there's two of them. There's the default one, which can kind of give you metallic, and specular is the other one. And you can see them both listed here, standard and standard with the specular setup. You can make the specular setup look just like the other one as well. It's just more of a matter of what you use for your workflow. If you are brand new to Unity, it really doesn't matter one way or the other. This is really for preference. Some will choose one over the other.
I was going to say the specular setup actually allows you to make objects that are not available in the real world. You can go beyond the extremes that the real world allows, which your chart will show in a minute.
I'm trying to think of some superhero named elements.
Like Kryptonite.
Kryptonite.
There you go, Kryptonite.
If you are a shader writer, you can get the source code to the standard shader off Unity's website. In fact, you guys just released some of the assets for the Blacksmith demo, and the Blacksmith demo actually has a customized standard shader. So go check that out on Unity's website. It's a really complex and neat, beautiful-looking demo called the Blacksmith. It's about a 2-minute long, 3-minute long video that you should all watch anyway.
That was our GDC teaser. Check out Viking Village too. That's another really cool example using the standard shader.
Cool. All right, so all new materials that you're going to create inside of Unity, use it by default. So anything that you're going to render in Unity, any object that's going to display something, has a material associated with it, and a material has a shader. So if you want to display something, it needs a material, and a material has a shader to tell it how to display it. Caution when importing models. So Matt was talking earlier about the workflow going from Maya and bringing things into Unity. When you bring in things from other programs, at times you might not be using a standard shader. Now that we're moving forward on the standard shader, I like to standardize on a standard shader. And so I try to make sure that any models that I bring in, when I look at the materials assigned to them, that they're using a standard shader. The idea behind the standard shader is to give you this kind of consistent look between things. It's not necessarily to say one is maybe more realistic than the other. It's so you can use this one shader that is also good for mobile and desktop environments. It's optimized for both. If you don't use parts of the shader, as we'll look at the interface in a moment, if you don't use parts, it will optimize them out. So it's one shader, and it's kind of the same code, so it will give you this consistent look across the different ways you're using the shader. Now, here on Unity's website, you can find the shader calibration scene charts. And this gives you a good idea of what each of the standard shaders will give you. So on the left is the regular standard shader. That was the one that just said standard. In other words, that's the metallic standard shader. And it's called metallic because there's a metallic setting. And we'll actually look at this in a second here. The one on the right was the specular setup. So if we look on the left here, and we can see if we change in Unity's interface, there's actually a metallic value and a smoothness value. So just imagine for a moment these are sliders in Unity's interface, as we'll see. If we change the metallic value from 0 all the way up to 1, you can see how this object goes from not being metallic looking to really being this full reflective material at a 1. And there's a note here that almost all metals in the real world, if you're trying to simulate them here, will have a look of near 1. Metals will give you that look. Almost all non-metals will be 0. And if you go over to the specular side, you can kind of see as you come down here on smoothness, you'll notice that there's a consistent look. You can actually get a pretty similar look at times between the two of these. Smoothness value. Again, here, think of a metal ball that's been kind of sandpapered a little bit, so it's kind of a little rough. And you can see it would give you something like this. And as that kind of texture becomes smoothed out, you get more of that mirror finish. So you can control that as well.
Yeah, I was going to say, think of smoothness on more like the microscopic level.
Yeah.
Like if you really polish a chrome bumper, you get that really intense hot spot. As it gets dirty, the rays start to bounce more inconsistently, right?
There are
get that kind of diffused look on your specular.
Speaking of chrome, there are rumors that there's a particular type of car that you like and spend a lot of time with. If you saw in the Mark's intro slide, you have a 21-window.
A 21-window VW bus that I painstakingly restored to a very, very shiny specular.
You should try to reproduce that in Unity.
I will. I am.
All right. All right, let's look at the standard shader. I'm going to use the shader calibration scene to show you this. Now, this is something you can get from the Unity Asset Store. It's a package. You can load it through the website or Window Asset Store and load the shader calibration scene. The idea of the shader calibration scene is a lot of the concepts we're going to talk about today, you can bring your objects into the scene that's already set up and see how it works. Mark's going to be talking about the lighting. We just want to concentrate on just the basics here, which is the standard shader, which is going to lead us into what Mark's going to talk about shortly with global illumination and physically based rendering. All right, so let's play this and see what this looks like. Notice, as it spins around, there's this kind of dynamic shadow here and lighting. This has a particular glossiness value to it. Let's look at actually what makes this up. So here's our overall pot. And if we look at what that's made up of, we have the body and the lid. So if I look at the top level game object here, I don't have any kind of shader here, any kind of renderer. So clearly I know I need to look further. If I go to the pot body here, on the mesh renderer, which is responsible for displaying an object, notice if I uncheck that mesh renderer, it disappears. We have a material on a mesh renderer. So if I click on the material, it shows me in my project where that material is. Now remember, I said, if you want to display something, you need a material, and that material has a shader. So this object has a material, and that material has a shader here. And I can choose different shaders here. Of course, these are a lot of these, the older, and they still work just fine. But going forward, we're moving to the standard shader model. But again, these are a lot of the old ones. You can kind of see the look of them changes. Let's go back to the standard shader here. So there's standard and standard specular setup. If I go to the standard, we have a couple different maps that you can assign here. And with this, you can really customize how the shader looks. So notice right now, we have just a color assigned to this here, to the albedo. We can assign an image here as well. What we're going to look at later on with our game, like, let's go back to our game right here. And when Matt was showing like those objects before, let's take our cave, for example. If I click on this cave and I look on our mesh renderer, we see, oh, there's a cave here. Click on our cave. We're using a standard shader. But now notice, instead of here we have an albedo color and no texture assigned. Notice this is empty. Over here, we're actually white, but we have an image assigned. So there's that cave texture. If I mess with the colors here, you can notice it changes the entire overall tint. So not only can you assign a texture, but how that kind of looks in the environment here. Now going back here, let's go ahead and increase that metallic value. Now this, to kind of show you that chart again here, if we increase that metallic value, we go to more metallic looking, and increase the smoothness, we increase that reflectivity value. So let's go ahead and increase our metallic value here. So you can see we get a different look here and change our smoothness value.
This seems very physically based.
Very physically based. A normal map is a weird looking image. If you, I think we can control click to preview these. Not sure how the resolution will come across on your end. These are mostly this kind of purplish looking image, and this kind of, it's a trick that will give you depth on your objects without necessarily having to render these difficult light paths at runtime. It's a trick to basically having details on your objects here. So there's our normal map. You can do things like occlusion. You can, Mark, I've seen you do some stuff. Actually, I think you're going to show using occlusion today, right?
I am, yep.
All right, so Mark's going to show you a little bit of occlusion in a bit. emissive materials, where you can make materials essentially give off light as opposed to just kind of reflecting off light as well. So you can control a lot of these values to really change the way these objects look. If I go back to my cave, for example, and I look at that shader on this, the standard shader, and I want to make my cave metallic looking and smooth, right? It uses that cave texture but turns it into this kind of metallic looking texture on there. So really you can fine tune the way that things look. And you might import something that you get from somebody else and realize it doesn't look right at all, in which case you have to go in and kind of play around with some of these settings to get it to look the way that you want it to look. Make sense? Clear as mud?
Sweet. Clear as mud.
All right, let's go into talking about lighting in skyboxes.
Sure.
Because the standard shader kind of feeds into these values here. In Unity, we have a new skybox. Now, previously, skyboxes existed in Unity beforehand, and we could use them for some time. You want to add clouds to your world, nice blue sky scene, you add a skybox. With Unity 5, skybox is also a material, and it has a what did I say about materials? We need a shader on a material.
Yep.
So a skybox material, it has it's a material with a skybox shader. And that shader can be, you can choose a 6-sided image. So if you are a photographer, you can use 6 images and piece them together and make your own. QMap, new Unity 5 is procedural. We'll look at that shortly as well. Mark, you want to tell us a little bit about HDR skyboxes?
Sure. So HDRs are high dynamic range images. And you'd mentioned being a photographer, go out there taking 6 images. Imagine taking 6 images of the same image. So actually, I'm going to minimize my screen here real quick. And I'm going to show you guys an HDRI. So this image that we're about to see on my screen, let's get this guy to load up. There we go. Oh, what's going on here? No one doesn't want to load. All right, well, that's weird.
Come back to the slides, work on that a bit, and we'll get back to that because we're going to do some other stuff for our Skybox demo here. With the new procedural Skybox, you can also dynamically control these properties. And we're going to look at some of this here with the new procedural Skybox. So I'll start out while you get that kind of running over there.
Sure, I'm not sure what, that's not launching the HDRI viewer. All I was really going to show was what an HDRI is. So essentially what an HDRI is you take 4 or 5 different pictures of the same image. You put your camera on a tripod and just increase your f-stops. So you take one like f2, f6, f10. You put all those into a program like HDRI Shop, which munges them together and creates one high dynamic range image. You can then use that to light your scene, and it's pretty amazing what it can do because that image now contains the entire dynamic range, obviously that's why it's called that, of that day or that environment, indoor, outdoor, whatever. So, when your camera's only letting in a little bit of light, the sun is going to appear as a little tiny white hot spot, whereas the rest of the image is going to be black. As you start to let more light into your camera lens, that increases how much the visible light is in that image. So you take all that, you put it into Unity, and you have something like this. So let me just show you that here. So here I've taken that the cave scene, just kind of simplified it a little bit, and we're just using the procedural skybox right now. But if I go here and literally just grab a skybox, let me go into my skybox folder here. I've got a couple of them set up. As soon as I drop this in, look at what happened to the entire lighting of that scene. You can see we really get a very different lighting effect. And if I grab this other one here, look at that. The entire scene gets changed just by me changing that light source. If I go here to my directional light, and let's just tweak down the intensity, this illumination, every bit of the illumination except for the blue that we're seeing in the cave is being delivered by that HDRI skybox. And now I can actually go and rotate that with this slider here, and you can actually watch that light rotate around inside and around your cave. It's really cool. This gives you the ability to light a scene with an image that just instead of building a crazy light rig, you just pop a couple images in there, and there you go. If I go back to my skybox here, let's take our directional light. We've always been able to, if I crank up my directional intensity again, we've always had the ability to
scorch the earth. And
you can see I've got my hard shadows going on right now. So that's just coming from the main directional light. The skyboxes use more of like a ambient occlusion style lighting. So it's a very soft, diffused sort of a shadow that you get. Very, a lot less harsher or intense than a directional light or a spotlight shadow, but it just has this really warm look to them. So I kind of like to use both in conjunction. I like to have a directional light to kind of give me that heavy shadow, and then I use a nice skybox just to kind of fill in the nice ambient light with that. It gives all, that deferred lighting.
Let's go over to my scene here. and I'm going to go to window lighting. I already have it open, but just to show you where it's at here. So window lighting. Now Mark showed dragging and dropping into a scene. You can also see what is set. It used to be under edit render settings, I believe. Edit render settings, and you can set your skybox in there. Now in Unity 5 it's different. It's under window lighting, and the little scene here shows you your skybox material. So if I click on my skybox material, it brings me to the material in my project, which is a material. It's in .mat. Now I have to go back to my inspector to view those values. Let's close this tab out and this tab, clean this up a little bit. All right, so my skybox here, notice when I look at my skybox shader, again, a material uses a shader, there's what I can use. A 6-sided, if I want to set all my images here. If I want to set this to a cube map, I can set my cube map, or the new one here also, I can set my procedural. And with a procedural, you can control all these values in code. Let's rotate, let's increase my sun size here. There we go, there's my sun, which in this case, in this scene, kind of actually looks like a moon because of my kind of sky value here.
Out in the desert.
What's that?
Oh, out in the desert.
That was the desert, right? You're the coyotes right now. But so with a sun size, you can change this here. Atmospheric thickness, again, so this is all procedural. This is all calculating it at runtime. It's not an image that's based upon. And we can change our sky tint here as well. So let's give it like something like that. Change our sun size, so it kind of almost looks like the moon just coming up here. And you can change your exposure. Let's look over at everything here.
The exposure setting with an HDRI skybox is really powerful. I mean, it gives you, you really have all that range in that image, and the exposure value will take advantage of that.
All of these settings you can control through code. You can animate these settings. You can use these in conjunction with what Mark was showing on the rotation. So for example, if you wanted your light to move across your sky, and at the same time you wanted to change maybe your exposure like that during daylight, and over time you just wanted to animate back down like this, and change your sky color. You can control all that. So you can have essentially a whole dynamic sky system.
Absolutely.
By controlling the rotation on your light and by animating these properties here.
And with a clever script, you can actually crossfade between two HDRI skyboxes. So you can actually do like a real day to night, night to day, day to afternoon.
So you can have your sun and your clouds, and then your script will then merge that into kind of crossfade that between your moon and your dark sky, and it's pretty awesome.
Yeah, you really get those cool, you know, like you see in a lot of games nowadays. You get those night-day changes. Clouds are moving, all that stuff's happening. Your shadows are moving, and all that ambient light, the deferred lighting is also moving. It's great.
Cool. I got to see a demo. I haven't seen the merging of the two. That's pretty neat. All right, let's talk about lighting next. This all kind of leads in together here. In Unity, we have and have had 4 different types of light. So directional, which is like a sun and sky, point, spotlight, and then area light. Now, lighting is expensive. When you think about all the calculations that have to take place at runtime to render your scene, all your materials, be able to run around the 3D environment and have to calculate shadows and lighting, it is amazing what computers can do. And as such, that's why we see sometimes things don't run well, because we're always pressing limits to our hardware. So baking is a process where you try to pre-calculate how light is going to hit your scene, and you actually create images from that, textures, stores them behind the scenes, and at runtime figures out which ones to show and how it's going to show them. It's a lot more efficient.
For sure.
And Unity has included some really cool stuff for Unity 5 to help with this. And now, we got 2 concepts we're going to talk about here: physically based rendering, PBR. Not that PBR. And global illumination. There's a frosty beverage some folks refer to as PBR. That was the joke there for those that didn't get that. And if you did, I hope you're laughing at home right now. So let's talk about a little math on the slide here. I don't know how much
simple.
I don't know how much math you guys remember. We're gonna dive kind of a little deep on here. On the left-hand side, I'm just kidding.
You and I solved that earlier this morning over breakfast, right?
That's right.
Is that the one we solved?
Did.
Right.
We solved that on my old graphing calculator. So that's a simple formula that helps enable the physically based rendering. Unity 5 has added this real-time system that's enhanced by a system called Enlighten.
Yes.
And Mark, this allows us to do what kind of cool stuff?
Oh man, just like it says, allows for environment, textures, light, just the way deferred lighting, indirect lighting is going to bounce around your scene. You know, if you hold a red ball to a white wall, it's not the light that's actually, it's not lighting the wall, it's bouncing that energy off the wall, the physical base render, the PBR. So we can now do that. So I'll show you here in just a second. We can take an object and actually have it emit, it doesn't emit light, and it's hard to actually stop saying it's emitting light. It's actually emitting energy. It's emitting deferred color to that indirect lighting to that scene. It's very cool. And then it bakes it, so there's no performance hit at all. It's zero impact on the GPU.
So the idea is that you get this realistic, physically accurate look to what you're doing.
Yes.
As you mentioned earlier, there's Viking Village. So if you want to see a great example that you can download and kind of play around. So we had that kind of setup scene that I showed you before, the shader calibration scene, which does have PBR in it. Also, Viking Village is kind of the de facto sample that Unity has put out there. In fact, if we just say Unity Viking Village.
Yeah, it's a crazy cool scene. It's all LiDAR scanned, so it's laser scanned.
Yeah, so you can look at even just, we're not going to dive into the scene here, but just so you can see what kind of stuff, if you you can download that, you can look at all the assets and check that out. That is an incredible demo, so I highly recommend go to the asset store and bring in the Viking Village asset into a new empty project and explore that out. All right, what about global illumination?
Global illumination, you know, that's stuff that we used to do with ray traced rendering engines. And you would literally like wait an hour, 2 hours a frame to render, go home, have a coffee, whatever, come back. And now we can do a lot of that stuff in real time. It pre-bakes it. It can only work on static objects that are not moving in the game. But you know, any of those objects, which makes sense. If you have a wall and lighting is being affected on it, if that wall moves, you don't want that lighting information to move unless the light moves with it. You know, like a shadow is not going to move, get stuck on a wall like a decal. So it makes sense. So basically, you just mark your objects as static, and then the global illumination will automatically pick up on those objects.
And by marking them as static, like on my screen here, notice on any game object here in the upper right-hand corner, let's go ahead and just click on like this guy. Notice the static checkbox here, and there's a bunch of different types of static.
Yes.
So, Mark, you're talking about light map static?
Yep.
And then there's also, we're going to talk about navigation static today. So, yeah, there's a bunch of different static types in there. With global illumination, the idea is you're in a room, red couch, how sunlight is interacting with materials in that room, and like you said, kind of not emitting, but affecting everything else around it, right?
Yeah, it's giving off, you know, it's receiving energy, it's bouncing that energy back off, and now we're taking advantage of that energy.
Now, this is a little tip because I've come across this in development. As you change things in Unity Scene, and you might even see this as Mark's going through a demo here, Unity will constantly recalculate this information while you're designing your game. As soon as you play your game, it stops that calculation process and then resumes again until it finishes. That's a lot of information. It can make your system, I'm always running with just a few gigs left on my system. I always need bigger hard drives, and of course when I get bigger ones, I fill them up and then run out of space. So I'm always clearing stuff off, and this cache can get pretty large. And if you look inside of Unity here, under Edit, Preferences, GI Cache, Clean Cache, and it says right now, actually my cache is right now 6 gigs just about. Maximum cache size is 10 gigs. So just a little helper thing that they've added now to be able to clean that, reclaim a little bit of space on there. Just because it's helped me because I'm always running out of space. I'm sure a few of you that are listening to this are probably like me with that.
You know, with that in mind, I mean, that cache being that large just shows you how much data that it's actually computing, it's writing, it's calculating to figure these things out. So it is a lot there. If you're wondering why, you know, sometimes when you're using some of this lighting techniques, it takes a while to bake that information in. It's got to not only got to write all that data, it's got to actually process all that data and create that data. So it is a lot of stuff.
Now, when we look at something like lighting going on around a room, PBR, and global illumination, one of the things that you kind of expect to see are reflections, right? You have objects that you hope, if they're metallic, not even metallic, but some sort of reflective value to them that the environment itself is going to kind of reflect onto it. And so in order to do that inside of Unity, that you need not refraction probes, reflection probes. And these essentially are needed if you want to reflect a texture. Unity will actually show you color lights without having a reflection probe. So if I have like a metallic sphere and a green light below and a red light up top, I'll see those colors on my sphere. But if you really want to reflect textures like the inside of a cave, for example, you need a reflection probe set up.
And you're not really, you know, if you're just shining a color on an object, you're not really reflecting the light. You're actually just shining the light on there. Once you make it reflective, then we need to actually tell Unity what you want to reflect. You could fire rays infinitely, and at some point you want to tell it, hey, just reflect this environment, this part of the area.
And these are for reflecting static objects?
Any object.
Any objects?
Any objects.
Cool. All right, let's look at some lighting settings. Mark, you want to take us through a couple cool lighting settings?
Sure, absolutely. So, see what we're looking at here. I just sort of just stripped it down a little bit. Just want to show you again some lighting stuff. So what we have going on here, we have our cave. And in the back of the cave, I've got a few point lights set up. And if I actually just select all these point lights and turn them off, you can see the lights go dark and the lights come back on. So no big deal there, just standard lighting. Right now I've got this set to real-time mode, so I could bake these into the texture map of the cave if I wanted to. But what I'll show you instead is I'm going to turn that off. And I've already set the cave up here to be static. So it's already computed the light map for it. So therefore, if I go and just grab a couple spheres, and I'm just going to select these and turn them on, you can see I basically got a couple spheres here. And now you can see here at the bottom right corner of my screen, it's actually now computing the light map for these spheres on here. And you can see just how long this is going to take. It's not too terribly painful, but again, it is doing a lot of calculation. It's creating an entire light map. And once this is done, you'll see the results are pretty slick. It doesn't just compute it and then you can't tweak it anymore. So you can see right now I computed that light map. This has no performance hit anymore on the GPU, whereas before our other light sources, the more light sources you add, your frame rate starts to suffer. And now here, you have no impact at all. But we actually still see these spheres. So I'm going to show you a couple little tricks. One, if we just open up our standard shader, and you can see I'm using the non-specular setup, so I have control over my metallic and my smoothness. I have them set up to be shiny. This doesn't matter at all for this because these are actually going to be invisible by the time I'm done with them. I'm just going to turn those off. But what I can do here is change the color. So right now I'm emitting this HDRI value. This is our new color picker for emissive values. You can see it uses actually an HDRI type of a setup. And as I move this around, you can see that the lighting in my environment completely changes. I can change the color like so. Obviously, I can change the intensity if I want. So if we go back here to say like a blue, let's get it something that sort of matched what we had before. I can actually change the value of this emissive value. And here's a little tip for those of you that don't know. If you hover your mouse to the right or to the left or right of any of these value boxes here, if they don't have a slider, it gives you actually a virtual slider. See how my mouse just changes that icon? So now if I hold my left mouse button down, I can kind of scrub left and right. And you can also do this, just go right completely past the right side of the screen and just keep going. You can
First time I saw that, I was like, what?
Yeah, pretty slick, huh? And there is a limit to the maximum value that the emissive will give you. But you can animate this. You can make a cool, like we have here, glowing kind of a hallway. Throw a script on there that'll animate that. Another really cool trick is to actually just turn off, in the old days we'd call it a primary rays, but I want to turn off, I don't want to see those spheres. That looks kind of weird. So what I'll do is just go back to my shader here. I'm going to set the rendering mode to cutout, and then click on the albedo color. And down here at the bottom, this alpha channel slider. As soon as it's below 50%, boop, it disappears. And now if I unselect my spheres, they're gone, but that contribution is still there. So I can select it. I can still go tweak the amount of emissive value that's in there, and then unselect it, and that sphere then hides. So a really cool way of creating lights. There's no overhead on this at all. And
you say that was on the albedo, cutting out the...
Yeah, I'll show you that again.
Alpha?
A lot of people try to use this slider here, the alpha cutoff. It's not. You actually have to set this to cutout, click on the albedo color, and set your alpha channel down here to something below 50%. It's either on or off when you're using
50% is that magic value.
That is the magic value. And I'm going to tone that down a little bit because it's a bit ridiculous. There we go. Another cool thing we can do is set up things like bounce cards. So what I've done here is I've put an object, which I need to turn on here real quick. And right now you can see it's missing its texture map or its material color. If you're familiar with Unity, you know that purple color right there tells you, hey, something's missing. So what I'm going to do is I'm going to create a new material. So I'm just going to say game object, create material. And here I'm just going to give it, say, a color. We'll make this maybe red. And I'll also set the emissive color to red, like so. And everything looks good there. Maybe give this a name. So I'll rename this to red or whatever. It's not really that important, but call this red emissive, like so. And now if I drag and drop this material onto here, we should start to see a little bit of red spilling in there. Now I haven't cranked up my emissive value, but if I do, look at that. Now I've got a cool, nice, glowing hallway that's actually getting it from that hole in the ceiling right there. So it's really a nice way to create fill lighting. Like, if you want a nice daytime or a nighttime look to a scene, put a couple blue dark bounce cards outside, and you get that nice spill coming in like so. Another thing that we can do, which is pretty slick, is use reflection probes. Let me talk about those real quick. So we have these little coins here. If I could set my camera properly, there we go. So if I hit play on our little game here, we can see I've got these little coins as soon as it starts playing. Give it a second. There we go. So you can see we got these little coins on here, and currently there's no reflection on them. They're just sort of static, but they are gold. So why don't we make them reflective? So what I'll do here is create a game object, and reflection probes are under the light parameters. So I'm going to click on reflection probe here, and it created my probe kind of out there like so. So I'm just going to bring this in. Now the way these probes work, there's a little bit of a thought process that goes into this. You need to set this cube to a certain size that's going to capture your environment that you want. You can actually see what it's capturing right here. And what it does is it basically creates, and if you zoom in, you can actually see this, it creates a basically a texture map that it reprojects as a texture projection on all of your reflective objects. So whatever this sphere is showing right here is what's going to be projected on there. So this just gets baked as well, so it's not very intensive, it's not very CPU or GPU expensive or whatever you want to call that. The performance, it's not very great. But what you do want to do is you want to scale these reflection probes so that they encompass what you're looking for. And I actually said the wrong word there. I said scale. You really actually need to use these little dots here to actually grab your reflection probe and scale it. And you can see that every time I make a change, it'll update here in the probe once it finishes baking that. So let's give that a second, and maybe I'll just pull this back a little bit like so. And I'm going to also bring this into my cave here. So you have to click this little icon right there. So we click that. I'm going to bring this out like so. And now, if I go spin this camera around, and we take a look at our materials that are on the coin, let's just frame up on this guy. Right now, the material doesn't have any metallicness or smoothness to it. So I want this to be gold, so that's definitely going to be 100% on the metallic side. And then I could look up on the chart to find out what the actual value is for gold. It's probably somewhere in the 0.6 or so. Let's just hit play and see what that looks like. And look, now we've got a nice shiny gold environment that's actually reflecting the environment that we see here in our scene. You may wonder why the ones in the back there were dark. They're still not reflecting anything. The reason for that is whatever is inside of your reflection probe, this box right here, that is the only things that will be reflective. So it actually, as soon as you leave this area, if you have a reflective object, nothing. So if I press play again and go forward, let's just do that, and we'll jump. You can see that these are now reflecting nothing. So I've cranked them up to be highly reflective, to be metallic, but they've got nothing to reflect. So what we're going to do is we're just going to select our reflection probe, Control D to duplicate it, and I'm just going to slide it down the road a little bit here. And you can see it's actually going to bake now a new reflection probe, and I'm going to select both of them here at the same time and just show you a neat little concept. If you overlap them, they will actually blend between the two probes. And you can actually click on any object in your scene, and it'll tell you what do you want to blend when you go between two probes. So you can tell the probes and the skybox if you want to include the outside environment, or just completely turn it off or have a nice blend. So we won't really see that too well with this example, so I'm going to do something here in a second. But now you can see we've got some shininess going on both of our probes, on all of our coins rather. So what I've also done is, just to show you something else here, it's pretty slick. I've got on my character controller, I've got an object here called the bazooka. And this bazooka is somewhat famous in the Unity lore. It's the standard bazooka from the asset store. So if I press play and we just kind of walk through this environment, you can see it's not reflective at all. So I'm going to go and just stop that really quick. Select my bazooka. I've got the standard shader on it, and I'm just going to crank the metallicness up. I'm going to crank the smoothness up.
Beautiful.
Beautiful. Look at that. It's getting our shininess there, but you can see it's not actually sliding the textures. It's reflecting, and you can see it doesn't quite look right. Well, the reason for that is if you don't have this setting on your reflection probe called box projection set, it doesn't slide the image past the reflection. Actually, it's much easier to explain than to show. So I'm just going to select both my reflection probes and turn on box projection. Without this turned on, it works really well when you have objects that are animating, like this, where they're just rotating around. That's fine. But if you want them to actually appear as though you're sliding through that environment, you have to turn on that setting there.
Oh, look at that now.
And now you can see it's much more realistic as a slider. Now, I should point out, I can't actually move my mouse and have it move the input just on the way we're projecting today, so otherwise it'd be a little more dynamic with the, oh, I've just fallen off. Ha! And you can see once I left that area, we're no longer reflective at all. So you can see it just turns to black.
You need some more reflection probes and
pummeling to my endless
demise.
Whatever just happened there. So anyway,
cool.
Yeah, that's a little bit on reflection probes and those emissive values.
Awesome.
That little trick of setting the cutout and setting that alpha channel, that's really, really good to know. It took me a while to figure that one out, but it's just great that you can populate your scene with those emissive values.
Cool. It makes it beautiful looking. Awesome.
Why, thank you.
Let's move on next to talk about some animations inside of Unity. They've added a couple new features. Unity supports 2 animation systems. You've had the legacy support there for a long time. Some folks still use it, but then we've got Mechanim, this awesome animation system, which we're going to look at today. It uses 2 components. It uses an animation file and an animation controller. Now we have these animation state behaviors. Previously, if you were doing any kind of anything a little bit more complex with animations, you actually had to call API calls like this to find out what the current state of animations were. And now we can actually use code called animation state behaviors, which we'll look at shortly. 2D root motion. So root motion is taking an animation and mapping its movement in the physical world to an animation. So for example, if I have a guy doing a zombie walk, I don't have to actually move my object. Just the fact that he's doing a zombie walk like that, like this.
Is that what you're
like
doing?
This. Just the fact of him walking along like that. Without root motion, he would just be in place. You enable root motion, and it tracks his positioning, and will actually move him through space. So really brilliant way to get realistic-looking animations. Now there's 2D root motion. We're like, well, how does that work? 2D root motion, you basically define an animation for a 2D object, and then it will move that object through space. So we're going to look at some other things today. We are limited on time. They've added a whole API in there. So from code, you can create all of your animation controllers. You can essentially populate everything we're going to do today all through code without having to do anything in the UI. Maybe if you wanted to write animation extensions, things like that. But just maybe to enhance your workflow. It's not something that I use on a basis. I don't write the code to create my animation controllers. I like to click in my UI to do that. But I just want to tell you that in Unity 5, there's now a whole API to script all this if you want. So first, let's look at animation state behaviors. And if we look at our project here, let's go to my main scene and run it. And you can see the baking kind of was happening in the lower right-hand corner and got cut off as soon as I click play here. A little bit of music there. And notice, if I fire, the animation, like the ball doesn't come out of his hand right away. There's about almost a half second that goes by before he shoots that out. So how can you control something like that? Now, previously, Unity had a way of doing that in the animation system. Let's open up this guy's animation values here. And in the past, you could come into your animation window and you could go to like your shoot animation, for example. And you could come in here and define an animation event through this little tiny icon. You had to know it was there, and then you had to know to look for them. And if you ever got an error, it was forever trying to track it down. So I never was a big fan of the approach of essentially calling a code event at some point in time on the timeline here. You can do it. Again, that's what this little icon is for. But now we've got these animation state behaviors. And also, you could call a code event here. It still didn't tell you how far your animation was from being done. So now we have these behaviors. If I look at my shoot behavior, what I'm doing here is this is all the stuff, everything you're looking at here beneath shoot is from the Unity standard asset. That was a third-person controller. These were all the built-in animations. The beauty of this animation system is it's retargetable. If you have a humanoid character, like a zombie, an elf, or a vamp kid, anything that's a humanoid shape, you can take any other humanoid animation and apply it to that character. If I want this guy doing the Gangnam Style dance, or a zombie walk, or shooting an arrow, I can buy all those animation files or make them. There's third-party systems you can buy. You can write your own. There's ways of using the Kinect to actually record yourself doing your own animation files. There's so many different ways of doing it, or you can download them off the net.
Is that where you do your zombie thing in front of you?
I don't know what you're talking about in front of my Kinect. I practice at home.
That's right.
So you can take any of those animations and apply them to these characters. So these were already set up for me, and I was able just to, instead of Ethan, use the Vamp Kid and swap it out just by changing the model. And it just worked. Nothing complicated there. Now, I want to shoot, but when I shoot, I want to know that at a certain point in time to fire off that projectile. And so if I look at this code here, what you can do now is on any animation, you can add a behavior. So if I open up this behavior, now again, it's not on a game object, it's on these little animation blocks. And if you're brand new to the Unity animation system, we're going to cover what these blocks are in a second. But if you're already familiar with Unity's animation, then you'll be like, oh, this is something new. I don't understand. I didn't know that was there.
That's a huge thing too.
It's really cool. And so what I'm going to do in this, once this loads up, is after 0.4 seconds elapses on my animation, I'm going to then in turn say, hey, at this point in time, I want you to fire off a projectile. So let's let this code load up, and I will show you the goodness in the code. Code goodness for short.
Code goodness.
CG.
It's getting thick in here. You know, we are working on making the state machine scalable. So you can zoom in and out.
I was going to ask you that earlier today,
Yes.
actually. Yeah. All right, so here, there's a couple different methods. If you create a new state, a state machine behavior, that's what this inherits from, it will create you some default methods by default. You can see the ones that are commented out here. So Unity will generate that code template for you, then comment it out. I'm just using onStateEnter and onStateUpdate. So in other words, when something triggers off my shoot animation state, and for those folks that are new to this, I'll show you that in a minute. As soon as I enter that animation state, I'm saying, hey, we have not shot our projectile yet. Shot is false. Now, onStateUpdate gets repeatedly called each update frame from the time you enter to exit. So you enter your state, you constantly call onStateUpdate, onStateUpdate, onStateUpdate. Your animation's processing. Every time I process that, I'm saying, if my time that's elapsed, essentially, is greater than 0.4 seconds, and I have not yet shot my projectile, go ahead and call that code to shoot. That code is on my, my VampKid game object, and it just simply instantiates a projectile. We're not using new for folks that are new to Unity and wondering, why don't you just new up an object, var projectile equals new something. We're not doing that in Unity. When you want to instantiate a game object, you use instantiate.
Fast typer.
So we're going to essentially just call that shot method, and that's it. So one of the power of having these state machine behaviors is that we can say, hey, at some point in time, do method X, do method Y. We know when we've entered a state, and now we know when we have exited the state. And for folks that have dealt with the Unity animation system, this was a long requested feature. This was a little bit painful to do previously. All right, now let's look at the basics of the animation system and some things that were added here. And what Mark had just mentioned is I can't scale this window out. I can shift spacebar on any Unity window and expand it, so I can have a little bit more real estate here, but I can't zoom in and out. Let's go ahead and create a new one here. I've got a really template scene that we can rip through on this. Scenes, we'll do zombie animation. I have this zombie, and when I click play, it's going to go to my game tab, which I don't have any way of exploring my world yet, which is perfectly okay for this demo. I'm just going to switch back to my scene and just notice that my coin's not spinning and this guy is not doing anything. Now, Matt created animations for the zombie, and I can find those in here under my characters, zombie, and we have a zombie anims. And in here, we can look at all the zombie animations and preview them. Zombie death, zombie attack, zombie rise. So all the animations there. And what we can do is in our animator, we need a new animator. And what we're going to do here, let's create a new on my zombie. I'll show you from scratch here. We're going to add a new animator. What avatar? This essentially tells Unity how the bones are configured in this guy, how we're going to map animations to this guy. And we're going to select our zombie avatar. How do you know what an avatar is? When you bring in a model and you look at that particular model, you can configure the avatar for that particular model on the rig, configure, and it just brings up a default window that shows you the T-pose for that guy. Let me save all my changes here. Configure. You can see kind of the humanoid form there, and it will tell you if things are out of whack. Everything here looks good, so I'm going to actually get out of this. And let's go back to what I want to show you at hand here, is how to use kind of the animations here. So our scene has, let's go back to, 1 second here. So back to our zombie guy. We've added an animator, and we're going to look at what this requires in a second. We've pointed it to an avatar. Again, these avatars are just configured when you bring these models into Unity. Anytime you want to do 3D, you have to configure an avatar. When you bring in most things from the asset store, it's there by default. It's typically not something you have to worry about. But we're saying for our animations, we're going to use this zombie avatar. In other words, this is how his bones are configured. Next, we need an animation controller. So I'm going to right-click, and I'm going to create a new animator controller. And I'm going to call that zombie move, and then just assign that guy right here. And apply root motion you can use if you want to move the object through the world without having to write the code to move that object through the world. Now I'm going to click on my controller. So again, all I've added was this animator component. Open this guy up, and we'll notice there's a couple new things here. The exit is off the scene by default, so you have to watch out for that. We have the ability here to say, hey, when you enter, when this guy starts up, what's our default animation going to be? And so we say entry to some default state, idle, we'll use for example. And then we can transition from any state to another animation and then exit. Let's look at, make a lot more sense once I do it. I'm going to take my animations here. Let's take idle, for example. Drag and drop. Boom. Play. You can see, you can tell by the light here, he's idle. He's hanging out, he's chilling out. If I highlight my zombie and come over here, I get this real-time mode, and it shows me that I'm just running through my idle animation. All I did was I dragged that animation up into here, and it became the default animation. So again, on my zombie, I have an animator controller, has this little graph here, and I just dragged an animation file up into there. Now, what about when we want to make this a little bit more complex? I've got all these other animations here. So let's go ahead and do walk, for example. And let's do attack. And let's do death. Maybe rise. And let's say I want any of these to be called at any point in time. So I could be in the middle of idle, and then I want to transition to one of these. Now, previously in Unity, you would have to go like this, and then say, you know what, from walk, I want to go here. There were a couple different ways of doing this, but we have now, let me undo that, undo, 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 delete. All right, what we can do now is we can say from any state, we're going to go into walk. So we're making a transition to walk. Let's maximize this. And from walk, once we're done playing walk, we're going to exit. And that will just bring you back to idle by default. That's our default animation. That's why it's orange here. When some trigger becomes true, we're going to attack. And when we're done attacking, we'll exit. And when something becomes true, we're going to play death and exit. And when something comes true, we'll rise. Well, when I say something comes true, what do I mean?
Dreams.
Dreams come true. I define parameters here. So I can say that when a Boolean value called walk becomes true, we'll go to walk. Attack is a one-time operation. In other words, when I'm walking, I'm typically walking for a while.
Like a zombie, apparently.
Zombie, yeah. The zombies are slow. They're going to walk for a while. Attack, that's like a once-and-done thing. So I'm going to say a trigger. It's like, think of it as a one-shot Boolean. In other words, when I set this value, this trigger, to attack 1, it will trigger this off. Now, the naming convention doesn't matter here, and I'll show you how this links up in 1 second. Let's do another trigger for death.
Basically, the difference there is a Boolean stays on. You have to tell it to turn off.
Tell it to turn off.
On,
as soon as you consume that value, it automatically goes back to false again. The first time you use it, boom, goes back to false. You don't have to worry about setting its state true, false. And then we'll do rise. All right, now how do we use these values? You actually have to click on the arrow and say when walk becomes true, we're going to walk. Go down to attack. Now, attack is a trigger. It doesn't have true or false. It's just when attack is triggered, we're going to do that animation. And death, when death is triggered, and these are one line of code, you can call that. And rise, let's do the same thing here. Rise. All right, save all that. Now, I can pop this window out because we can debug this. Let's get a bigger view here, like that. There we go. Run that. Switch back to my scene view. All right. I am currently on idle. Now, if I walk, wow, look at that. He's kind of funky.
He's walking in circles.
And you'll find sometimes you have to kind of fiddle around with some of these, and you have to say, you know what, this value play that again. He's walking around in circles. Something that root motion can do for you too. So there's a guy walking. This sometimes the animations don't cycle up exactly on top of each other here. Let's turn off root motion. The other thing that you'll find when you get animations from various places on the net, or you make them yourself. So you notice, right, we had a different behavior here by turning off root motion. You can sometimes look at your animation files. Let's dock this window back in here. You can dock, click on this guy right here, and we look at our animation properties, and you'll find these values will cause you infinite headaches at times. Sometimes you'll import something, and this will be acting weird, and you're like, what's going on here? It's because the root transform position is based on center of mass as opposed to original. And it all depends on how the designer made it to how you consume it. The important takeaway is if you have animations and they're acting really strange, come in here and check these values on the actual model itself. It's hard to go through a full discussion now on what these all mean because it depends on what the designer wanted to do, if you're using root motion. But as a kind of a beginner tip, if something happens, check these out here. So let's play that again and just, let's revert that. I want to use that value. We'll play that, pop this out one more time. Let's do death, and we can do death over and over again. Notice, it's a one shot, so I trigger it off by clicking that. Boom. Now in code, this is essentially one line of code to be able to do something like that. Animator.set trigger def. That's it. Animator.set bool. Walk is true. That's how you set, what I was clicking, that's how you do it in code. It's literally that easy. But I like this preview in here because you can kind of test out all your animations and see how they work. So we go to death. When we're done with death, we exit and go back to idle. And so it's a really slick way of doing it now that's been added to Unity 5. Pretty cool?
Nice.
Pretty cool. All right, let's look at, we kind of covered this on the animation state behaviors. We have this new any state and exit state. We are getting short on time here, so I actually want to run over to you.
Yep.
Because you've got some cool stuff to show on audio, which is super, super important on any game.
Absolutely, unless it's a silent game. Ha! Wow. It was a late night.
Well, it was late night.
All right, so yeah, audio for version 5 got a major overhaul. Pretty much rewritten from the ground up. We now have a full bus system here. You can see I've got a bunch of different sliders set up. And just because we are running out a little bit over time, I'm just going to go and blow all this away and just show you how we can set this all up from scratch. Now, when you have an audio source, so I've just got a couple set up here, like my background music. As soon as you apply an audio clip to a game object, this whole pane here automatically populates. And you can see right now that it's outputting to nowhere right now because I've deleted it. I've deleted the audio mixer, so I could set that back to none. And you can see there's some other settings here, like we actually want this to loop because it's background music. And I can change a few parameters here. But if you create a mixer, you can do a whole lot more with this. So what I'll do is just create a new mixer. And I won't call it Mixmaster Mark. I'll just call it Mixer, Mixered, whatever. That looks fine. And by default, it creates a master slider right here. So obviously that's your master audio level. From here, I'll go ahead and create a couple more groups. So I'll add a group. We'll call this one Background. Like so, and then I'll create another, and we'll call this one Sound FX. Now, before I had it broken down into each effect was separate, I'm just going to show it to you on one effect here. Now, right now, this hierarchy isn't flat, so the master will control these two. Background, because sound effects is actually underneath or parented to background, if I lower my background volume, my sound effects volume is going to lower itself as well. I won't actually see the slider move, but we will lose that volume. So what you want to do is grab your sound effects layer or your object and just kind of drag it above into the master. So now you have a flat hierarchy like this. This will make it so that master will, of course, affect both of them, but now sound effects is independent and background is independent. Now I need to tell it what audio do I want to pipe into these, because if I just hit play right now, you know, nothing's going to happen here because it doesn't know what the background is. Just because I called it background doesn't tell it anything. So what I'm going to do is click on my background music game object, and now I'm going to set the output here. Just going to click on this, and now you can see the mixer that I set up. There's all my different buses right there. So I'm going to send the background music to my background bus like so, and now if I press play, check it out. Now we've got our background music right there. So I'm going to stop this. I'm going to show you one other quick thing. We've got all these coins. If I select one of these coins, we also have an audio track on here, just a little coin drop sound. Again, this one also needs an output channel. So I'll click on this little icon right there, that little bullseye looking thing. Click on sound effects like so. And now if I press play, I have my background music there. And if I walk over a coin, bling. Oops, I'm making sound effects that aren't even happening.
You are your own mixer, Mixmaster.
Oh, you know what? You guys can't hear. Can you guys even hear my sound? Oh, geez, I'm sorry, guys. I wasn't sure if you could hear it. That's better. Hopefully you can hear that. So I had my audio muted. It's always good to give an audio demo with muted audio. The best way to do it. Anyway, I think you can visually see what's going on. But some other cool things that we can do here, you know, now that we've set this bus system up, is I can start to add all types of different sound effects. So if I click on, or filters rather. So if I click on add, I've got all these different filters that I could add. You can actually write your own with C++. That way they're nice and cross-platform, but you know, I could put on here something like a pitch shift, press play now, and I can go and just start to tweak the slider here. Now notice, you know, for those of you that know Unity, you know you can't make changes in play mode, right? Well, with audio you now can. So I have a button here for edit and play mode. I've got another one right here. When you click that, you can now actually make these changes, and these changes get picked up. So these actually get saved, which is different than you know, usually when you're working with Unity. That's why I have my play mode tint. Have you talked about play mode tint?
Yep.
Okay, good. So I got my play mode tint set to blue. Adam had his to kind of a weird green. And here you can see I'm changing the pitch, which is changing the audio quite a bit on the background track, which is pretty neat. Some other things that we can do is I'll just show you one other quick little effect is something called ducking. Ducking is going to allow us to take any audio track and actually lower or raise the volume based on when another sound effect plays. So think of like you walk into a boss level, you want to drop the audio level down when you get near the boss so that, or at least the background music so you can maybe hear the boss talk, but you don't know the length of time that the boss is going to talk. Maybe you're doing 4 or 5 different languages and they all have various lengths of time. So you just basically make this an automatic effect. So what I'm going to do is add something called a duck. So basically you're going to put the effect on the track that you want to actually lower. So I'm going to click add. I'm going to add a duck volume. And that comes up with this controller right here. You can play with these quite a bit, but something easy to do is just to make it really, really noticeable, set your threshold all the way to the left, your ratio all the way to the right, and that's basically going to make the background volume pretty much plunge almost immediately as soon as something triggers it. So what I want to trigger it is the sound effects of picking up a coin. So when I pick up a coin, the background music is going to fall. So to do that, you also have to add something on the sound effect track. So I'm going to click add here, and I'm going to add a sender. And what I'm going to send is the volume of this track to my duck volume, and if it detects that volume, detects that sound effect, it's going to drop that volume. So you have to come over here now. Once I added send here, it appears here in my inspector. Change this to duck volume. And the one other thing you need to do is adjust this slider here. And you can see that when I move this slider, it actually moves this slider here. So you can actually do this in both places. And I'm going to show you a neat little tip. It's kind of hidden, but on our little tiny hamburger icon right there, I believe that's called, if you click on that, there's a little checkbox here for show bus connections. And I love this because it shows a nice little connection there, which, I don't know, I think that's neat. Anyway,
cool.
Yeah, a little visual, a little cue that something's going on there. So now when I walk over to my sound effect, to my coin sound, bling, the background music will fade, like so.
So background music will fade, and since we can't hear it here, hoping that you guys hear it on your end.
That is correct.
So which is cool because if the background music is too loud, you don't really hear the coin. I think we were talking about some other cool use cases, like maybe if you run inside of the cave, and when you get inside of the cave, you want to trigger something off so that duck volume kind of goes down. Play some other ambient sound effect while you're in a cave, and then when you come out, crank up that background music. So all sorts of cool little effects like that.
Yeah, one other quick thing is snapshots. These are really simple to set up. Snapshots just allow you to set your levels to predefined states. So here I can just quickly show you add a snapshot, and this is literally one line of code to trigger it. So you could say like BG low, something like that, add maybe one more, BG cranked, whatever. So here I could say, okay, well, whenever I'm invoking this snapshot, I want my background volume way up, and I want my sound effects volume low. Here I want the background volume low and my sound effects high. This is quite a bit different than a duck. A duck is, happens immediately. It happens anytime that sound comes through the sound effect channel. This one here is a little bit more scripted, if you will. You could say, you know what, when I get to this part of the level, I want these values set. And it can be on all these sliders. You can have 100 sliders, and you can also choose the time that it takes them. So it can be a nice fade. It's not an immediate thing. You'll actually see the fader slow or drop. So actually, if I press play and edit in play mode, click on my different snapshots, you can see those volume levels change. And again, through some simple scripting, you can change the
switch between what's the active snapshot.
What the active snap is,
cool.
Correct.
Very neat.
So there you go. Just a little primer on audio for version 5.
Very cool. All right. I think that brings us to the end of this particular module. We will be back shortly, and we're going to be talking about coding and AI up next. So thank you very much, and we'll see you shortly.
PBR? Oh, we're at. Oh.
Welcome back yet again. Thanks for sticking with us, or welcome if you're just joining us for the first time to Building Windows 10 Games with Unity 5. This module we're going to be talking about coding, AI, and a little bit of the mobile input controls that they have in the standard asset packs. So some really easy way to get up and running with mobile controls.
Expect a lot of laughter in this one.
Laughter.
Very, very
right.
entertaining.
Here also again with my good friend Mark from Unity, who's going to be my sidekick throughout this module.
I am.
We have Matt as a heckler in the background there.
Hey, we're also, by the way, we're also going to give you guys a link to win a free Unity Pro license at the end of this also.
So for those that are live watching it right now, Mark's going to give a link to win a free Unity Pro.
Yeah.
Can we cut off and I just go to that link? All right, so in this module, we're going to talk about a little bit of coding, coin pickup, zombie score, level death, how to put a border on a level, essentially how to detect when you've gone off a level, some of the input and mobile input, and just some rudimentary basic AI. So on the coding side, the typical process for most of the code that you write is very, very similar. Anytime you want to detect a collision with something, it's either you're using what's called a collider or a trigger, which we're going to look at. When that collision happens in code, Unity will call your code method, and then you increment some variable. Like the process is extremely simple. It's template code that you use pretty much all the time. In this project that you can download, you'll see that there's going to be a player score component. And at lunchtime here, we're going to break. You're going to be able to find the code. Everything that we're showing is going to be out on github.com, Adam Tuliper. My repositories, though, I will make this public. You're going to see the VampKid 3D project out there. So that is where you're going to find it. Is where you're going to find all my stuff is out on GitHub. So github.com/Adam Tuliper, VampKid 3D. If you go right now, you won't see VampKid 3D. Again, at lunchtime, I will make that public. So that will be coming up very shortly here. If you're watching this, the recorded version, it will already be live. Simply a variable that we're going to use to track our inventory, in other words, our coin score. And there's some challenges of UI and rotation, and I'll talk about that with how we're going to do something cool in the coin pickup. We're going to look at the zombie score, and again, it's template code. We have some variable we're going to update, and we're going to check that when we hit, in other words, when we collide with a player, we're going to tell someone about it. Again, it's template code. Visual Studio Tools for Unity will actually generate the method signature for you. But the idea is that in coding in Unity, when you want to do near anything, if you want to communicate with other objects, you ask Unity for a reference to those objects. And so notice this code sample here. Assume this is the zombie, and the zombie wants to know how to alter the player's score. So the zombie, when the zombie wakes up, not wakes up from the dead, but when Unity wakes the zombie up, well, I guess it's kind of waking up from the dead. You call GameObject.find GameObject with tag. And if you recall, when we talked about tags on a GameObject, let's look at the zombies, for example. Now, Matt was appreciating these green prototype zombies. He made these green prototype zombies, and he's actually made a much cooler looking zombie. This is a prototype zombie. When we resume after lunch, you guys will see a final zombie, which looks a lot better than this guy. But on any particular game object, you have a tag that you can assign. You don't have to, but you can, and you can assign your own custom tags here as well. You can add super zombie, just for example, if you wanted to do that. You have some built-in ones by default, and if you look at a common one is player. So Unity provides a few of these by default because people use them all the time. They don't have any special meaning. They're saying, hey, we realize that a lot of folks will use these, so we're just going to give them there by default. If you want your own, you can make new ones. You don't have to use any of them. But this is the common way that you ask Unity. GameObject.find GameObject or GameObjects. There's an API called an S. GameObject with tag player. And that will look through all of the game objects that have a tag set and then find the one from player. This is a pretty fast operation. I wouldn't do something like this every frame, but it's perfectly okay to call when that object starts up. That's when you ask for references. In other words, the zombie wakes up, says, hey, I want a reference to player that I can use later on. So that's what your kind of code that you're seeing here. Okay, let's look at some score code here. And we're going to do our no coin level on this. So we have a couple scenes that are going to be set up that you'll find in the demo project here. And we have main no coin. Let's run this. There's the audio you may or may not have been able to hear before. And notice, I hit this coin, nothing happens. So let me just fall to my doom there. All right. Now, this coin, there's some code we can assign to this, and we'll walk through it. The idea on any object you want to pick up is that you want a collider on that object. So if I look at this coin, and notice I don't have anything there yet. As such, I walked right through that. Let me collapse these just so my view's a little bit cleaner for you here. For those watching this. There's no collider here. So there's two things to note. If I want physics on an object, I have a collider. So if I have a cube, for example, and let's just scale this cube out, make it visible. So this cube has a box collider. In other words, I could actually fall on top of this cube. I can run into this cube. I will not be able to go through this cube. Let's try that. Just to show you what a collider is. See, I cannot go through this cube. That's because it's a collider. Now, in some cases, I want to be able to run through something, but at the very moment I come within a particular defined region of that object, I want Unity to tell me in code. As it stands right now, I can have an onColliderEnter piece of code assigned to this that Unity will call. But that assumes there's physics happening. Maybe I don't want physics. I just want to say, hey, when you run within range of this coin, let me know in code. Don't stop my player from running, because that's going to make him look kind of messed up. He's going to running along, hit a coin, and he's going to stagger. I don't want that. I want to, in theory, be able to run right through that coin. But the moment I touch that coin, tell me in code, and then I can pick up that coin, make it disappear, or do something with that. And so let's look at what we can do here for that. If I go to my scripts, I have a pickup script, pickup coin. Let's load up that code. And it just really requires one thing. It requires that your coin has a collider on there, and that collider is a special type of a collider called a trigger. Why are we using triggers? What's the difference? A trigger is when we don't want a real physical interaction. We don't want something to bounce off it to hit it. We're just saying, hey, I want you to do a region detection, and when something comes within range, call my code. That's it. Don't stop the object. I'll handle all that. And so that code in pickup coin, I've got a little code in here for debugging, but basically the code that we're looking at is this guy right here. It's one code method. You see this code all the time. onTriggerEnter, and Unity will call this on both game objects that the collision happens between. So in other words, when they become within range of each other, one object's collider passes, it comes in contact with another object's collider, and one of them is set as a trigger. It calls this method. And it will give you saying, hey, here is the collider of the other object you've just hit. Well, remember, a collider is a component. So if we look at this, for example, we see that there's a collider on here. If I want to know who this is, I don't care who the collider is. I want to know who the collider's game object is. And so in our code, we can say when I collide with this collider, let me know who its game object is, and then let's look at that game object's tag and see if it's player. If it is, we're going to do some code. We'll keep it really basic to start, and we'll just say destroy myself. I can't say this. If you're writing code, it might seem like I want to destroy this. This is actually an instance of the pickup coin script. That's not what we want to destroy. We want to destroy essentially this.gameObject, but we can just leave this out. Lowercase g, not capital G. C# is a case-sensitive language. Do not use capital G, because that's for doing things like gameObject.find gameObject with tag. When we want to refer to this gameObject, lowercase g. All right, let's take that code, and I can actually assign it to this big cube if I want. We'll do the coin in a second. This will give you a nice big demo to look at. Okay, take that code, drag it onto our cube here. And now this is not a trigger, so we need to make that a trigger. Otherwise, it will not call on trigger enter. Okay, let's save that. Run that, and let's, boom. As soon as I hit it, call this code method. In fact, I can even just debug this if we want. Attach to Unity. Wait for that to start. Debugging is super easy with Visual Studio Tools for Unity. Click play over here. Now when my main player, who has a collider on it, comes within range, this box's trigger, it's a collider with the trigger checkbox checked off. When it comes within range of that, it will call our code. So let's hit this guy, right. There we go. Just happens. There's our game object tag, is player. There's all our game object properties, it's VampKid. Perfect. F5 to continue. All done. So let's take that code and drag it onto that coin, because we can just reuse that same code. So take our coin, add our code there. And we talked a little bit about prefabs. Let's go ahead and make a prefab out of this coin. So I like to do that in the prefabs folder. And I've actually had this coin started. Let me just create a new temporary folder here just so I can show you this demo. Take my coin starter, drag it down here. Okay, now it has, we still need a collider on here. So let's go ahead and add this shape. We have a couple different colliders we could use. It doesn't have to match the shape exactly. Let's do a sphere collider. Make that a trigger. And now notice, see that sphere that surrounds that object? That's the range that we need to come within. That's pretty close. We can make this a little bit bigger if we want, meaning if we come within that range, we'll pick the coin up. The cool thing with using a prefab is we can just do that, we can do that. We have all these reusable instances. And let's go ahead and change. Let me just do one thing here. Apply those changes to my prefab. There we go. So if I change any one of these prefabs, like for example, if I change the radius on this one prefab, and I like that change, and I want to apply it to these guys, I click apply, and it updates this, and pushes that back out to the scene again. All right, so all we did, we added a collider, and added that code that had that one method in there. On trigger enter, that's all we care about. And there's also 2D versions. So there's on trigger enter 2D. There's on trigger exit when they leave each other. And there's also on trigger stay, which is called constantly while these objects are in contact with each other. Let this compile, and we should be able to run right through and pick these guys up. OK. I'll clear that breakpoint so we don't see it every time here. Perfect. All done. Now let's take this one level further here. So that was just destroying it, but let's actually pick it up, so to say. All right. This is going to get slightly more complicated. We're going to call this method called pickup. what is pickup going to do? Let's see. Let's run this, get the visual on it, and then we'll actually walk through the code. Now, these have an audio source component on them. You can see the little speaker on them. Let me turn this up so you can hear it on my microphone here. And watch what happens. So we picked it up, it made a little coin sound, because each one of these has an audio source. And then it actually took those coins and spun them up to the corner. And that has some challenges, because if we look at this coin, and when I pick it up, I'm going to quick move my screen away here. Right? I'm shaking it, but it's still consistent. Like, no matter where I look, it moves up there just fine. So how does it do that? Well, the first thing that we need to do is, as soon as we touch this coin, we are changing the parent of that coin. Now, the parent-child relationship in Unity is kind of interesting. If we take any game object, let's just take this coin, for example, and make it a child of my zombie. Now, when I move my zombie, child of that guy. Now let me move my zombie here. Notice, any child moves with the parent. So let me undo that change. So we're taking that coin and making its parent the camera, meaning wherever we look, that coin is now going to be, it's a child of the parent, it's going to follow that parent around. Then we do something called a coroutine. We covered coroutines in our first Unity course that we talked about earlier, the ak.ms/free Unity training. Quick refresher on coroutines. This kicks off, think of it as a separate task. It's not a separate thread. Unity uses a coroutine system. So think of it as a separate task. You're saying, hey, I want you to create this separate task, and then go ahead and play that sound. So it's not going to wait for this to finish. It's going to kick this off separately. Then right after it kicks off that separate task, it's going to play the audio source on this coin. So it's getting that component and playing it. Getting that component, what does that look like? On that coin, is there an audio source? Sure, we see a speaker on there. So get component audio source, returns this, and play simply plays that sound. Now let's look at this. This is the interesting thing here. Start a coroutine, move to score. A coroutine always has this format. It's IEnumerator. It looks a little bit weird. It's just, that's how these methods are defined. While true, which seems like an infinite loop, but what we're doing is we are going from our screen coordinates to our world coordinates. Now in Unity, these are screen coordinates, and as we look around the world, those are world coordinates. Screen coordinates go from 0, 0, all the way up to our screen width and screen height values. So 0, 0 to screen width and screen height. And so what we're saying is we need to find out, we need some point in our world, which is going to be our upper left-hand corner in our window. So we're going to say, starting at 0, which is all the way to the left, and then we're going to go, it's kind of reversed the way you think about it. So it's 0, and then our height is actually up here. So 0, 0 is down here, and height. So we need to take our coin and move it up to the upper left-hand corner, which is 0 and screen height. We're going to set this coin's transform position, and remember that a transform position is right here. On any game object, we can change its position, and so we can just do that in code. We change its transform position. We're going to lerp it to this world point. What is lerp? Every frame this processes, we're going to move it a little bit at a time. It's a frame-based system, so we need to do something a little bit at a time and move and move and move. So this is our coin's position, and every frame, we're going to come back in and move it just a little bit more. Lerp is a pretty common use function. It looks a little weird at first, where it takes two values, and then a value between 0 to 1 on what percentage to move the object from point A, or move the value from point A to point B. So if I have a value of like 0 and 10, and I'm moving it by 0.1, it's going to return a value of 1. In other words, 10% between 0 and 10. So it returns a percentage between those 2 points. And every frame, we're going to move closer and closer and closer to that world point. If we get close, we're going to destroy our coin, because we don't need it anymore. and then we're all done. Now, when we're all done here, this is where we can do something like keep score. So notice we're not doing any score keeping here. So let's change that. When our coin wakes up, let's go ahead and say we have a player score game object. Let me rephrase that. A player score component. Make this private. That player score exists on our main player. So if we look at our Vamp Kid, we can see he has a player score that is just set to 0, 0, 0 right now. So we need to ask Unity, hey Unity, I would like a reference to this so I can update these values at runtime. And so in order to get that, we first have to find the Vamp Kid, and then we have to ask for this component. So find Vamp Kid, ask for the component. Game object, and remember I said it's a common task to find game object with a tag, player, and you can type that out if you want. One of the techniques I like doing is you can have a class defined or an enum or structure, depending how you like it, where you just don't have to type it every time, and it kind of prevents the old fat fingering where you kind of type it in incorrectly. So you can either type it in or you can have these values you refer to. So this is a little bit less prone to typing errors. Errors are bad. We don't like errors. Find our game object. That's our player. Perfect. And then we can say our player score. We can actually do this all in one line. I just want to break it out a little bit. Equals Vamp Kid dot get a component on the Vamp Kid. Get me his player score, a reference to that code that's instantiated on our vampire. So these two lines will find the vampire and get a reference to this guy right here. Perfect. And then once we actually pick up a coin, once we get close enough that we're going to destroy our coin, at that point in time, we will say our coin score plus equals 1. In other words, increment it by 1. This is a little bit of what they call a brittle implementation. Ideally, I would probably want a method I call into and give it a value of how much to increase, just to make sure multiple things aren't calling at the same time. There's a couple, there's a little bit slightly better way to write this, but this is just a really basic way using a basic object to show you. We have a public variable on that object, and we're going to change it at runtime. So let's go ahead and set a breakpoint on that guy, F9. And then we will go ahead and let me actually cover this real quick, and then we'll run this. So if we're close, so we're taking the upper left-hand corner and our current position, taking the magnitude of that vector. It's an easy way to check the length. And we're basically saying, hey, if we're within 1 unit, 1 meter of that object, then just go ahead and destroy it. So this is a common way of checking length between two objects, wherever they are in space. We're dealing with 3D. So we just want to know, like, hey, are you close enough here within 1 length? Sure. We're going to destroy the game object, increment our score. So let's go ahead and switch back to Unity. Everything compiles okay. We don't see any red down there. We're going to attach to Unity. And then we will run our game. Switch back over here. Give it a second to finish its processing. Come back to me. Mark, you know any good jokes?
No.
No.
Not one.
Oh, there we go. Okay, now it came back. So let's go ahead.
I can open another can.
You know, you said you said not one, and that was the joke, and it worked.
That's my joke.
We're going to play this again. Everything's kind of slowing down here. It's like, I want lunch.
Not one.
Not
No,
one.
didn't work that time.
Oh, there we go. A little delay. We get to listen to some good music. All right, so let's touch this coin. Now, notice, we heard the sound. The coin flew up, and then we hit our breakpoint here. Our coin score is currently 0. Let's F5 this. There we go, 2. 3. There we go.
Fair.
We picked up 3 coins. We have 3 as our coin score.
I know who's buying lunch.
Super. I'm kind of getting hungry. You're going to hear my stomach growl soon. All right, so really, really easy way to write some score code there. We simply take the parent, take that coin, make its parent to camera, so no matter where we move, it's going to move with the camera. Move it up into the upper left-hand corner, and as soon as we get close, then we just increment our score.
Sounds good.
Real easy. All right, let's talk about level death detection. Tell you it was a late night last night. All right, level death detection. Let's go back to our scenes here and load up this guy. And you'll notice, let's run off our world. You want to say it again?
You know what? I think it's just funny, like listening to people over here, non-industry people talk about like level death detection and stuff. But whatever it was you just said about the world was funny too.
Level. All right, here we go. All right, I'm going to come off here and jump.
Dude, why'd you do that? You're not very good.
Actually, in my environment, in my terrain, I actually had a level end on there. So let's go ahead and stop this, because that's giving us a little delay when we play here. Play that, and you'll notice I'm going to run off this level, and I'm just going to fall and fall and fall and fall. Goodbye.
Ow.
Right? There's no level death detection. I'm falling. There's my level up there. Wait, can I see it? No. All right. How can we overcome this serious limitation in our game? One thing that I like to do, and this was a question as a beginner I had, how do you do boundaries and levels, like level edges? Really easy way. So let's find out where we kind of want to do this, maybe around here-ish. Game object, 3D object, let's create a cube. And in our, not in every direction, but I want to scale it out maybe here and here, there, and there. Let's see what that looks like. Oh, that's pretty big. So notice, I'm just taking literally a flat cube. It's got a little bit of depth to it. And let's make it so even if somebody finds a way to jump towards the edge of our world, they're kind of still limited a little bit. All right. That looks good. The depth, I think, looks okay. As we get closer, we actually see our shadows on there. So we've got this level now. I can run off my world. And you can clearly see it down there with all of its fine lighting.
Oof.
And I hit it. Well, that's no fun. I can turn off its mesh renderer. Voila. Play. You might guess we'll still have another issue. Have you ever been on a glass bottom boat, Mark?
I have.
You have? All right. So this might look familiar then.
Yes. I was
Okay.
on the top of the CN Tower about a month ago, which has a similar kind of...
Awesome.
Yeah. I liked your Endless Faller better.
So, well, the problem is we have an invisible collider, right? A collider is not a visual object. It's something that you've told Unity about this region, this big box. It doesn't have to be visible. But now we can use the exact same type of code that we just did for our picking up a coin. And on here, we're going to say level end, and then we'll look at this code.
That's going to be one giant coin.
This is literally all the code that we need. On trigger enter. So we need to go ahead and make this a trigger. I mean, we can make it a collider and run around on there, but there's no reason to run around on that. My cube is right here. Let's call this border instead of cube. Let's turn this into a trigger. Why? Because I don't care about something landing on it and running around. That's worse for performance. I mean, although there's a highly optimized physics engine here, but I just want to say, hey, when something touches this, let me know. So save that change. Speaking of save changes, another Unity 5 edition. If I make a couple scene changes and then I undo it, it used to keep my scene dirty in a sense. I would go and play it, or I would be prompted to save. With Unity 5, now I can undo, and it keeps my scene clean. So for those using source control, it actually helps quite a bit because If you're just making a couple changes and undoing them, it doesn't dirty your scene, so you don't have to resave it again. Cool little workflow. That was actually highly requested as well. All right, back to this simple code here. On trigger enter, when our player hits this trigger, that's it. He's dead, Jim.
Ha!
We can do whatever we want to do with that at that point in time. In this case, I have a player health class component, a player health component on the player. So if we go and we look at VampKit again, we just looked at player score. There's a player health also on that character. And so when we hit, that's when we say, our vampire, give me that component. Actually, I just realized we could have done a little shortcut that I did not do. When we collide, we actually already have a reference. So let's go back to the coin in one quick second, because I realized I could have optimized this code a little bit better. So good learning exercise here. When I hit my coin, it passed me my VampKids collider right here. I don't need to search for it on startup. It's already given it to me when I collide. And since I'm only ever colliding with the coin once, I can just use that and ask for its component. In other words, I could have just done this. This is a little bit optimized. I could have said other dot game object dot get component, and I never would have had to do anything in Awake. So if you're watching this at home and wondering, hey, you could have made this better, well, hopefully I just caught that. I will have the fixed version in the download source. Just a minor change here. But anyway, that's what I'm doing on level end. As soon as I hit my trigger, I'm just getting its health and calling die, and we don't care what die does. The important thing is detecting that collision here. And so we can see now when we run off the edge of our world, we'll call on trigger enter, and he will die. Oh, he's a vampire, so his die is just trigger off a bunch of bats and make him ideally disappear. Although in this scene we don't make him disappear. Cool. All right, let's talk about input and mobile input. In the standard assets package, we now have some built-in mobile input that we can use. That was one of the questions I hear a lot from developers. Hey, I want some sort of touch interface on my screen. What works on the desktop does not work on mobile. So, and you can write your own code. You can buy packages from the Unity Asset Store to do it. I've done them. I have bought packages to do that, and there's some really, really good packages out there that do that. A lot of customizable joysticks. But Unity has provided some basic ones built in to these standard assets. Now, the input system in Unity reads values. You can say input.get button down fire 1. And if you're pressing your left control button or your left mouse button, it will turn true. And that one actually works for a touch on mobile. But when you actually try to read input, like your left and right on your keyboard, input.getAxis horizontal maps to your left and right arrows. And if you're saying, well, I'm new to Unity, how do I know what horizontal means? Because I had the same questions.
I think laying down flat.
Edit project settings input. So edit project settings input. If we look at the word horizontal, maps to the left and right arrows, the A and D key. If we say input dot get axis vertical, that's going to map to the down and up. And those are values between -1 and +1. So if I hold down the left key, it's going to go pretty quickly to -1. If I let go, it's going to go back to 0. And you can control how fast it moves back to 0 to 1 to -1 with the sensitivity value. But anyway, I digress here. I just want to show you where these settings are, and also like fire 1. It's the left control or the mouse 0. In other words, the left mouse button. So on keyboard, it works great. But when you try to use your left and right arrows on a phone, you find just swiping in the air, you don't actually have that. So there's no keyboard. Now, one of the ways of doing that is you throw an image on the screen and you kind of track the users, how they're dragging that image around, or just tracking touch. Unity does support touch through the input.touch class, but you have to kind of write your own there. There are third-party assets like EasyTouch. Now, they have given us some code, Unity and the standard assets, in the cross-platform input class. So let's go ahead and kind of look at that here, because in our main scene, so let's go back to our scenes, main. All right. We can find, if we look for cross-platform input initialize, notice it refers to these values here, cross-platform input, and we have a menu item. I mentioned earlier that you can really script out Unity's environment. Pretty powerful. There's a lot of assets that rely on this code. So notice this says menu item mobile input enable. So this actually adds this menu right there. That code adds this to the interface. And when you say enable, you have enabled mobile input. You'll need to use the Unity Remote app on a connected device to control your game in the editor. Now, there's an asterisk surrounding this. There's not a Unity Remote app for Windows Phone. There's one for Android and iOS. I think both of those have source code available. The process to test on a Windows Phone, I'll show you here, is actually really easy. So you just deploy it to your phone and test out the package, which I'll show you here. So I'm going to say, OK, let me make sure I have my code open here, which I do. And back to Unity. Oh, my dialog is preventing me from seeing this. OK, we say OK. Now, let's see if this picks this up here. Once mobile input is true, notice it's triggered off a change in my environment. I'm going to say reload, because mobile input is now true, and so it enables this cross-platform input controller inside of Unity. I'm going to reload all that. That value is now true. If you are familiar in C# with preprocessor directives, preprocessor constants, that essentially has enabled one in our code that we can use. And if we look at, let's find this guy throughout. Cross-platform input, editor mobile input, and mobile input. So the fact that we have these enabled means Unity has a cross-platform input class behind the scenes. And what happens is, when it's enabled, it will read from virtual settings on mobile, and I'll show you what the interface looks like that. And when it is not enabled, it just reads essentially the standard input. But it maps to this virtual class here, which I think I have the name that I copied out here, just to make this a little bit easier for you to see here. This was, yeah, like this. Let me search in my entire solution, find all. So there's a cross-platform input manager. This is essentially the virtual interface that all of your code calls into to find out if it has a button down or button up. So rather than reading it from input like you would normally do, in other words, normally input, get, button down, that's specifically tied to like your keyboard, like input.get axis horizontal, your left and right arrow key, right? That doesn't work on mobile. So the cross-platform input manager gives you this generic interface you can call against, and they've given you the code, it exists, and actually there's a prefab you can use. So let's look at that. Under standard assets, clear this out so we can see where it's at here. Standard assets, cross-platform input, prefabs. You'll notice there's a car tilt control, dual touch control, mobile aircraft controller, mobile single step, mobile tilt controller. So in this, I've taken these dual touch controls, and notice as soon as I've enabled mobile, they show up in my scene here. So these are 2D elements that they've added, and these will, you can hide these images, so I can delete these images, and ideally you want to do that. They're just showing you, hey, these are the areas that we're defining in your game. So what happens is when you have this enabled and you do a build, it's no longer reading from the keyboard. It's actually waiting for you to touch. Now this will not work in Unity's interface. If we click on play, and we try to play our game here, right? I can't, like, I'm moving around, clicking, it doesn't work. I'm using my keyboard, it doesn't work at all. It's essentially waiting for you to touch the screen, which the input.touch works on mobile. Specifically mobile controls here. So let me show you, if you build to a phone, you can plug in a Windows Phone that's registered as a developer, say build and run, unlock your screen, and it will deploy right out to your phone. If you want the Visual Studio solution to work with, you just do build, and we're going to cover this in the last module of the day today. But let me load up my phone here. And if you want to see what's on your phone, you load the Project My Screen application for Windows Phone. I click on Yes to allow screen projection. And I've got my VampKit 3D here. Let me get it close to me so you can hear the audio when it loads up. There we go. So you can see the icons here. I'm touching on the right here, turn touch area. And if I press on the left here and move forward, goodbye. There we go. So those map to touch areas on the screen. Let me Alt F4 this application, close that out. So that's the mobile input controllers. It just works. You drag and drop them into your scene. And again, there's a couple different options you can choose here. I'm using the dual touch controls. There's also a single stick controller, tilt control. Drag them up in your scene, enable your mobile input, and it just works, as long as you're using standard assets. If you're trying to integrate the standard assets with some of your own code, you're going to have to call, rather than using input, you're going to have to use their cross-platform input class to read those in, instead of input.whatever. All right, moving on. AI. This is a funny term. Artificial intelligence.
Oof.
The funny is not artificial, but it's intelligence, because it's not really intelligence. If you look at most games, the logic in games does something like this. If something is in range, do X, otherwise do Y, and every now and then randomly choose some other some other Z, some other action. Right? Take a zombie, for example. Sit there idle, walk around, sit there idle again, scratch your head randomly, like every 10 seconds, do some random action, and then if the player comes within range of you, then pretend you're attacking. Right? It's a pretty simple process. It's not really artificial intelligence. Now, granted, there are games that have amazing seemingly AI in them, but for what you typically see on mobile and a lot of like desktop games, it's very, very rudimentary AI. That's why I hesitate to use the term AI. Now, we're going to look at just like what seems to be artificial intelligence movement. In other words, Unity's pathfinding system, which is NavMesh, navigation meshes. And this allows you to move between areas to go from essentially from point A to point B. You can go between defined navigation areas. So you have these off navigation areas that you can travel upon to get from point region A to region B. You can be defined to a particular area. You can say, hey, I want to be able to go up these inclines, or I can't go inside of an area that my head won't fit. So there's all sorts of parameters you can specify here. There were pro-only features in Unity 4.x. Well, when Unity 5 was released, they did something that was pretty amazing, and they made the personal edition have all the same integrated features as the professional edition. Of course, the professional gives you additional add-on features, analytics, cloud build, etc. But all the basic in-game features that you're going to use are the same between the free version and the professional version. So you have all these really cool navigation things available to you. So let's look at a demo. We're going to look at our NavMesh Unity, and that is, we go to my scenes. All right, I'm going to disable my mobile input here because we are not going to use it. Get out of 3D mode, out of 2D mode, I should say. You can see my baking going on down in the lower right-hand corner. And let that finish here 1 second. All right, now notice my mobile input just disappeared. And let's go to find my VampKit here, or one of my patrol points. All right. We can make this pretty simple. Let's delete this guy. Actually, we'll just hide this guy. All right, what I've done here, the intent is I want something to follow the player. So let's play. And this is nothing new. We've got this little world here, and this guy can run around here. All right, now if I have an enemy that I want to follow my player or move between points, we need to tell Unity about these objects here. So let me just move some of these around a little bit, because I'm just going to essentially break up some stuff. Now, we want to go to Window, Navigation, And in order to include something for navigation, it has to be navigation static. In other words, it has to be checked off navigation static. These other ones don't matter here. It's navigation static is what is required for nav mesh. If you have an object that you don't want to be included in all of this, then you simply uncheck navigation static, and it's not included in the steps we're about to do next. All of these here, I want Unity to include. In other words, I want some enemy to be able to traverse through this entire area. And it doesn't have to be an enemy, right? You can have this, quote, AI or pathfinding on your main character as well. But we're going to do this with a little enemy here. So everything is marked static, navigation static is all I care about again. Let me save this scene. And once you have your navigation window open, again, window navigation, you simply say bake. And it turns this pretty blue color, but you'll notice that there's kind of some gaps here on the side. And with your navigation settings, you can tell Unity what the radius, what areas you can traverse around areas, what height you're allowed to go within, what's the maximum slope that my characters are able to travel up. You'll notice this has too much of a slope here, more than 45 degrees, so it's not blue. This is not an area that the enemy is allowed to traverse up. And we actually have a problem here because the enemy as it stands now can't get from this platform to up top here, which is a use case for the off-mesh links. In other words, that's what you can use to tell Unity you need to be able to travel between this platform, this area, and this area. We're not going to do that here just because of time, but we're going to look at some other things on how to use all of these defined areas. There's a lot of other parameters you can set on NavMesh. We're going to look at some of the basic ones here right now. So all we did, window, navigation, bake. And I just had anything I want included checked off as navigation static. Now notice I only see the blue stuff when I'm on my navigation tab. Now I need something to actually use that. So let's go ahead and create an enemy. Of course we could use a zombie here, but I'm a fan of the Indiana Jones movies. So why don't we create a big evil sphere. Crank this guy up. That's an evil sphere, if I ever saw one. All right, I'm going to move this guy back a little bit. Make sure in 3D space I'm really where I think I am. So sometimes I like to drop an object down until I see it pass through a surface, because 3D can be a little misleading as you're working at it. You really have to rotate objects around to make sure you are where you think you are. But when you see that you're intersecting other objects, then you have a pretty good idea where you are. All right, so this guy, I don't need to enable physics on him. I don't need a collider here. I don't need a rigid body. I just want him to have some simple pathfinding capabilities. And as such, on this guy, we're going to add a nav mesh agent. So think of a secret agent. A nav mesh agent you need on something if you want that object to take advantage of your navigation areas. If you don't have a nav mesh agent, you're not moving in those areas. So you bake your navigation and then add a nav mesh agent to whatever character you want to move around or whatever object. So that's all we did here. So if we look at this sphere, we have a nav mesh agent. And this defines some areas, what radius we need to be able to go through areas. If we have a really skinny area that's maybe smaller than a half of a meter, we won't be able to go through that area. So we can define all these parameters on what size areas we can move through, what height we need to be able to go through areas, how fast we can steer, how fast we're going to go. We're going to keep these at default right now. Let me save my changes. Now, when I play, nothing's going to happen because there's no code controlling this nav mesh right now. This nav mesh agent, I should say. It's just a component on a game object right now. Right? You can see him over there not doing anything. So let's add some rudimentary code. And I've got this navigator class. While that loads up, let's go ahead and take this code and show you one of the other ways you can add it to an object. We've looked at dragging up here. We've looked at dragging over there. You can do it here as well. And there we go. So our code has been assigned to Navigator. And let's look what that code does. It's super, super basic. When we start up here, we are storing our starting position. And then we're asking Unity for our player. And again, just to be consistent, rather than typing out here, I like tags.player. We're saying, get me my player game object, my vamp kid, And I want to know his position. So that's his transform.position. Now I want a reference to my navmesh agent component. In other words, on my enemy, get me this guy, because I need to pass this component parameters of where I'm going to go. And then, once I have a reference to that component, I simply set the destination to be wherever the player currently is. So this is essentially, I stored those values, and now I'm saying go to that location. Now, every frame that I update here, we have some code here to find out if we have arrived at a location. And the code looks like this. So you can find it on the net, or you can use my code. Path pending, remaining distance, and stopping distance. Are we currently on a path? Are we currently pending a path that we're navigating on? What is our remaining distance? And what is our stopping distance? So remaining distance, we might have a distance of like 3 meters to a target. You can basically say on a navmesh agent that you can stop within 0.3 meters of a target. Like, you don't have to be right on top of there. If you come within 0.3 meters, that's good. And it's good to have a little bit of a so they say, a fudge factor here. Keeping that at 0, it's sometimes hard to stop right on an object, especially when you're dealing with float values and small positional locations. Objects are constantly trying to move and get on top of each other for these very minute locations. I like to say, hey, when I'm within like 0.3 meters or half a meter, that's good enough. Let's stop right there. So I'll save those changes. And when I arrive, I'm just going to debug log a little statement here and go back to my starting location again. So let's see what happens. Now you can see he's coming after wherever my starting position was. Let's get out of his way, because he's going to wherever my starting position was. And once he gets to that location, let's go to my console here. There we go. Arrived, done navigating. Now he's going back to the starting position. Now if I wanted to make this guy a little bit smarter, I could always make him go to something like this. I could cache my player's transform position and always make him follow that. So I could do something like private transform player position. I should probably call that player transform. It's not really his position, it's his transform. And once I arrive at some location, instead of going back to my starting position, I now want you to move to wherever the player currently is. Let's see what that looks like. So every time I arrive at my last seen position, find his new position and go there. That's kind of a good AI for a zombie, right? Because the zombie kind of sees you, moves towards that location. He's probably looking down at the ground, thinking about brains. And then he looks up and you're not there anymore. Oh, you're over there. He's going to go to where you were. So let's go here. Let's kind of keep an eye on this guy. Now we circle around. Oh. It's coming back. So he kind of stopped there. Now he's coming back after me again. So, rudimentary quote AI. And he's not going to follow me down here. That's one good way to get away from him. All right. Pretty basic, right?
Yeah.
Easy enough to do. That closes up that demo. And we will see you after lunch.
Sweet.
And then we're going to talk about more excellent stuff. Thanks for joining us, and I will see you soon.
Thanks, guys.
Welcome back once again to Building Windows 10 Games with Unity 5. I'm Adam Tuliper, evangelist from Microsoft, back again, joining us after lunch.
I'm Matt Newman. I am an indie game developer.
And this module, we're going to be covering everything I wish they told me about cameras, or at least a good chunk of it, maybe not everything. So we're going to talk about some good lessons and things that I didn't know when I first started out writing games, and it took me a while to find out. such as using image effects, what you can do with cameras, difference in camera types. So let's get rolling, and I think we got some good stuff for you on this module.
Let's do it. Sounds good.
We're going to be covering cameras and layers and how the layers affect things in 3D and 2D. We're going to talk about animating the camera and camera effects. So to start out, cameras and layers. Every scene has a main camera. It is there by default. In other words, when you create a new scene, it always will have a new main camera. Getting a reference to that main camera is very, very common. So Unity provides you a method of doing that by just calling camera.main. And what camera.main does behind the scenes is it finds the first camera that has a tag of main camera. That's one of the tags that Unity gives you built in by default. And the first active camera that it finds, tagged main camera, that's what it returns from camera.main. And you can do some pretty cool things with cameras, like shoot rays out into the scene and find out what you hit. So think about when you touch the screen. You go like that on the screen. You can shoot an invisible arrow out, and Unity will tell you what it hits. And that's how, when you do touch controls and when you tap the screen and you want to know if you've shot something, you can use something like this API call here, camera.screenPointArray input.mouse position. So wherever you are clicking on the screen, shoot out an invisible ray. And so there's some cool things you can do with that. Now, let's talk about different camera modes, because there's 2 camera modes that Unity will support, and perspective is the default mode in 3D. Let's be specific about that. Default mode in 3D, and how much you can see is defined by the property called field of view on that camera, and we'll check that out. And you have a clipping plane in the camera, which defines your minimum and max viewing distance. So if you look at the image of the left-hand side here, our clipping plane is back here. So this is near and far. I'm suddenly getting memories to when I was a child. And remember those guys?
Wait, what?
Those guys on Sesame Street. You guys don't know those guys?
Oh, okay.
The near and far guys.
Yeah.
I'm not gonna do the voice, but near, far. YouTube it if you if you don't remember. So back here is our near clipping plane, and there's our far clipping plane. Basically says how far can we see in the scene. And notice in this image on the right here, I pushed up the near clipping plane a little bit more, and notice here we can see that chop off. Let's go ahead. I'll use that script that I showed you guys earlier today, and let's go into temp, and we're going to say battle build. Right click on this and open as Unity project. I love that right click open as Unity project, if I do say so myself. I hope you download that and get a lot of use out of that. I seriously use it all the time. Under scenes, let's look at, we'll do level 1.
Oh, I remember this one.
You do?
Yeah.
You remember this one?
I do.
All right, good.
I made a GUI screen for this.
You did make a GUI screen for this. If we're lucky, we'll see it. Come on, load up here. There we go. This is a pretty hefty scene. So let's go ahead and look at this guy. This is a huge terrain, a highly detailed terrain, so that's why kind of a little bit of a delay here.
It's chugging a little bit.
Yeah, we could actually do, this might be a little bit better for performance here. Let's load up complete. And what we're going to do on this demo is I'm going to just show you how we can kind of change some of these perspective values. While this scene is loading up, let's give this a minute to finish loading up. Let's just continue talking, and we'll get back to the scene here. The other type of camera is an orthographic camera. So we have perspective and orthographic are the 2 types of projection that's handled in Unity. By default, in 3D projects, it's a perspective camera. When you go into Unity and you specify here that you want to create a new project, when you select 2D, my 2D project, your camera mode in this project actually defaults to orthographic by default, which has a very, very different behavior, as we'll see, but it's very common in 2D. And an orthographic camera does not, should I say, respect perspective and the way that we see things. It just does not operate the way that we see things, which is good for 3D. There's no scaling like you would see in a perspective. So perspective sees things like we would. You have this cone that comes out. There we go. All right, so our camera here All right, we can see what this camera can see right here. This is a perspective camera. How do I know that? We can see it's 2 different modes here. It's set to perspective. If I change the field of view, notice this is actually one way that you can do like a zoom. When you're doing like a sniper scope on top of a rifle, for example, you can kind of zoom in like that, show a black image on the screen to kind of black everything else out with a circle in the center. So that's one way of doing that. Now the clipping planes here, that's our near and our far. So if we change this, see how I start getting cut off in my camera preview there in the lower right-hand side? So that allows you to define how far out and how close you can see things. A common beginner mistake is you don't see anything in your scene and you realize it's actually behind your camera. This happens a lot in 2D, and we'll look at 2D shortly here. Now on the orthographic side, so again, this is common for 2D. On any new 3D project, if I come into this 3D project and I say new scene, my new camera is there and it's perspective by default. If I go to that 2D project I just created and I look at that camera, it's orthographic. And let me click on that camera. And rather than having this cone that comes out, notice it has this fixed box here. If I change that to perspective, right, this is how we see things. We have this cone of vision, this frustum. We don't see things outside of it. Here's our box, and it goes very, very far out. And it doesn't matter if an object is here, or here, or here, or here. It will not change its size. Everything is the same size no matter how far away it is, which is very different than perspective. In perspective, of course, the farther away something is, the smaller it is, which also allows for effects like parallax. Mm-hmm. Very, very easy. If you move a camera, let's go back to complete here. If we take our camera, and if we start moving it left to right, you'll notice everything in the background stays almost centered. That building way in the background, but the tank up close moves very fast. So we get this parallax effect, which is pretty cool. It's common in 2D games. This just happens in 3D by default. This is how we see things. But we're going to look at this, what the orthographic cameras do on the 2D side. It's very important here, the orthographic camera size. That's how many units is equal to half the height on your screen. Again, very important for 2D, as we'll see, because when you want a fixed height, orthographic is the choice. Perspectives can vary, depends on the viewing size that we're in. If we look over here, our viewing angle on our game can change all the time. Unity has built in a couple different aspect ratios that you can choose here. So 16 by 9, for example. And notice, things scale. You can add your own custom sizes on here. And this presents some challenges when you're trying to make a game and you want to ensure that you are fixed at a particular box size or resolution, important for 2D. On 3D, when you have these free-flowing games, it's not quite as much of an issue. But let's look at our 2D game, the 2D version of the Vampire game. Vamp Kid versus Zombie Apocalypse. While that loads, just so we can have the official demo slide here, we're going to talk about 2D orthographic cameras in this one. Load up level 1. So this project was defaulted to 2D. I mentioned that a 2D camera, in other words, a camera in a 2D project, I shouldn't say 2D camera, that's incorrect. A camera in a 2D project is orthographic by default. How do we know any of this? If we go to Edit, Project Settings, Editor, you'll see Default Behavior Mode 2D. When we choose a new project and you do 2D or 3D, that's what it selects. And it does a couple important things. On a 2D project, it changes your default cameras to orthographic. It enables this by default, which, big deal, you can click in and out of it at any time, even in a 3D project. It also takes your images that you import into a project, and it makes them a texture type of sprite. So notice that this image here, any image I click on, fine artwork by Mr. Newman.
Oh, thank you. Thank you.
Any 2D image that I've dragged and dropped into my project comes in as type sprite. In a 3D project, if you do not have it set up like that, so I'm taking a little bit of a sidestep here to kind of talk about this. Let me take this image and drag it into our other project that we've been using here. I'll take that platform image, drag it into our 3D project. Notice, look at the image, look at the sides on this. It's all kind of white. I can't drag it and drop it into my scene. Whereas over in this guy, I can literally just take it and drag it up in here, and away I go, like I'd expect to do it. So 2D defaults these images to a sprite, and 3D they just retain a texture. So just a little side thing there, because it's important to realize what differences when you select a 3D versus a 2D project. So let me delete this one from this project, and let's go back to VampKit and let's look at our camera here.
Also, too, when you do sprites for 2D, it's going to alpha out any alpha channels you have in there or anything like that. Whereas when it comes in as texture data for a 3D project, it doesn't really know exactly what you want to do with it. It's just looking at it as, okay, it's an image file. How do you want to now use this texture? And then you have to go in manually and set the different texture settings for that specific texture.
Exactly. What Matt's saying here, that white location on the side here, and look over here, how it's perfectly transparent, right?
Yep.
Like we'd expect it to be.
Exactly.
2D in Unity was possible previously before they integrated their support for 2D, but you had to use third-party toolkits or write your own because you couldn't take this and drag it up. Like literally a texture like this is meant to be assigned to an object. I could notice what happens. When I drag down under there, see what happens? So you would assign it to a quad. So thankfully they added this 2D support, which is pretty cool.
And also, if you start a project with 3D settings and then decide, oh, I'm going to start doing 2D, right? It's going to keep those initial 3D settings. And I've had that issue a couple times. You want to make sure if you're doing a 2D project and you want to have that feature available, so when you bring the images in right away, it knows that this is a sprite. Essentially, you got to have the 2D setting set up. If it's set on 3D, it's going to come in as a texture, and then you have to go in and change it to sprite every single time.
Good point. If you accidentally or decide later on you want to go to that 2D mode, again, edit project settings editor, and just change your mode over to 2D, and then bam, you'll be good to go. And now anything else you bring into your project acts like 2D. Otherwise, as Matt said, you got to go through and check it off. And
it's like an extra step, basically.
Yeah.
It's not a huge deal, but
it's kind of a pain if you have like 100 images.
Yeah, exactly.
All right, so this guy here, this main camera, notice the box. This is great for 2D because this kind of matches the layout that I want here. If we look at this, I want this kind of boxy layout. This works well for me. And if I change things like the size, see what happens on the camera? It's kind of like a field of view and perspective, but this is size here. And this size will be fixed. So whatever you are looking at here, this is exactly what you will see on a target device in terms of height, not in terms of width. The aspect ratio for an orthographic camera, in other words, this guy here, the aspect ratio determines the width. So ideally, on a 2D game, you come in here, set your orthographic height, and sometimes people want to set that height based on a particular image in their scene. And there's a bunch of scripts out there you can find. Your sprites, you can specify pixels per unit of 100. You can actually go down to 1 pixel per 1 unit, and you know exactly how many units are on the screen. So you can make this pixel perfect, map it out exactly towards your orthographic camera. A whole bunch of different ways to spin this. I just want to show you kind of the layout here, that if you're going to do a 2D game, make sure that your orthographic size fits like that. Now your height will always be set, and your width is aspect ratio dependent. And you might say, well, what happens if I need to change that? Then you have some difficulties, because then you have to have artwork that maybe scales differently. And we're going to look at a brief example of this when we talk about the UI in the next module. But there's challenges. You have to basically ask yourself, well, how am I going to scale? What am I going to clip off? Because you can't change aspect ratios without clipping something off or making it skewed in an improper way. So there's no other way around that.
Absolutely. And you brought up a good point, too, in terms of pixel perfect art. When, for example, you're making a game and you know it's going to be for, let's see, 1920 by 1080 for HD TV, right? You're going to be playing it on a console, whatever, but it's a 2D game. right away, that's a great model to know that, okay, my artwork has to fit within 1920 by 1080.
Yeah.
Use that as your canvas within Photoshop to create your artwork. Bring it into Unity, make your canvas or your orthographic camera the same size as you would an HD television, and right away you're going to get a perfect example for pixel perfect art.
Boom, you got it. Yeah.
It's like a 1-to-1 ratio. So very, very easy to get that kind of effect, essentially.
Cool, cool. All right, so make sense?
Yeah.
Makes sense?
Great.
The setup is pretty basic. Field of view on perspective versus size for orthographic. And again, make sure you get rid of kind of like those borders. That is going to be your height. Your width is going to be set by your aspect ratio. End of story.
Cool.
Layers. Layers are important on a camera, both for 2D and for 3D and outside of just a camera. So one use case for layers are to show or hide what the camera can and can't see, to filter out something for either performance, or I'll show you a little mini-map demo in just a little bit. But you can also do things like, I want to send out a ray, and I only want to hit things that are on my enemy layer. Maybe I have like, I don't know, 1,000 objects in my scene. I don't care about hitting tanks. I don't care about hitting buildings and maybe animals walking around. I only care about where the enemies are. And I want to shoot out and see if I find one. I can put all those enemies on a layer, raycast out, and say, only return to me things that are on a particular layer there. So that's one way of doing it. You can use camera layers to filter out what we're going to see, and I'll show you a demo of that when we look at doing a mini-map. And then you have, actually I just realized there's something incorrect on this slide here. Sorting layers. Really, they should say how to render what order everything is displayed in.
Yep.
Super easy.
So basically, like in a 2D project, the background from the foreground.
Yep.
If your player character, say he's made up of several pieces and he's moving, you have your arms, your head, your body, your legs, things like that could all be under a player sorting layer.
Absolutely. Well, we're going to look at a 3D example. We're going to do something with a little mini map here, and then we're going to look at a 2D example. Sound good?
Great.
All right. So let's take our 3D project here and go to, this one will work fine. When we look in our game window here, imagine we want a little mini map in here somewhere. And think of a lot of games that you play. You get a little map, you can see characters running around. It may or may not look like the scene that you're looking at.
So like, I want to see where all the zombies are in this level.
Yeah,
Gotcha.
exactly.
Gotcha.
Or maybe, my view this level is pretty limited. Maybe I want to see the entire map.
Yeah.
So I can see exactly what it looks like.
How do I get from start to finish?
Absolutely.
Yep.
All right, so we can do this in a couple different ways here. Let's do a basic way. Essentially, we want one map that's going to show us something like this, but projected into maybe I have a coin square there, so maybe we'll just project it into the lower corner down here. Let's go ahead and create another camera. And by default, it's a 3D project, so this is perspective. So we're going to rotate this camera to look down. Unity uses the left-handed coordinate system. So picture, got my left hand up here, and here's my camera. It's looking out. If I want that camera to rotate down, what axis am I rotating around? My X, right? Actually, like that. So I'm going to rotate around the X by 90 degrees. So these are degrees here, 90. There we go. It's kind of, now, notice how misleading this is. This is kind of the tricky thing in 3D. It looks kind of like my camera's looking over there, but as I move up, look how that completely looks weird. I'm like, whoa, what am I looking at here? So sometimes these views coming from like the right or the side can help. Like now I can see, all right, perfect. Now I see where I am. Maybe like that. Now I can actually go to my top view, zoom back a little bit. Now I can see exactly kind of what I want to see. Maybe I want to show something like this in my mini-map window. Maybe I want to rotate a little bit to fit a little bit more in, something like that. Move it down a little bit more. That kind of looks like a pretty good representation of the level, right?
Yep, perfect.
So let's save my changes so far. Now this particular camera, notice, it's pretty much just stomped out what the other camera was seeing. If I uncheck it, they were back to our normal view. If I check it again. So we've got kind of a problem here with that. We're going to, first of all, take this camera's depth, and we're going to change it. And notice, a camera with a larger depth is drawn on top of a camera with a smaller depth. So I'm going to change this to 1 because I always, always, always want my mini-map drawn on top of the other camera. Now, viewport rectangle here, we have an X and a Y for position and a width and a height. Notice, see how I can kind of change what this camera's position is here? From my viewport. Now, this isn't changing in space. It's changing how it's mapping to my viewport here. So let's change the size of this. Let's kind of make this a little boxy.
Would we want to make that camera orthographic also to get?
That is one option that you can to flatten everything out as well. Yeah, you can definitely make this camera orthographic as well. So there's a rough little mini map in the lower right-hand corner here. Let's go to 0. Now, the thing that I don't like about this right now is I've got my level here, but it's also re-rendering all these lights from above. It's rendering this terrain here. That's extra added performance that I don't necessarily need here. So let me save my changes so far. Let's just run this and see what this looks like. All right. Now, I can do different nifty things. So I could write a script that, as my character turns, rotates this camera. So it kind of seems like it's following my player as it turns. That's one way of doing it. But I just want to address kind of the performance consideration here, that this whole terrain here, I don't want it to be shown in this mini-map. So I can take my terrain, which is selected here, and I can assign it to a layer. Let's add a layer, and we'll call this terrain or level. Since it's named terrain over here, let's keep this terrain here. It doesn't have to match, but just kind of for consistency's sake.
Now, one of the reasons that we're going to be tagging this kind of stuff is essentially performance gain, right? We don't want to render the entire level in a tiny camera because we're basically doubling up all the draw calls. We're showing way too much to the user. They don't need to see all these little details. So basically, I assume you're going to occlude all these different elements and then shows particular
elements. That's it. And
okay.
So performance is a great reason here, but also I might not want to see the whole rest of the terrain. It kind of might muddy up the view, or maybe I want my own custom view here. Maybe I want to show a new interface inside of here. Maybe I want like a white level. Remember we created our border before? Yep. Maybe I want that border, I want something like that, maybe like a white background to show here, but not in the other camera, right? So I can hide it in one case and show it in this case.
We could have it transparent too, right?
The border?
Yeah, the secondary camera with the map view, like behind it, could that be transparent?
I haven't done a transparent, but I would imagine that we would be able to do that.
Oh, okay.
I'd have to think a little bit about doing that, but I wouldn't imagine why we couldn't.
Yeah.
Let's take, so the terrain, we added this layer. We call it terrain, but we haven't actually assigned it yet, so I'm just going to assign it to that layer. Do you want to change all the children because it says there's child game objects here? Absolutely. Now, we need to tell that particular camera that we do not want to essentially render the terrain on there. So let's go back down to this new camera we created, and I'm going to call this camera Mini Map Camera. And in the Mini Map Camera, our calling mask here, notice there's everything. I'm going to scratch out terrain. Boom. Terrain disappears there. And now we have just kind of this clean area, which we could actually probably change up a little bit more here. Maybe even change the field of view so we kind of maximize that space there. Something like that. So we don't see the rest of it there. We don't have to worry about all that dynamic lighting at the bottom there. So better for performance sake, and it's just kind of a little bit cleaner looking. Now, granted, we probably want to make this a little bit prettier. Maybe, like you said, throw on something cool, make this transparent, or even with like just maybe a lightly shaded background here that we can see it a little bit easier.
What other things can you call in the culling mask?
So anything that we want to, any of our own custom layers that we want to specify in here, they give you a bunch by default, but we can throw all of our own custom ones in there as well.
Cool.
Play that. Let's look at this. There we go. Now, another thing you could do is you could take all of your characters, and they're really small down here. Like you can see the little green flickers there. They probably won't even show up on your end. There's a tiny little green flicker on my end here. We could also call out the zombie and the vampire, and just have a script that projects him here as a big cube or a big sphere, right? We can do all sorts of cool things in there. You see that a lot on mini maps in more, you think of like battle type games where you see like the enemy circles kind of moving around. You don't actually see the character, you see a big red circle, right?
Yeah, and will they have like a circle sitting far above the character, like above his head basically, and they cull it out of one camera, but they show it in the other. And in the other camera, they're culling out the character, but showing the cube or the graphic or whatever, which lets you do a variety of things. You could use a sprite, make a custom sprite kind of iconic icon that you could sit above the character, have that way up there, have it showing in one camera but not in the other. Absolutely.
Cool stuff.
Yeah, awesome.
All right, let's go on. So that was the regular layers. Let's now look at sorting layers. So Matt was talking about earlier about being able to filter out, show the order of 2D stuff that you want to do. So let's go over to our 2D game here, because that's where the sorting layers apply. Now, the sorting layers are not shown here. Our sorting layers, it's a little bit misleading because you see all of the layers. If we click on this layer drop down, here's all of the layers that we're kind of just looking at. And then we have separately sorting layers. So the sorting layers are specifically used for 2D. If we edit layers, we can add all of our own sorting layers here. And on this one, there's always a default. And there's 3 rules that happen here for the order that's going to get drawn out. The first is the order of layer. So default is drawn out first. Background will be drawn on top of that. Layer on top of that. Players on top of that. Particles. My new layer would be drawn on top of everything else. So if I took, in this scene, and I took this tree, and I dragged it up here, right? This guy's behind everything right now. If I set its layer to my new layer, this is now drawn on top of everything else. So that's rule number 1. Rule number 2 is order in layer. So let's duplicate this guy. Control D to duplicate. And now maybe I want this guy, he's on the same layer, but he's behind him. Maybe I want this guy in front, but on the same layer. Now I can specify order in layer 1, and now he's the one that's on top all the time. So we can customize within a layer. A great use case for this is if we have all of these guys on level. But now our tree is also on level, and maybe we want our tree to always be rendered on top of everything here. So use case for sorting layer, and then within each layer we have our ordering layer. And then lastly is our Z position will be used. So the most important one is sorting layer, and then within each layer we look at ordering layer, and then after that it is our Z position.
And this works great too, not just for level layouts, but also for characters, right? Let's say you brought several pieces in and you're building a character out. You could essentially put all those pieces within a player sorting layer, essentially, and then have each one of them as a different number in that layer. So according to
so like if I had
a
side view of a 2D character, and I wanted his arm to always be kind of like in front of the body.
Absolutely correct.
Cool. Now, one of the things that it might not be very apparent, like why would you ever do something like this? Behind the scenes, let's see if we can actually get Unity to do this here. Let's take this is level. Let's put this on our level layer as well. 0. You'll find that sometimes you get this very inconsistent response. Sometimes you can duplicate it, and sometimes you can't. You'll find that everything looks fine in your scene view, but then you play your game and things are randomly disappearing. Because they're on the same layer, they're occupying the exact same space, and Unity is using its own rules behind the scenes what to show. Well, why would it be doing something complicated like that? Because these are really complex objects behind the scenes. They look like simple sprites. Behind the scenes, they are wireframes. Everything that your graphics hardware displays, everything, gets through a process called tessellation broken down into triangles. So if you notice, even a tree is broken down into triangles through this process called tessellation. And that is how every single piece of graphics hardware that's in this room, and everybody that's listening right now, every single piece of graphics hardware that they use also uses a process of tessellation to break it down into triangles. So there's a lot of complex rules that can go on behind the scenes on who overlaps where and when. So it's very important that when you are in 2D to specify exactly what layers you want and exactly what order and layer that you want as well.
And is it possible, if they are in a conflicting layer like that, you can separate them using like Z values? essentially.
Yeah, so if they are in a conflicting layer, so if they have the same layer and the same order in layer, then the third value is Z
Okay.
to be able to change as well. So 3 values.
Cool.
All right, let's look at some camera effects next. With camera effects, you can do some pretty professional-looking things to your scenes. A lot of third-party ones available. If you go in the Unity Asset Store, you can get all different camera emulation modes. Really,
Like blooms and
really neat stuff.
fog effects, all kinds of stuff.
So Unity gives us a whole bunch of effects, which we'll look at by default. But also, for like the really hardcore photographers and people that really like to frame their images just right, there's some essentially filters that will model existing film equipment out there to give you a particular view towards a particular type of camera. I'd like some people get pretty intense on this.
So yeah, there's like vignettes, there's like old style film, there's like retro film. Like you can do a lot of really cool film effects with a lot of these plugins that exist. Very, very cool stuff.
There's we get a pack that's provided by Unity by default, which we'll look at a couple of those. Some of them are optimized for DirectX 11, so meaning that on your desktop hardware, they would perform the best. Some of them are going to be tricky on mobile because of the performance hit for them. Something like Camera Shake is a simple script, and we'll look at that. Again, the idea here is that some of them are better for desktop, especially because you have a bigger screen to look at too, but because they're more processor heavy,
Yep.
so you can do a little bit more and get away with a little bit more. All right, let's look at a couple camera effects here. Let's go over to our guy here. I'm going to hide my mini map camera. And let's look at our game view here. Let's say we want to make this, I don't know, old school, right?
Yeah.
We want to go a little old on this. Let's find our camera here. There's our main camera. Now, under Component, Image Effects, notice we have a whole bunch here. Well, where do you find them? If you Asset, Import Package, Effects, this will load them into your project. And we're going to add some of these effects here. So, Image Effects, if we want bloom. Find that kind of happy medium here. And you can change these values. We'll animate one of these in just a little bit here. I just want to go through kind of a couple effects here. Like that. That's got a cool, nice initial look to it.
You'll see a lot of bloom effects in like fantasy-related projects,
Yeah.
like going through forests, things like that. It kind of adds almost like an ethereal.
That's true, right? As I go here, because
Yeah.
you have this like glow.
Yeah, looks almost very magical in a way.
Yeah.
You know, and that's a cool thing. Like you want to think about if you're doing a game that can support, if you're using a platform that can support these type of effects, take advantage of them. It's only gonna enhance your product in the end. You want to give people the best experience possible when they're playing your game. So why not use one of these effects to just really kind of enhance the experience?
And you can dynamically turn these on and off. Maybe if you're in a magical area of the forest, you can turn them on, and you can control them in script. Remember we looked at our get component call? You can enable and disable very easily in code.
Yeah. Or if you're like in a dream sequence or underwater,
good
even
point.
there's all kinds of uses for these camera effects.
Let's look at a couple others, shall we?
Yeah, absolutely.
Because these are pretty cool. Let's take depth of field. You're a photographer too, aren't you?
Me?
Yeah.
Occasionally, I dabble in photography.
Wrong one here. So change this so our things up front, think of our f-stop if you're a photographer. We can change our focal distance so things up close are a little bit more in focus and things farther away. And any of these parameters you can animate. So let's look at this one. Will bring us into the next one too. So let's check out this guy here.
It'll really make your project look a little more cinematic than just a standard kind of your standard camera. Adding these effects, it just gives it that extra bit of polish that's really going to make your product go a little bit farther. And there are some mobile ones available too. Look on the asset store, but people have gone out of their way to create some plugins that work great for mobile that do this exact same thing.
Watch as I change my focal distance here. Doesn't it kind of look like I'm focusing in on this, right?
Yep.
When I use my camera, my video camera is actually my main camera. When I do video on there, I have to manually focus it in. So
Yeah.
a lot of my videos kind of look like this. So if you wanted that sort of effect, we could animate something like this. Now,
Yeah.
how can we animate something like that? Add component. animator. Let's expand that here. And we need an animator controller for this. So there's a shortcut we can use here, actually. We can go to the animation window. So we can just load up window animation. So there's two components, our animator we looked at before with our Unity animations, and open up our window animation window. To begin animating the game object named main camera, create an animation clip. All right. Create it, we'll call it camera blur. Actually, I put this in my scenes folder. I should probably put this in another animation folder, but I can fix that easily. You can drag and drop your stuff inside your Unity interface without a problem. And in here, I want to change my focal distance. So let's start out here. I'm just going to modify this value a little bit, and it writes out my initial value. And it's red to say, hey, we are now recording this value. We're not recording it like across this timeline. You're logging what's called a keyframe. So it's starting out with 53.8. And now, let's say over here, at a half second, I want to be maybe there. Now we'll go between those two values over and over and over again. So let me zoom back a little bit more, maybe go to like a second and a half, and maybe overdo it to this way. So now we have kind of this auto, maybe something's blurry. You're either coming out of a dream, you're waking up, or maybe this is the view through a camera that you specifically want to look like somebody's focusing it.
Yeah, maybe it's like a handheld camera shot or something in a game. It's a security camera or something like that. There's a multitude of different things for it.
This is all red because it's in record mode. I can get out of record mode, click play, and that's it. It's going to be animating for me.
It's like we had an online question real quick. How much do camera effects affect performance?
Yes. How much do camera effects affect performance? It depends. It depends what you're doing. It depends which effect you're using. It depends what your graphics hardware can support. It depends if any of that can be offloaded on your graphics hardware or if it's all CPU based. So the answer there is it depends. It can affect it a lot if you're doing a lot of effects, a lot of intensive effects, but it really depends. You'll find that some of the newer Unity effects have optimized versions available. If you look at the docs on Unity site, it'll say this is our new DX11 optimized version.
Yeah.
So it all depends on which one you're using in your hardware as well.
I would say as a rule of thumb, most of these camera effects work better on console and PC. Just something that has a lot of horsepower that can handle these effects. There are some, like I mentioned before, there are some effects out there that work for mobile. A lot of that is kind of faked in a way. They're doing some very interesting things with post-processing to make that happen. So there are some available. I would say most of them are more for your higher end devices.
Yeah.
Because you are going to take a hit. I mean, it does add a lot of draw calls and different things to it. But like you said, some are optimized for DirectX 11 and certain graphics cards. So yeah, absolutely
Test it
play
out.
around them, test it out.
Test
see
it out.
what
That's the only way to tell.
Yeah, if you're getting major draw calls off of a certain effect, then obviously maybe that one's not working. Try to find something comparable, that kind of thing. It is a little bit of trial and error in it, but that's kind of I would say the polish end of your product. Once you start getting your game working, it's running great. Then get in and start doing these things and seeing how can we push this a little bit. How can we really enhance the effect and that kind of stuff.
And we'll look at a quick example of the profiler at the end too, so you can kind of get an idea on how things are affecting.
That's really, the profiler's awesome. It's really going to show exactly how much performance hit you're getting from these type of effects.
Let's add one more onto here. Let's do a component, image effects, and let's just see what kind of looks good here.
Is there a tilt shift in there?
There is a tilt shift. Tilt shift is under, there we go. So tilt shift is the effect that, it's neat. If you take a picture of people on a beach and you ever see the images where they make them look like little toys,
Yeah.
it's the tilt shift effect. So let's add tilt shift. Let's clear off depth of field. Okay, now let's change some of our tilt shift values here. So blur area. You can define what areas are in focus and are not in focus, which really gives you that toy look inside of certain images. It might be kind of hard to tell with the scene that we're set up with here, but that is a pretty cool effect to get that. I know what else I want to show you guys. One more effect. This is very common in games. So this is actually with the code. So during the break, as I mentioned, I posted the code out there. So it's Adam Tuliper on GitHub /VampKid3D. We are going to be making changes here. The code is by no means perfect yet, so we are developers as well. So we go through, we iterate, we fix. If you find anything on there, let us know. I'm definitely aware of probably at least 12 bugs that are in there right now.
We're version 0.0.2 right now.
Yep. So you'll find some code in there. Now, I do want to give credit, and I think I actually note in the actual source code files where I found this on the net. There's a pretty cool camera shake group of scripts here. I think they only work if your camera is located at 000. So maybe I'll have to make some modifications to this code to work in different scenarios. But underneath the scripts folder, there's some different camera shakes and different camera shake modes. So Perlin shake, periodic shake, random shake. And so all I've done is I've added over here the Perlin shake to my main camera. And we can trigger this off in script, or we can set this little checkbox true. So if we look at the code here, let that load up.
And camera shakes are great for things like, if a T-Rex
so many
was stomping
things,
by, a bomb just went off.
Player gets killed.
Player gets killed. There's a variety of uses for using camera shakes, and camera shakes add a ton of drama to your game too. Disorienting the user at the perfect time always, drives the point home a little bit better than just having just some image appear on the screen.
And be careful too. If you find these scripts, you're like, I'm going to use this and place this in this project. Caution, because like in this project right now, we have a third-party character which is running around, third-party character controller, and then we have a freestanding camera rig which is always following it and rotating around, looking at it. So if we suddenly try to shake the camera, well, this is going to try to this is trying to auto-correct its position based on the user, and we have something else shaking the camera, so it might not work as expected. In that case, I would actually use two cameras, disable one, shake the other one, and go back to the other. So there's different ways of doing this. But here in the code, there is the location. I got it up top. And if we go ahead and click on the test button, this just shakes on the spot. So let's see what this actually does here. It uses a coroutine we talked about earlier. Let's play. And let's crank up. We'll try the small one first. This is going to be very, very tiny here. So you can see my focusing is still happening there. This is too small, so I'm going to make this magnitude to 0.1. Still pretty minimal. Let's do like let's do 1. There we go. Did you see it?
Yeah.
We'll do magnitude 5. Now you saw it. The speed, I think, if you hit something, the speed should probably be a little faster. There you go. You can almost hear the sound effect in your mind, like, right? So real easy to add. Trigger it off once, it shakes your camera, and you're back to normal again. Which is actually kind of good that we're this fits the focus right now. It's all shaky. We're going in and out.
Yeah, totally.
All right. So some cool effects you can do there. Hopefully you picked up something neat from that. Next, let's talk about animating the camera. We kind of went over this process just a little bit. Cameras are game objects. You can animate any game object. It's very easy. If you're going to use multiple cameras, make sure you disable one camera and activate the other one. Unity's working, they've announced on the roadmap this feature called Director, which is going to allow this timeline where you can really say, hey, take this camera and pan it over here. Meanwhile, move a character over there and do this. Right now, animations are limited to a game object or its children. The Director is going to be, they showed it last year at Unite. Hopefully all these things overlapping.
Yeah, I don't know if anybody's seen the blacksmith demo that Unity put out there. Very, very cool. It's almost like you're kind of in charge of directing a scene, essentially. You can have all kinds of things trigger in a complete timeline, and you're kind of orchestrating this whole thing that happens. So great for cinematics, great for just initial gameplay element, all kinds of stuff. So really exciting to see that, to see when that comes. It's going to be awesome.
So check out on Unity's website here, Pages of the Blacksmith. We mentioned it, I think, in the first module today. Play this, check it out. They've released some of the assets for this. Really phenomenal.
Oh, that's right. Yeah, the assets just came out.
And, I mean, the quality of everything, using a standard shader that we talked about, physically based rendering, really neat stuff. All right, so let's go back. Moving cameras. Let's look at a quick demo of animating a particular camera here. So let's assume that we want to start this camera out. We already have an animation defined for this camera, which is okay. If I look at this, here's the animation controller. We looked at this earlier with a zombie. Right now we have one and only one animation. That's our camera blur. So we want to create another animation, and we can do that in our animation window here. Let's highlight our camera. You have to make sure your camera's highlighted. I'm going to drop this down and create a new clip. This is a new animation file. So the two things required for animation are the animator component on your game object and a .anim file. Now, the animations I did on the zombie earlier was because Matt had already created essentially the animation data in another tool that got imported in Unity.
Yep.
We can create our own as well. And we can see what an animation looks like. If we want to look at what a zombie animation looks like, here it is. So Matt had created this in Maya. I believe you did your animations in, right?
Correct.
And look at all those keyframes and data. So a zombie idle takes the chest, front, back, and does this along some timeline. We can actually preview this.
And there was a couple questions earlier, people asking, well, can you do some of these animations within Unity? And so as it stands, you can't really do it within Unity. You really need an external tool that's specific for animation, for rigged characters to do that. But there are some pretty great tools that people have launched. I think one of them that just came out is called Skelly, and that'll actually let you take a rigged character and animate it within Unity just by keyframing joints and things like that. So yes, it is possible. You can do it. So just a heads up on some of those questions I got earlier. I saw some.
Yeah, this guy right here,
about that.
Skelly.
Yeah.
I'm a proud owner of Skelly. So yeah. Complex animations, when you look at all the data that an animation tool makes, it's like, wow.
Yeah.
I mean, even for 1/10 of a second, look at all that data that was included just there for 1/10 of a second from this area over.
It's a lot of keyframes.
That's a lot.
Also, I whenever I do animations in Maya or Blender or any other program I'm using to make my rigs, I always bake all my keyframes because I want to make sure that the animation that I created within Maya comes in exactly how I made it within Maya, right? So part of the reason you're seeing a lot of those keyframes are in there is because I literally baked that entire sequence, every single frame. So when it came into Unity, it had all of that data on every single frame. That's not always the case.
Because if not, it'll kind of interpolate some of that data.
Exactly. Sometimes, if you don't bake your entire sequence, Unity itself will try to interpolate those specific movements, and it'll try to tween in between it for you, and you might not get exactly the result you're looking for. It might be slightly off. So as a rule of thumb, if you create an animation in 3ds Max or Maya or Blender or whatever it is, bake it out before you bring it in, because then you'll ensure that you're going to get exactly what you created in another program in Unity. It's kind of like a one.
It's funny because going into like the world of game development and art, this term bake, I'm like, what the heck does bake mean?
And
it's
everywhere.
It's all over the place, right?
Yeah.
It's when you basically take some sort of settings and pre-calculate ahead of time and set it into something.
Yeah.
That's bake.
Baking.
So you're taking that animation data and baking it, or in the case of lighting, we are pre-calculating ahead of time and baking it, making an image from it so we can have it pre-calculated and use it later.
You'll hear the term, if you're new to game development, you will be very familiar with the term baking in a matter of weeks.
Absolutely.
You'll be light baking, you'll be baking animation, you'll be
baking cakes,
baking textures. There is a lot of baking that's happening. And basically, yeah, like you said, it's just basically calculating behind the scenes before you actually use it. So I guess the term is
bake.
It makes sense.
All right, let's go ahead and take our camera. We already have that blur animation here. We're going to create a new animation, so make sure your camera's highlighted while this window's open. It is context sensitive, so make sure your camera's highlighted. Drop this down. We're going to create a new clip. And this particular clip, since I already threw my one in the wrong location here, I'll do this one there as well. We'll call this camera fly by. Nothing's pointing to this right now, but I can still test it out. I can still develop against it. So my camera is currently there. For my flyby, I'll start there. So I'll move this object just a little bit so it logs its initial position. Oh, let me go in the record mode here. Move that just a little bit. There we go. Now we have recorded its initial position. I can even fix this back up to start it. 0, 0, 0. Now at, say, let's go to 2 seconds. And at 2 seconds, maybe I want to be here, there, over here. And then maybe at 4 seconds, let's come down in and we're going to do a little rotation here. So let's go and rotate around the X. By X, I mean X, not Y. Again, as Mark said earlier, we can just click on these letters, which I like to do sometimes. Let's kind of flatten that out a little bit and move this down. And then finally, we'll maybe come by for a fast, maybe like 10 seconds over here, and we'll rotate it around our y-axis. Something like that. Let's just see how that works. All right, so our animation is done, and it's just going to repeat over and over again. But now if I want to trigger this animation off, come over to that animator window. Let's stop our recording and playing. We need some way to get over to our camera flyby, and let me maximize this. And let's go from our any state to camera flyby, and once we're done with that, we're going to exit back out and go back to our camera blur state. How do we get to camera flyby? By adding a parameter, a trigger. We'll just call that flyby. And we'll say that when this transition from any state to camera flyby will be triggered. In other words, it will happen when somebody sets that value to true. In other words, when they set that value. Since it's a triggered, it's not really true or false. It is behind the scenes, but you just click it and it just happens. So let's watch this here. We'll click play. Pop out my animator window. So I'm blurring right now, and we'll see camera blur. Let's go to our game tab here so we can see that. Now if I want to trigger out that flyby, there we go. I clicked it once. Now it's still blurry because I happen to trigger this in the middle of a camera blur. And now we go back to the kind of that initial camera blur location and settings there. So we can overlap these, we can trigger them off, just like we did with the zombie. We can change any of these values here.
And that's, like we said before, just using that, little things like that, like tweening your camera, adding in these post-processing effects or camera effects, all that's just going to give your product that much more of a little more quality edge. You'll notice a lot of products that are out there, they do that because it really just gives it that extra little layer of polish that I think it needs. So, if you're an indie game designer and you're doing things for Steam, go nuts, man. Get all the best, camera effects you can find and use them, really make that product shine, It's awesome. Cool.
Awesome. Well, that's it for this module. Next, we're going to talk about UI and
particle effects.
The wow factor.
Wow. I actually had a lot of people hit me up on the forums, and they were talking about, how do you create particle effects, that kind of stuff. So I'm not going to go a lot of magic spell questions, things like that. So we'll show kind of some initial pieces of what you would need to create something like that, but I'll kind of guide you through that whole process, and we'll get rolling with it. It'll be cool.
Cool.
Awesome.
See you shortly. Welcome back once again to Building Windows 10 Games with Unity 5. Matt Newman joining me on this module once again, and this one we're going to be talking about some cool stuff, UI and the
particles. Awesome.
Wow factor. You're not supposed to tell them what the wow factor is yet. It's a surprise.
Wow factor.
But while we're talking about particles are cool. You're going to show a neat demo with particles.
Yes.
There are so many things you can do with particles. Well, we'll talk about there. It just gets me excited. I want to talk about particles and,
Whoa, calm down.
Potions and magic and listen.
Particles are pretty much everything, right?
So you couldn't help yourself. You start rolling on it, right?
They're going to give you that. It's a low hit and cost of the CPU.
Very efficient.
It's very efficient. It's going to give you that extra kind of animated quality. Things will feel like they're moving. You can use them for bullets to magic to
wait till
smoke,
you see what we can do with particles.
You could even use them for clouds. You can use them for rain. You can use them for explosions. Anything. So
anything.
Particles are your best friend. I would say learn the Shuriken system very well in Unity, and I'll show you some demos on how to kind of get your feet wet with it and start doing stuff with it.
Amazing things with particles.
Yeah, and from there, use them in everything you do. I mean, when you're you know, and there's different stages of particles too, and we'll get into that when we explain it. But you know, you really want to think about the particles and what you can do.
Potions and magic and snow and fire and smoke and
Very cool. Gore, you know.
bats, gore, blood.
Yeah, whatever.
Let's start out by talking about the Unity UI.
Okay.
And then we'll look at the wow factor after that. Unity UI has a little bit of a history behind it here. What is Unity UI? Well,
What is Unity?
so this allows placement of game objects in your scene that will overlay, ideally, overlay onto your screen. So we looked at a heads-up display, coins, things like that.
Yep.
You can drag and drop like a coin up in your scene, or you can actually project things from other areas. Maybe you had a 3D model running around somewhere else and you wanted to project out on your screen. So you can do some really neat with that. As we're going to see, this is meant for layouts. Like it's meant to overlay on your screen, give you a UI, something that pixel perfect layouts, scaling your layout screen, scaling your screen.
Yep.
Right? If you have a coin we saw on our display for a game, how do you scale that out? So we're going to look at some things that you can do based on that.
You even add particles to UI as well.
Can even add particles, text and image components, plus the code to operate them, form the bulk of nearly any UI component that we're going to look at.
Yep.
There's a text component for displaying text on your screen and an image component, which is different than the images that we looked at which is slightly different than the images we looked at when we looked at the 2D project with orthographic cameras. But text and image components give us the bulk of what we see with our UI components, as you'll see shortly. Initially, there's a long history on Unity UI. They had a very inefficient old system, and they had mentioned several times there was going to be a new system released, and it didn't happen, and everyone's like, when's it coming? So finally, they in the later 4.x version, I think it was 4.5, was when they first announced the Unity, what they initially called UGUI, now it's Unity UI, and it was initially formed, from my understanding, off the base of NGUI, which was one of the #1 selling assets of all time in Unity Asset Store, to be able to really create really powerful layouts on top of your screen. Really neat stuff with that. And then, so this was kind of initially based off that. Actually, two folks that did NGUI and Unity worked together. There's a whole story you can watch on Unite when they talked about this whole process and their old UI systems and the history of it. But now we have Unity UI. So let's start talking about what's required for Unity UI. Everything's inside of a canvas, and you have various canvas modes. Those UI elements, so for example, if you want to display a coin in the upper left-hand corner all the time, that must be inside of a canvas game object. Must be. By default, you'll see it's going to create an event system, which is going to detect things like clicking when you click on a game object in your canvas. And so the event system will detect those actions and send them, and I will show you that as well. And a canvas has 3 modes. If you look on a canvas game object, there's a render mode, and it's a screen space overlay, which is kind of what you expect when you think about like a HUD, a heads-up display.
Yep.
It's overlaid onto your UI. So there's the overlay mode. There's a camera mode, which is, in other words, there's some camera in your game looking at something, and that's going to be overlaid on top of your UI. And now they've also added world space canvas. So you can actually take everything we're going to show you in a canvas and throw it on a door somewhere inside of your game, right?
That's cool.
You can throw it around anywhere in the world, so it doesn't have to be overlaid on top of the screen. It can literally be a game object inside of your world, but still act like a canvas and do all the cool things a canvas can do.
Very cool.
Oops.
That's a world space canvas? Is that
World space, yep.
Cool.
There's the rect transform. So to date, we've looked at a game object, and a game object had the basic properties of a name, a tag, and a transform. And you'll see that when you go to the Unity UI system, you're still dealing with game objects. But to help you out and to make a little bit more sense, because of how these are laid out, you get a rect transform object. And we're going to look at that, and it makes it super easy to deal with these 2D elements that you're overlaying onto a screen. You can define your location, your rotation, and the anchoring system, which is used for positioning. You can also use pivots for your rotation, and you actually have a size, width, and a height, for example, that you can specify on these. This makes it really easy to work with. So let's look at a demo of that. A good project to start out with here would be this one. We've seen this a couple times. I will pause the music for those that have expressed concern in the studio. They've heard it too many times today.
I love that song.
I like the song too. It's getting scrolled on me quite a bit. So I'm actually going to keep one of those filters on here. You know what? I think it adds a little mood here. So I've still got the effect on the camera from the last module. And I've actually added Mr. Newman's latest zombie
right
that he
on.
gave to me at about 4 in the morning last night, and was wondering, at 8 o'clock this morning why it wasn't in the game yet.
He says that, but it was really like 2 weeks ago.
That is so not true. I have the bags under my eyes to prove it.
So actually, this brings up a good point.
Yeah.
So
Turn this music
if you
down.
notice from before, we kind of had these green kind of amorphic kind of zombie guys running around, right? And those were prototype versions of what I wanted to do for the enemy. So what I did initially was create a very, very low poly kind of shape of a character, exactly in the shape of the, or more or less in the same dimensions of the enemy that I'm creating, right? I did all my animations with it because we needed a prototype fast. This was kind of like we had to get this done quickly. We had to iterate in a couple of days. So to start, I needed to give Adam some pieces that he could work with like yesterday, right? And so what I did was I created this kind of prototype character. From that prototype character, gave you the animations. You were able to get it in the game, have it do what it needed to do. We had all the animations.
Had me something quick that I could work with really fast.
Exactly, and then that gave me some time where I could then say, okay, now I'm going to go into like ZBrush and Mudbox and create like a really cool character in the same dimensions as that character, bring it back into Maya, re-rig it in the same rig that I used for that initial character, and then all I have to do is give him that new character as an avatar.
For those that are brand new to this, what's a rig?
A rig is essentially the skeletal structure of joints that makes up your character, that exists within your character, right? So I built my character originally with all these animations, didn't have any textures or anything. I was just a very simple character, right? But he moved like a zombie, right? And so from there, gave it to Adam. He throws it in the game. I then make a cool zombie when we're ready, and he's got that character working. He just changes the main mesh of the character that's running around, and essentially now we have our zombies running around the level.
Here's that kind of when we were talking about a rig. Here is if I look on the zombie and I click on the zombie FBX file, again that common 3D file format, zombie FBX I've got highlighted here, and if I go to its rig setting and configure, there we can see kind of this layout right there. Those are the bones inside, and defines how animations will be mapped to this particular character, right? So getting a little bit off subject, but important to
Let's take a look at that zombie real quick. Just want to see.
You want to see what the zombie looks like?
Maybe there you go. There you go. Cool.
Looks like a pretty scary dude. I love that he's missing the eye there.
Yeah, that's cool. That was the last minute decision.
At what time was that?
I think it was like 3 in the morning.
Oh, see, I got you.
I actually just didn't want to waste any more time, so I just said he loses an eye.
All right, so on our game here, notice in my scene view, you don't really see anything first, but over here we've got this overlay that no matter where we look in our game, follows it around. Start this up and move and left and move right. Once this starts up here. All right, there we go. So no matter where I look, right, that shows up there. So that's the power of kind of the UI system here. And also, notice the way that we have it here. See the images scale down and scale up, and so we'll talk about that shortly. But first, let's give kind of a little background on this. Let's do a new scene. And in this new scene, I'm going to go ahead and create, just to show you how the UI gets created, I'm going to create a UI, and let's just do a button to start. Now notice when we do that, we get a canvas added, the button gets added inside the canvas, and we get this event system. The event system is what I mentioned. We'll send those events to this canvas. If you find you're clicking on buttons and your scripts are all set up right and nothing's happening, you might not have an event system. It's typically added there by default. I've seen on rare occasions that it doesn't. So one thing to note, this is what sends the events to the canvas. Now here is our button, and a button is a game object, name, tag, a rect transform, a canvas renderer, and now a button is an image. There's the image. It has a script that manages interactions. In other words, when you click on it, you can animate your button. So we can say that, for example, when we highlight over our button, we're going to turn red. When we press, we're going to turn blue. And if you disable it, you can turn it a different color. So let's run that. We'll call this scene UI test. Save that in my scenes folder. Give it a second to start up, and you'll see, there we go. So I click it, it's blue. I hover over, it's red. You can also do things like you can swap out different sprites when you mouse over. You can actually define animations. Using the same animation system that we've done, we can actually say auto-generate animations for us. Where do you want to generate them? Let's create a new folder called animations. And it will actually create those animations. The same deal we've looked at before, animation. Pop that window in there, highlight our button. And you can see it doesn't create any data, but it's given us an animation named normal, highlighted, pressed, disabled. So let's say when you highlight over this image, I want to do something to this button. Let's just pulse it. In other words, we'll make it scale a little bit bigger. So we can go into our 2D tool here. And this deserves a little explaining. We can see it in our game view, centered here. If I go to our scene view, where is it? Notice we have this window on the side. Let's pop into 2D mode. Always go into 2D mode when you're dealing with your canvas. Let's double click on the canvas to bring it into view. I can't scale this. It's basically telling me right now it's locked to 318 by 573. This is tied to our viewport window right here. If I change this window, notice it changes my layout. That's what we're looking at. This is a representation of this entire window. And it's saying that wherever we're displaying your game window, we're showing this image right in the center. If I create a game object, a cube, right? A cube is there. Let's go into 3D space here. It fools you at first because there's this gigantic button around this cube. Don't let that mislead you. It's so you can see both of these in the same view at once. But just know it's the canvas settings that control how it gets shown in the end here. So you'll see sometimes that the canvas looks so weird in your scene because you have all your game objects here in this huge canvas. Don't worry about it. It's just so you can see it all in the same scene and work with it. Previously in Unity, you couldn't see this in your scene view. You had to modify values, check your game. Modify values, check your game. At least now you can kind of see them all in the same view here. If I want to take this button and duplicate it, for example, like that. But now let's go back to what I was talking about with an animation here. Let's say at 0, 0, 0, my scale is, let's just log it at initial value of 1, 1, 1. And come back here, and let's say at 1 second, we're going to be 1.2, 1.2, 1.2, just to scale out a little bit, just like that. And I will copy my initial value and paste that at about 2 seconds. So I should pulse out and back in again when I'm highlighted. Let's try it. Run. That's not our default animation. That's only when we are highlighted. Oh, I'm sorry. I did that in my normal. That is my default animation. When I highlight, it goes away. So same animation system we use for camera flybys, for animating any game object, same animation system. All right, let's save that, and I want to delete these guys. And let's go ahead and create an image. An image makes up a button. An image makes up a lot of things here. And by default, it gives you this little placeholder here, this image. I'm going to bring in a ruler image that I have handy, because this, I think, helps visualize this. Now, I dragged and dropped this in, and if you remember, this is a 3D project, so I can't really drag and drop it up here. I can in a 2D project, but what I need to do is change this. This is the setting Matt was talking about earlier. A sprite that you can drag and drop in your scene, an image, needs to be a sprite. And notice it says it's used for 2D and UI. I'm going to apply that. All right. Now, my image is my scene. It's a square image. This image here is a ruler image, just so you can see the layouts. Let's take this ruler image and drop it onto this. This uses an image component, which it takes a source image, a color, so we can actually tint our image. You can do different materials. You can do all sorts of cool stuff with this here. But importantly, notice my aspect ratio is all messed up. This was not a square image, so I can preserve aspect ratio. There, now we can kind of scale this out a little bit more. And I can go native size. And this image, if I look here, 2048 by 1200. So on my canvas, 2048, I want this whole resolution to essentially scale out right now with this. So I want to make my canvas scale with a screen size. When you scale your screen size, I want my canvas to scale with it, along with all of the elements within it. I want it to scale. Well, when you do that, Unity says, okay, that's cool, but what is the starting resolution we should base everything off of? Your designer probably gave you something. What do you want to use? So this image was 2048 by 1200, so let's just use that because that's what these rulers are set to. 2048 by 1200. And notice it's kind of offset a little bit here. Let's take this image and we are going to dock it in the top left. For those that have been using Visual Studio for a while, you'll notice this is pretty similar to how you can dock elements in Visual Studio. If I drag something out here, for example, and I want this to be docked to the top left, I can't just click top left because that sets my anchor. What's an anchor? An anchor is used as the fixed location, so there's some distance in pixels between the anchor and the edge of this object, and that distance will remain consistent when I'm doing operations like this. Right? It's kind of this fixed width that's always staying scaled from. If I move it over here, notice my anchor's there. It's always going to stay consistent to that anchor. Now, what I can do here is, if I want to dock it to the top left, just follow the directions, Shift and Alt. So I hold Shift, Alt. Now I can click the center, top right. Let's do that. All right. And now you'll notice, let's save this scene here. So scale with screen size, 2048 by 1200. Let's check our, so 2048 by 1200. Now let's see what happens. If we happen to be running in this resolution, and you're not going to be able to really see it too much here, I'll have to kind of read this off a little bit. Let me just change one thing here, make sure that we are good. All right. It's unfortunately the best quick ruler image I could find on the net really fast, but it still will show you the idea here. Let's go back to free aspect ratio here, and as we scale this window, something's going to happen. Something has to give here. And if we look at our Canvas scalar script, this is what it's going to use to basically resize elements within here. And the reason I want to show you this rule is it shows you what happens. Notice we're retaining our aspect ratio here. We have a reference resolution, and we're telling Unity to match either the width or the height that I've specified here, or a mix of the two. You have to give on one or the other and make a compromise. If somebody is running at a 16 by 9 resolution, like this, great. You've got kind of your whole image here. If somebody goes to a different format, you have to give somewhere. Either you're giving on the width or you're giving on the height, because you're not at the same resolution that your image is at anymore. And so this allows you to specify how you want to give on your width or your height here. Thankfully, in our game, it's a pretty simple scenario because we're just docking elements to the top left and the top right. I don't really care about the bottom. I know that I'm within range of any modern device is going to display OK on it. So let's go back to that main scene and kind of talk about what we're doing to display our stuff here. We can actually, I'll tell you what, we can even take our images, our HUD images here, and I'll show you just how we can use them right here. Take this coin. We can't drag it into our scene because now we're creating a 2D game from it. We need this as a UI element. So UI, image. Again, I want to stress this is different than a typical like a 2D game workflow. Like here, in our VampKid versus Zombie Apocalypse, if we go to all of our stuff here, like these images we can drag and drop into our scene. Like this. Set the sorting layer. Right? But when I play my game, if the camera moves, that goes out of view. So that's not what I want in this particular case. I need an image. I'm going to give it my coin. And now I'm going to say, all right, I want you to dock into the top left. So hold down Shift, Alt, top left. And I want you to preserve aspect and set the native size. Let's see what that looks like in my game view here. All right, so it's a little bit small, so I can hold down Shift and scale this out to retain aspect ratio. Let's see what that looks like. Pretty cool. It's a little cramped on the edge here, so maybe I want to move it away a little bit. Now, notice its size is automatically. It's got a fixed width from the edge here. It's docked to the top left. Perfect. Now I need some font next to it. Fonts are, let's label this though. Let's call this Coin HUD for heads-up display. Now let's go ahead and, oops, one thing with Unity, if you don't hit enter after a rename, it doesn't take it. So Coin HUD. Now we need some font here, some text. And so text is a game object UI text. Not the component. This will add it to an existing game object. We want to create a new text game object. So game object UI text. Click on this, and there's this little tiny text right there. It's kind of blurry here. Now let's talk about fonts. I've brought in another font into this project. By default, Arial is the only font you will find in a Unity project. Unity does not know what fonts are or are not on somebody's system, and it actually has to turn these fonts into images on the back end to display on your graphics hardware. So it's not like a TrueType font like you're used to using in a regular system. You need to bring in whatever fonts you want into your project, so Unity has all that data to package into your game. So you can go to websites like thefont.com, for example. There's a bunch of different font websites out there. You can search on license, what you can use, free for personal use, donate to author, all sorts of cool stuff out there. TTF, TrueType fonts, and OTF, OpenType fonts. You take them, drag them into your project, and they're there for you to use. So in this case, I chose this font called Chunk 5. And I'm going to increase the font size. And now notice it immediately disappears because my scene here is not big enough for it. Let's go ahead and crank that up to something like this maybe. Change its color to, let's do white. So you don't click on the dropper because the dropper is for selecting colors. I'm going to click on the little bar here. Just change it to white. And we'll call this 0. Now notice that flows in the right direction. It's going from left to right, which is good, because as our scores will progress that way. There's an option on here called Best Fit, which will take it and make it fit whatever size you're kind of going to. Caution on that approach. There's a minimum size and maximum size. This is not good for performance or for the size of your game, because behind the scene, for every font size, it has to take all of those fonts, all of the letters, and turn them into images for every single font size. So not a good thing to do. We want to use this canvas scaler, which will automatically take our fonts and see how it scales them down and up. That's the canvas scaler working for us. The last thing that you saw in the other game was we had another score on the right-hand side, which was we can just duplicate this and dock that in the top right. So Shift, Alt, top right. And I want to drag this down to make it match the other guy. But now I have a problem. This guy is filling like this. See how our text is filling this way? So I don't want it to fill that way. I want it to fill from the right on out. Like that. So we're always aligned over here. Now I can take that text box, crank it out just a little bit, and maybe say something like 0 points. So we have our coin score and maybe our zombie score, for example. And now we have a UI. Let's play this. Because of our canvas scalar component, we should be able to take this and just, look at that. It's perfect. We don't have to worry about different font sizes. It just works. Again, we only have 3 elements here. We've docked them using the we've used the anchors and it's set their positions, top left, top right. Brought in the font file. And then our canvas has simply set to scale with screen size and given it a reference resolution. And it just works. It takes care of all the rest of that. Now, one more thing you can do. So we have a bunch of other different components here. There's a button we looked at. There's a panel, which is interesting because a panel is nothing more than an image which fills up space. You could take your coin HUD and all that and maybe drop it on a panel. Maybe you wanted some sort of overlay that you wanted to show, and you could disable and re-enable that object just to show it. That's one way of doing it. But the use case on a panel was interesting because people wanted the panel, but it's just literally an image that stretches. So we talked about docking. you can actually take images and stretch them here. Like this coin, for example, if I want this coin to stretch, this is going to look kind of funny, but if I, right, if we want to take up the entire area there, we can stretch. I'm going to undo that because it's not how we want our UI to look. Take all that out of our canvas and delete that panel. Sorry, out of our panel. Now, we also have we have a raw image, a slide, or a scroll bar. And all of these are typically based off images, and they have a little bit of script on them. One thing to note, when you want to call code methods in the UI, let's add a button here. Game object, UI, button. That button centered. And let's make this guy quite bigger. So again, this is the 2D tool, which is great for UI. Let's scale this kind of out some here. Our reference resolution is pretty big, so let's just 1024 by 600. All right. Now everything else is going to look kind of messed up. That's all right. I would have to reposition. It just was making my button look kind of silly here. And I want to show you this button click demo for the world's ugliest button here. Let's fix this guy, scale him down a little bit. We'll just disable those and show you just a button. All right, now, when you click on a button and you want something to happen, let's say you want a level to load. Why don't we make this, this button, we'll say load level. Oops. Load level. And we'll change that font to chunk 5. And we'll change our font size up here. All right, let's create a little script. Create C# script, and we'll just call this button click. Let's open this guy up. The only requirement that we need here is a public void method. I'm going to delete the other methods here. Public void load level, we'll call it. The API call in Unity to load a level is application.loadLevel, and you give it the scene name you want it to load. Let me load this back up again because it reloaded my project and lost focus. So we can literally just do this, application.loadLevel, whatever our scene name was. Our main scene, I called main. We don't need .scene or .unity, I mean. You don't need that, you just the name of it. That scene must be included as part of your build settings, and we'll look at that when we do our build, but just to be sure, here's our build settings. File, build settings, and you can drag and drop scenes on your build settings, or you can add the current one using this button. So if I wanted this to be included in my build, I would say add this current scene, drag it up here to make it my first scene that loads in my game, and that's it. My game would load with this, and when I click on my button, I want it to load this. But I haven't wired it up yet. Let's finish wiring it up. As it stands now, my button does nothing. Just to be sure, click on this. I like to highlight over the menus just to know when it kind of responds back in. There we go. So nothing happens. Our code is complete, but we haven't assigned this code to our button yet. And this is a little bit, you have to kind of pay attention here on how this works. On your button, you can say, when you on-click something, what do you want to call? And you think that you might be able to take your button code and drag and drop it over here and look at something here. And the way that you should be doing this is not like that. You should actually take your button and assign it to that game object. There it is. Now, click on the text for that button here. Right there. Drag and drop from here right up to there. Very important that you do this. Now if you look in this, it will show you for your button click code, there's your code method. So again, take your code, assign it to your button, drag it here, and then you get a whole bunch of things you can do. You can call different game object functions, game object broadcast message, which is a real generic way to try to call functions and other game objects. Not a big fan of that method. I just want to show you some of the other API that are here. I want to say button click load level. Here you go. So now when I click on that button, it's going to come into my code here and call application.loadLevelMain. Another API that is kind of useful, application load level. If you want to know what the currently loaded level is, it's application.loadLevel loaded level. And that just essentially restarts the same level over again. But let's go ahead and run this guy, application load level main. Give it 1 second there. Again, I kind of do my mouse over here to see when the menus respawn. There we go. Click on play. I click on load level. And we don't see anything until the level loads. With Unity now that the free version shares the same features as professional, you can have an asynchronous loading screen, so you can show a progress bar. But with that API call, just a simple one there, you don't. So just like that. One other thing I want to show you can do with the UI elements on this game that we have, the 2D version of Vamp Kid vs. the Zombie Apocalypse.
That's awesome.
It is pretty cool. We have this health background. So here's coins and our font there. Now we have, let's pick this apart. We have this health background image. And then as a child, so this is our health background image. As a child of that, we have this green overlay. And you notice we only see a portion of it right now. Like it looks like a health bar. But down here, it's a full, long green bar. And you can, on the image script, you can basically say that you want this to fill the entire length of your game object by a certain amount. And notice, this is essentially percentage, 0 to 1 though. And through code, you can control this. So for example, if I wanted, hypothetically, to just set that value to something else, I could say, give me my image component and set the fill amount to 0.5. So for example, we could say get, assuming this code was on that particular image. It's not. I just want to show you the API for this here. We're going to say get component image. An image isn't found by default. You actually have to import using Unity engine.ui. And then we can say var image. That would give me my image component, and I could say image.fill amount equals 0.5, and it's a float, so I put an F after it. That's it. So that would automatically set that health bar to be halfway through. So every time you get hit, you can make it 0.4, 0.3, 0.2, 0.1, until you have 0, and then you kill your character like we did earlier. So the API for that is simple. Again, anything that you can see in your UI like that, you typically have control over in code. So here we have that the fill method, and there's different fill methods you can use. Radial, so you can fill like that. All different ways of doing that. But the overall idea is pretty simple.
That's always kind of complicated too, like doing the radial fill method. So it's nice that they have that built in, because when you do things like circular loaders and things like that, you try to do it yourself. It's
got to write the math to do it and all that.
This is a much better.
No,
way.
thank you.
Yeah.
All right. Next, real quick, let's look at creating a message system. So we saw that our level ends, but we don't have any way of kind of alerting the user for that. And so we can do something pretty simple here. I've got a little code snippet of sorts called show level message, and this is going to integrate with the UI. So let's, on our UI here, we'll do it on our main level. We'll make this work how it should, I should say. We'll go scene main. And when our character dies, let's go to 16 by 9. When our character dies, let's show a little text, some text there. Hey, you died.
Hey.
Or maybe go, or when the level starts, we'll say go, exclamation point.
Yeah, there you go, yeah. There you go.
The way that we can do this is we create a text image in the center here, and we're going to stretch it to be the entire width. So you don't really see anything in it right now. Let's go ahead and let's change our font here. Let's change some settings on that. And we'll call this test message. Let's make our value for this. Let's change this to white. And I don't see, so this actually, caution here, because what did this do? This looked for the first canvas in my scene and created it there. However, this is my dual touch control, my mobile controls. I don't want this in my mobile control. I want to create another canvas to have my UI overlay. So I'm just going to drag that down into this guy. And this font is probably too small, 0. Let's try 75. And reset its position here. And why am I not seeing my text here? Let's create one more just to make sure that we can see our text here. Okay, so there's new text. Let's go ahead and change its color. Okay, we can still see it. Let's change the font on this guy. Let's make this a lot bigger. We're going to center the text here. This is important. We're going to center the text within this box. There we go. Let's delete the other one here that was... And we'll call this level message or info message, whatever you may. And this font is pretty big.
Cool.
So we have a message there, and we just need to set it. And this is just a text component. So in code, we can set that component, and we can actually fade it. So we'll use this code. And let's say on a typical way of doing this is we have a game controller. Let's create a game controller script. And in our game controller script, I'm going to delete what's there and paste in something called show level message. And this is going to require a variable here. Reload this. Anytime you want to set a UI element through code, you need a reference to it. You have to somehow get that reference. So we're going to expose a public variable of type text. It's a text component called level message text. And it's red here because we need to be using Unity engine.ui. Okay, so we have a reference to it. We're going to have to fill this reference, and I'll show you that in a second. Show level message, we give it a message. We set it active to true. And then we will make the text visible. And then we fade it out. So the UI elements have a built-in code method here called crossfade alpha that you can use, which will fade it out over 5 seconds. So let's go ahead and see. All right. When we start up here, let's just do a quick test. Public, we'll do void start. Show level message. Go. Let's try that. Oh, actually, we didn't set the reference yet here. Gotta get out of this play mode real quick. Wait till it comes back to us. And what do I mean by what I just said? We haven't filled in this variable. It has no idea what this is. So here's what we're going to do. We're going to take our code and assign it really to any game object, but I have one called game controller. That's pretty standard. So we're going to drag down the game controller. And that should expose this variable now. This is the public variable from our code here. Really easy way to expose values in Unity's interface. It says, hey, this is a type text. You want to tell me what I should be assigning to that? Well, that's easy. We just take this guy, and in one click drag motion, if I select it, I don't have the focus on my game controller anymore. So I click game controller, drag this over, save my project. My game controller now knows about this UI element. Let's run this and see what happens. There we go. It's fading out over 5 seconds. Bam. Anytime we want to fade a message on there, we just need to get a reference to that and show it. We can do something really slick here. We'll do one last thing, and then I'll turn this over to Matt for some particle effects. Let's take, what do you say that when we die, we just show you died on the screen?
That's cool. Yeah.
Easy enough? All right, so I think...
Animate it? Should we add an animator to it?
No. Let's keep it simple.
All right.
Because we already have the camera animated a little bit when we die. It actually
Okay.
looks down and then rotates back up after a few seconds.
Gotcha.
So I think I said he's dead, Jim. So let's find a spot in the code. Probably matching by, no. It was the die method. So let's look for die. There we go. All right. So we have this method here that player health, when the player dies, we can go ahead and do something with that. Well, what do we want to do? Conceptually, call game controllers show level message. How do we do that? We ask for the game controller. And then secondly, we ask for the game controller script reference, which has that code in it and already knows about that text box. So one, we'll say var game controller is equal to game object, ask Unity for the game object, find game object with tag, game controller. Let's see if I have that defined in my tags already. I do, perfect. That gives me the game controller game object. And then we'll do a short version here. GC is equal to game controller dot get component. What component do I want? It was actually called game controller. That was the name of the script component on there. In other words, this right here, game controller, is a reference to this guy right here. And I can simply call that show level message once I have it. gc.show level message. You died.
You died.
You died. Let's try it.
Quadruple exclamation.
So we start up. We should get our little go text. That should fade out over 5 seconds. And wait for it. There we go. Let's let that fade out here. Shoot some cool particle effects here. Okay, let's die.
No.
And I didn't see it happen here, so let's just look at... oh, you know what?
Technically he doesn't die. He just explodes into bats.
Yes, you exploded into bats. Let me just real quick look at what happened here and attach to Unity. And run this, and let's go ahead and jump off and see what happened. We should have seen our text. We didn't, so let's find out what happened. We've got our breakpoint set. As soon as Unity comes back, we'll run off, run off the edge. It technically doesn't die.
Doesn't.
He's
like Dracula.
He's Dracula. He just poofs. All right, go. 5, 4, 3, 2, 1. Okay, our code was called. Our breakpoint hit. So there is our game controller, and that reference actually returned. Our text is you died. It's active. Our color's there. Our alpha, so it's visible. It should be visible. Oh, you know what? We're actually calling into die a couple times, which is, I think, overwriting the call. So that's a bug I'll have to fix. But anyway, we saw it once when the level starts. It's just I happen to overlap calls into it when I die. So I will fix that actually while you continue on with
Let's do it.
the next thing on particle effects here. So the wow factor, enhancing the game through a bunch of different ways. So you see games that kind of have pickup text, right?
Mm-hmm. Particles, particle explosions, particles in the UI. Yeah, pickup text is a good thing. Every time you get a coin, you want to see a little like twinkle every time
Nice.
every time
5 points.
Even right now, he shoots his little projectiles. They could probably add a little bit more, like on the initial kind of launch of those projectiles, and even when they hit things, when the projectiles hit things, maybe do a cool like projectile effect on that.
Yeah.
When you shoot zombies, maybe little zombie blood flies out.
Little explosion, and then
Exactly.
little brains go flying everywhere.
Yeah, even
not
right
like
now,
pieces, like
when
we
our-
have bats and brains.
Yeah, when our character dies right now, or technically escapes, he explodes into an array of bats, right?
Yeah.
So that it's something different. It adds a little bit more to the
Pizzazz.
Yeah, exactly. Wow factor is.
Particles can do, it's as you mentioned earlier, it's a pretty optimized system. We can include animation, we can include physics on them, so we can actually trigger colliders like we talked about with them.
Yep.
So show us some cool stuff with particles.
So there's a couple people on the forums who basically said, hey, can you do some magical particle effects and stuff? So while you were doing your,
Is that what you're busy over there doing?
I was busy creating some magical particle
Nice.
effects. So here we've got just two very, very simple elements that I'm going to use to make a very cool magical kind of sigil particle effect on the ground, right? So my initial kind of burst graphic, this is just 512 by 512 in Photoshop. You can see right here I've got my layers, and to save it out, I have black so I can see what I'm doing, and I can kind of really get those nice glows and stuff like that. Turn my black off, I save it out with an alpha channel as a PNG. It's 512 by 512, very small. Also, I want to have these little guys shooting up from it. I don't know if you've ever noticed, like kind of the Super Saiyan style when you charge up and you see these little rays of light shooting out of it. So here's my little ray of light. This is just 100 by 100. You could actually be even smaller in that little graphic. It's just a line that I basically tapered the edges of and added a glow to. So I'm going to have those shoot up as well. So if we take those into Unity, after saving them out, we've got two PNGs. Inside of Unity, I'll show you right here. We want to make a magic sigil effect. So let's say a little burst on the ground that has energy shooting up from it from underneath your character. Like you just got a power up or something like that, right? In order to do that, you're going to need to combine a couple different particle effects. And I'm just going to kind of run through the process to show you how I made this little quick magic sigil effect, but hopefully it'll be pretty cool for you. So to start, we have Magic Sigil 1, and right here in my particle effects, the first thing I'm going to do, game object, I'm going to go to particle system and create that, okay? From there, I renamed mine Magic Sigil 1, and you can see right here, if I stop and simulate, there's my kind of magic sigil effect, right? It's on the ground, it's perfectly where I want it. In order to achieve that effect, I had to do a couple of things. One, after bringing my graphics into Unity, you'll see right here I have Magic Sigil and Magic Rain, right? Those are the two that I made in Photoshop, right? I had to create two new materials in order to show those particle effects, right? So over here, we've got Sigil right here, which is the Magic Sigil. And basically what I did was I created a new material. I went up to the shader properties under Particles, made Particles Additive, right? And then I just dragged my texture into the texture property of that new particle material, right? I made another one right here. Well, it says new material. We'll call it Magic Rain, right? Same process. Created a material, went up here, changed it to Particles Additive, dragged my texture in there, right? I adjusted the tint color to kind of make them glow a little bit more. So if you can see right there, I just kind of adjusted the value, just kind of pulled it up a little bit to kind of enhance that glow. I think when it came in initially, it looked like that. You just kind of drag that up, and that'll really enhance the tint value of that particle, right?
Cool.
So we've got these two particles, and now we want to do cool stuff with them, right? So we make a particle effect, and the first thing we want to do is there's two types of particles. There's looping particles. Looping is good for things like fire that's constantly going or smoke that's constantly rising, right? Or gas or things like that, or clouds that are just consistently going, or a star field that just keeps going. That's great for looping particle effects, right? They're just never ending. They keep going throughout the entire game. That's it, right? Doing something like a Magic Sigil effect, it's a little different. You're not going to be using a looping effect. You're going to be using a one-time kind of burst effect, right? And then you're going to adjust the time values on that. You're also going to birth other particle effects off of that to kind of create this overwhelming effect and get all these things going, right? So in order to do that, just really quickly here, so Magic Sigil 1 was my first element that I created, and I went in here. Down here, I changed the duration to a little bit shorter. I think it starts off as 5. I brought it down to 1 because I wanted it to be really quickly, and then I even thought that 1 was a little too long, so I slided it down to about 8. We'll go 8.5 like that, right? 0.85. We'll do the same here. So its lifetime and its duration is less than a second, right? I wanted the speed to be 0 because I don't want this thing moving. I just want it instantiating on the ground, growing in size, and then fading out. Like I said, it's a sigil, right? It's a magic sigil that's going to be around the base of my character. If you add speed to it, I'll show you right here. And also I turned looping off. You can check right there, right? So if we go into our scene, here's our particle effect. If I click simulate, you'll see my particle, right? If I add speed to it, you'll see it starts kind of moving in every direction, right? It's adding this kind of velocity that it doesn't need, right? I want it to stay in place. So we want to make sure we take our speed and make that 0, right? That'll ensure that it stays in place. To further ensure that, I'm going to go down to the shape of the particle. I'm going to make it a sphere, and I'm going to reduce the size. You'll probably have something like that to start. I want to reduce the size all the way down to 0.01. It's a very, very small size that this thing can emit from, right? Some of the other values we're going to need to mess with are the size of the particle, right? To start, you're usually starting with something that's about 3 units. We want to bump this up to almost 9 units, right? So that's going to give us a nice size particle that we can play with, right? I also didn't just want one sigil. I wanted a couple of sigils kind of fading in and out to kind of give it a feeling like it's almost like electrical, right? That was the graphic I drew, right? So in order to do that, we're going to add a little bit of rotation to those specific pieces. I did a constant between 2 curves, or between 2 constants, which means for each particle, it's going to consistently rotate them in different directions, right? I have one going in 360 degrees and another going in negative 360 degrees. So when I play it, I get this nice kind of alternating effect between the different particles, right? Kind of almost looks like electrical, right?
Cool.
So from there, as I go down, we set our sphere. We're going to change the color over lifetime. In color over lifetime, this is where you're going to adjust the alphas and different colors of the particles as they're birthed and instantiated, right? So in here, if we look at our particle and we simulate it, we see that it kind of fades up and then it fades out, right? And each one does that, okay? In order to do that, in your color over lifetime, I basically came in here, set my initial alpha to 0, then I kind of tweaked the colors a little bit as it kind of grew and created itself. I went from blues to whites to blues, messed with the alpha channel, came all the way up, then it started to taper off, and it goes down, and then eventually to 0. So if we look at our particle over its lifetime, it goes from 0, up, down, kind of changes color a little bit. Great for something like electricity, right? Also, I wanted to mess with the size over the lifetime of it. I wanted the particle to grow big and then kind of subtly kind of get smaller, right? Very, very subtly, right?
That's cool.
I also wanted to mess with the rotation over lifetime of the particle. So I constantly want this thing rotating in a consistent 45 degrees, always moving, right? It would be kind of, sometimes it's okay to just have it in the same spot. I just thought it would look cooler if it's rotating. It's already moving. It might add to the effect. We added a little bit there. And this is what's great about the particle effects, is you can just go in and start tweaking all these values and consistently just keep looking at it and playing it and everything, right? Next thing I did was, in your renderer, this is really important, to get that particle. So this sigil that I made, if you click on render, you're going to have to drag that particle into the material. You will not see your particles that you create unless you do that, right? I also billboarded it against the horizontal, right? So I wanted this stuck to the ground, and there's a reason for that. Normally, when you make a particle, it's just going to be billboarded to the camera. So I'll just change it to billboard real quick so you can see. If I simulate, it's right in your face, right?
Oh, yeah.
I wanted that billboarded to the ground, so we do a horizontal billboard. Simulate that, you'll see it's kind of stuck to the ground, right? Makes sense? We're doing a magical sigil on the ground, that kind of thing. From there, we need to add more pieces to it. So I'm basically have to create a multitude of particle effects, assemble them all together to create one particle effect. That's what I'm doing right now. Okay, so the first one, I have my magic sigil. Then what I did was I actually just duplicated that magic sigil and I made a variation of it. And this is going to be kind of an explosive element that comes out of it, right, using the exact same graphic. So in Magic Sigil, I made Magic Sigil 2. You'll see here if I simulate that, you'll see it's a little bit different, right? I just tweaked some of the values so it comes in, pulses, and fades out really quickly. And this just kind of adds to the whole effect, right? You have multiple textures you're playing with. I also created a spray, which was using just standard particles. Just had that kind of fly out, right? And then I created my Magic Rain, which was basically the same type of effect, right? So we have a simple little area on the ground that shoots up these guys, right? I don't know if you can see them kind of in there. I'll play this again. Might be hard to see on the stream. Oops, go to Magic Rain. See how they shoot up? So in the Magic Rain, what I did was I made 2 seconds of its lifetime. I actually added speed on this because I wanted them shooting up, right? And I added high speed on it. I put 8, right? Instead of 0, like the other thing that just sits on the ground, this one's 8. We want them
Fast,
shooting up, right? I also wanted to billboard them vertically, right? So if it's just a standard billboard, you'd think, oh, well, they're straight, right? They'll just go up. But no, it's billboarding it to the canvas, so you're going to get a weird effect. They're not going to be 100%, right? They're constantly looking and turning towards the camera. So you have to make sure that this is set to vertical billboard, right? Then you'll get that kind of effect,
cool.
right? It's great for rain, too, if you're going the other way and you're trying to make rain and stuff like that. So anyways, once you get these 4 pieces together, right, we take our original Magic Sigil, right, which is this piece right here. Let me move it off to the side here so you can see it. Get it away from those other particles. There we go. So under here we've got the initial Magic Sigil that we created, the variation of the Magic Sigil we created, that spray piece, and the rain. And they're all parented underneath the initial Magic Sigil that I created, right? So in here, if I click on the main particle, I click stop, I simulate, you'll see right away you get a pretty cool effect, right? So, you know, he throws his potion down, he throws his hands in the air, and whatever, right? So it'd be something cool that you could put underneath your character just to kind of enhance it, right? Like a bonus, a power-up, whatever. In order to get those playing at the same time, all you have to do is deal with sub-emitters. And so using our main sigil that we created, I come down to my sub-emitters, and it works if they're parented to the main object, right? So in your sub-emitters, you're going to come in here, and you're just going to, after you've parented to your main object, you're just going to drag them in. So if I look at my sub-emitters right here, I just drag my particles in. So at birth, I want it to create this new Magic Sigil, whatever, right? The one I made right there. Then I wanted to drag the spray in there as well, so when it birthed, it also did that spray explosion, right? You only have enough room to add 2 sub-emitters at birth of a particle. I think you're just limited by the Unity system on how many you can put in there. But that's okay because our Magic Rain plays at the same rate throughout the entire thing, so we can also parent that, but it doesn't have to actually happen at birth, right? It's more of just kind of an added effect. So once you put all those together, you've got a really cool little particle effect. Simulate it, boom, you're good to go, right? Similar effect we used when we created the explosion of the bats for, let me see, right here, for our little vampire. If I come in here, go to bat, so you'll see in here we got bat particle, I think it's called bat burst right here. Bring bat burst into the thing, there you go. So what I'm doing with bat burst is kind of a similar effect, except I also added another particle, which was a texture sheet animation. And that's what these little bat guys are right here. And you can see that right here, right? So I basically created a long strip texture with a bunch of bats kind of flying, like a whole animation.
Now, the rule here is because, we're so used to the 2D animation system in Unity.
That's the one thing I wish Unity had with it when you're doing like the texture sheet animations, especially for particles, is you can't yet use the 2D system, but I'm sure it's probably coming. But basically, in your particle effect, so if I look at my bat burst that I have right here.
Normally, in the Unity animation system, if you take a sprite sheet or multiple images, you can drag and drop them in your scene, and you automatically have an animation. It just works.
Yep.
And yeah, this one is kind of the odd one out.
This one's kind of, you have to make it ahead of time, essentially. Bring it in as a sprited animation, and then just tell the sprite system to use that particular animation. So if I go down to my bat burst, I go to bat's particle.
Did you tell me it had to be kind of a fixed grid that?
Yeah, so I add the texture sheet animation down here, and in here I tell it what type of texture it is, how many slices there are. There's 4 slices in the X direction, and it's one row, right? So 4 slices in 1 row. Use the whole sheet. I have it doing 20 cycles, which is plenty for what it's trying to do in animation-wise. Add that in, then you'll have your. You can use even more than that too. You can really customize it with those tiles, but essentially you could do an electrical effect. You could do bats. You could do little embers, whatever, right? So that's kind of a cool effect to just add in a little bit extra to your particle effects and make them do cool things. Another great thing to do is if you're animating like animated sigils or something like that, having them actually animate like in After Effects, saving them out as different frames, bringing those in as a tile sheet animation, adding them to your particles. You can really get crazy with the type of stuff you do. But just a quick kind of overview of some cool stuff you can do, and I know some of you had asked for some magical
That's pretty
effects.
cool on the fly. You know what?
Yeah.
You know what would be neat to show real quick?
That?
So you have that on your computer. You've just developed over there. I want to bring that into the main source branch of what we've been working on here. Now we're not up to date with each other.
Okay.
So you want to show how you just export that into a Unity package?
Absolutely. So let's say I just made this cool magical sigil burst that's awesome, and I want Adam to throw it in his project right now. But we don't really want to sync up projects. I just kind of want to email it to him so he has it. Easy way to do it. Boom, we've got our magic sigil effect right here. It's ready to go. I need to make it a prefab, right? So I'm just going to drag it down into my Unity project here. Actually, here, I'll put it in a better menu here. So we'll go Assets. We'll just drag it into the core of our assets right now. Drag it into our assets. There's our magic sigil prefab right here. All I do, click on it, right-click on it, export package. It's going to tell me all the stuff I need that's associated with that package, plus it has the prefab in there. I say export. I put that on my desktop, wherever, magic, sigil, save, makes the package, boom, there it is. I throw my USB drive on my computer.
And then I'll load this in for the next module, and so I'll copy it in the game and have that kind of in the starting location. So maybe he'll drop down on the starting location with a particle going underneath him as he drops that onto it, maybe. Something like that.
Drag this little particle effect into the USB drive, and we are good to go.
Good to go.
Pass that off to guy in charge.
Where?
He then loads it up in his game. He's got a cool particle effect.
We've got our main
cool graphics.
Just to show you how fast that process is here. That was magic. Let's close this later.
Yeah.
Don't save this one. Just to make sure we only have one Unity project open, because when we double click it here, we can always go to Assets, Import Package, and point it to that custom package. Honestly, I just like doing this where you just double click on it and it brings it in. There we go. Magic Sigil, import. Go to our root where that was dumped there. I'm going to drag that into the prefabs folder here. There we go. All right. Now a good place for this, maybe right here.
There you go.
Let's see what happens. I think I'm falling down right under the spot. Should work all right.
If it plays.
Oh, it'll play. It's just as the day goes on here, it's
It decided to crash right at the end. We did so good.
You know, it's probably taking some time here too. Is right there we go. Let's look down. There we go. It happened fast, but you can see the kind of the everything shooting off from there. Yeah. But there we have it. Pretty cool. I'll fix it up a little bit. I'll reposition that for the next one because in the next module, we're going to do building for Windows 10. Okay. And that will be the final module of the day. So thanks for joining us on this one, and we'll see you back in a few minutes for the Module 6, building for Windows 10. Thank you.
Perfect. Thanks.
Finally, the last module of the day, Module 6. If you're watching this now, thanks for hanging out with us or tuning in. And if you're watching this online, well, you could have just clicked and joined us without having to sit through the rest of us. So either way, we're happy that you're here for the final one, building for Windows 10. This has been a wonderful day of developing Windows 10 games with Unity.
I'm well rested. How about you?
You've been out there sleeping.
Yeah, right. No, I've been...
Yeah, exactly. In this module, we're going to talk about building for Windows.
Nice.
The process has not changed much, so this will likely be probably the shortest module of the day. Some of our other modules we went over quite a bit. This is going to be the easy one, not because of the fact that Windows 10 hasn't been released yet, although the process I expect this
It's just easy to do.
fairly simple, right?
Yeah.
It's very similar to what we did previously. All right, so building for Windows. Sounds kind of funny. Building for
It does, like building Windows. Well, wait.
I just realized. So this should really say, we're gonna do an on-the-fly. Just wanted to see if anybody was paying attention out there.
Hey, nice transition.
UWP, Universal Windows Platform. What is Universal Windows Platform, Adam? Windows 10 is going to power, and currently does power, a huge variety of hardware. From phones, I demoed the phone that was actually running Windows 10 earlier. That loaded Windows 10 up on that last night, loaded the game on there, and it ran great using the standard asset mobile controls on there. So anything from a phone, phablet, small tablet, large tablet, on up to my laptop, to desktops, to our Surface Hubs, which were the big PPI, big touchscreen displays, which are embedded built-in Windows systems, which are cool, to even the Xbox is going to be a universal Windows platform that you're going to be able to deploy to. In fact, Brian Peak and Jaime Rodriguez in their build talk this year showed a quick demo of actually taking Xbox UWP, Universal Windows Platform app, and deploying it out to an Xbox, which is pretty cool. Yeah. And we have also announced officially our partnership with you guys for the Unity SDK coming out for the HoloLens. So that's going to be very exciting. Unfortunately, we don't have those devices here today. Nor tomorrow will I have those devices with me either.
They are very cool.
They are very cool. Windows 10 will also run on small IoT, Internet of Things type devices like the Raspberry Pi. And the idea is that you're going to be able to take one package and essentially run it across an entire range of hardware. Now, it may or may not make sense to do that. So, for example, if I take a game, I might want to run that game on a small tablet, and I might also want to run it then on a system like this, or maybe even the Xbox, but maybe it's not the right experience for the HoloLens or a Raspberry Pi because I'm killing memory requirements. But the idea is that we have a consistent API compatibility using these contracts across these different systems, so it will, in theory, work, but again, we need to develop 4 different device capabilities, 4 different experiences. Take a Raspberry Pi, a little device. Do I have a graphics card that's powerful that I can render with under? No, of course not. So you have to kind of, tailor to whatever you're going to deploy to. And with Windows 10, we have something called device families. Now, single platform, various device families. The term Windows Mobile kind of went away because it was our old version of the phones. And whenever people would say Windows Mobile, I'm like, it's not Windows Mobile, it's Windows Phone. And now we're calling Windows 10 the mobile SKU mobile, which is small devices. I think it's less than 6 inches, I believe it is. Then we have the desktop and mobile. And there's going to be other device families as well. But again, we're going to be deploying potentially to a huge range of hardware. I think we've stated something like 1 billion devices running Windows 10. It's going to be pretty awesome. Now, the build inside of Unity is pretty simple. It's very similar to what we did with Windows 8.1 builds. And we did that in our prior MVA that we did, the one we had the link for the beginning, aka.ms/free Unity training. And There's also Jaime Rodriguez, and I think some other folks did the one building for the Windows platform from Unity, so they did some really cool porting and a native device-specific stuff on there. But let's talk about a couple of settings that you need in the build settings here. So, player settings. This is important. Ensure that you set deferred and linear. Now, where is all this noted? I might be jumping ahead just a little bit here, but let's save all this. Actually, this is a carryover from the last module. Since we actually took a break, now the timing's a little bit off there, but you notice, and I could actually center that a little bit better here, but he falls down, enters the starting space there, go. So that was a particle that Matt just made, and I just died. In the last one, how did I do that? I simply have a collider here. I took a square, just so we did our level boundary. I took out a cube, and I scaled it out, and I made it invisible. And I just simply had a little code there that when you come in contact with that trigger, we enable that particle effect. So the particle effect that Matt sent me is just a child. And again, I know I'm getting off topic of Windows 10 here, but we had to kind of have this carryover, because the deal was he gave it to me last module, and during the break I got it working here.
I didn't see him send you anything. I saw like a weird...
USB, you weren't even here. You were out
No,
sleeping.
I thought I was monitoring remotely.
So I have a sigil detect script, which is very basic and has just a public variable that contains our particle effect in it that we have to drag and drop into it, and on trigger enter. I don't need any of this other stuff down here. I can actually delete that. That's the entire thing we have there. On trigger enter. When the player falls on the box here, the sigil, we enable its child particle effect. So in order to set that reference, I just dragged it and dropped it right there. I then disabled it, so it wasn't active when we started. And as soon as the player hits it, it just, when you set active behind the scenes, this, all it does is go click. That's what set active does. Just enables it behind the scenes, so when we fall on top of it, then it becomes active, and then we get to see the particle effect.
Bam.
That particle effect. What just happened on that time? There we go. All right. That was a little delayed. The system, it's the end of the day. System's tired too. All right, so the deferred and linear settings here, affected lighting. Let's go ahead and change those. So if we go to File, Build Settings.
Yeah, I think it's worth pointing out those are settings you should set regardless of whether you're going out to Windows. Really,
Regardless.
if you're using
So
PBR,
even if you're
standard shader.
Even if you're on just a PC standalone build, for example, go into Player Settings and deferred and linear, deferred and linear. I'm going to go to my Windows Store settings and click Player Settings and check deferred and linear. If not, things will look different. So let's just show what this looks like. Notice those nice purple lights back there. Let's go to forward and gamma. And yeah, looks very different.
Yeah, with a lot of light sources, we get some wackiness when we're in forward rendering. And then the linear color space, that just solves for, well, I don't know how many people know about gamma being artificially ramped up to support certain devices, and it just really washes out the PBR. Well, that sounds funny. Just washes out the color range.
It washes out the PBR and the
And you're
GI.
left with watered down PBR.
All right, so back to these, back to the settings here. So make sure you set deferred and linear, and also change your company name. And let's go over here, player settings, scroll up.
That'd be a great name for a company.
3 Guys Games, we'll call it that since we're all here today. 3 Guys Games, VamKid 3D. And we're going to cover a little bit of these momentarily. Let's go back to our slides here. Now, the build, as I mentioned, Windows 10 supports device families. So there's a mobile device family, a desktop device family, and additional will come. So I would expect to see an Xbox device family and a HoloLens, and you're going to be able to specify which device family your package will run on. If I only want to target mobile devices, I will make sure that I specify that that package will only target mobile. Now, the store is not open yet to developers, so we can't see exactly to public-facing world how this whole process works yet, how you're going to specify the device family, where you're going to specify that. But just know once all these bits are released, you're going to be able to specify a device family and choose where you can and cannot go to, which device families you can and can't go to. Multiple builds still work. In other words, if you want to create a build for the phone and you want to for a mobile device family and a separate one for a desktop family, you can still do that. Similar to what you can do now. You can create a phone build and then you can create a separate build. Now, going forward, right now, if we create a universal build, for example, it's going to create, for Windows 8.1, it creates an actual, the Windows Phone build, and then we actually have the build for all the other Windows Store devices. So like my tablets, my desktops, multiple packages. Going forward, we actually get truly one package. We get different binaries that roll up into that single package, and it's going to work. It's a pretty cool process. Now, have you worked with asset bundles at all?
A little bit.
So asset bundles is a process that Unity has. If you have a low quality set of assets and a high quality set of assets, you can basically say, all right, depending on some criteria, maybe my screen size or some criteria, choose the low quality of assets, or let's say I'm on a big screen, choose the high quality version of assets, and you can actually stream them from remote locations. So that's one process. It takes a little bit of work to set up, although much easier in Unity 5. There's a great Unite talk that you guys did on setting those up, and you do have to host those packages somewhere yourself, and then you can stream those in. So it's one process, but again, you can create the separate builds, or you can take one to run across multiple device families. Now, this currently requires what's going to be released as Unity 5.2. If you happen to be part of the Windows Store beta, you can see that currently in action now. If you're not, then Unity has announced as part of their public roadmap that will come in Unity 5.2.
Yeah, actually, I was just pulling that up here. The new roadmap just came out, so if you go to unity3d.com, you can see right on the home page.
Cool. Show it on your screen. Let's look at a couple of those features real quick here.
Yeah, let me just get to that. Right here, right on the home page.
Roadmap.
Our roadmap. So, dates, what's all going to be on there.
September 8th, 2015.
Color-coded. This is a bit of a bummer. The 5.1, the font size is really small if you have a high-resolution display. So that's actually been flagged red, so slightly delayed, but we'll get there. And
Scroll down a little bit, can you please?
I can. Actually, let's scroll the whole thing down.
There we go. Platform, Windows 10 Universal Apps Support. So September, what was that, September 8th?
That was, yes.
Okay, so that is the publicly announced date from Unity as to when these bits will become active. Cool.
Yeah, check that out yourself.
All right, so let's look back at the slides here on for Visual Studio and Windows 10 dev settings. There's a couple changes here. When you load up your Windows 10 solution in Visual Studio, and if you do this today, for example, it wants you to enable developer mode for Windows 10. And if you were to click on the link that shows up, again, this is from Visual Studio, Settings for Developer, you now have Operating System Integrated Settings. So when I click on Settings for Developers, my Settings app loads up here. Don't use developer features, sideload apps, and developer mode. So you just select developer mode, and from that standpoint, you're good to go. On the phone, it looks just a little bit different.
You just dial 1. Oh.
Well, let's go back to 1 here. You can search on your phone. This is Windows Phone 10, which is also available. Search for in your settings, Devel or developers, and you'll see for developers. So that's number 1. Number 2, once you turn that on, you'll get prompted. Basically says, hey, this is essentially going to allow you to sideload apps on your phone. Do you want to do that? Yep.
So I don't have to tap 7 times on some?
No tapping 7 times. Nope, this is pretty straightforward. Then, just like you would see on like I showed you in the desktop Windows 10 here, the mobile, same exact options here. Don't use sideload and developer mode. Nice. And then away you go. Okay, now compiling. When you compile for release and master builds, you are using .NET Native. If .NET Native has no dependencies, otherwise than having your system be able to support it, but .NET Native is different than if you've been using .NET for a while. You might have heard of NGen, and that would essentially just-in-time compile, pre-JIT they call it, your assemblies down to native code. So it was an intermediate language. It compiled it out. And with .NET Native, with NGen still had a dependency on the .NET framework. .NET Native has no dependency on the framework. It fully compiles it out to native code with no dependencies, which is really neat. Now, it allows you to start 60% faster, 15, 20% less memory. It's fast. Now, if you happen to get the Windows 10 bits now and compile it, your compilation process might take a little bit. So I'm not going to show you the full compilation process. I will do everything but compile, although I could surely kick off my compilation process. .NET Native is still being optimized, and the compile process takes a little bit right now, but that will be optimized for release. If you do a debug build, you are still using Core CLR, so it's not going through the same long process here. Images. This one kind of gets everybody, and this is virtually the exact same right now between Windows 8.1 and Windows 10. So you really need to change the default images, because when you create a Windows store built from Unity, the default images will be set. There's 5 of them, and you can see here on the screen, and Unity will just kind of set their logo. You want to go in and make sure you change them. Don't deploy an app with Unity's logos. I've seen folks get rejected for that, so just as a heads up, you'll want to change that, and I'll show you where you can change that momentarily here. Now this tool is pretty neat, and I'll show you this in the web browser in a second here. This will generate you a whole bunch of images. I've actually filtered it down to just the ones that you're going to need here. Notice 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. In the editor interface, I'm just kind of mapping these out here for you. And I have a link to a document at the end of this, a little quick start guide that I wrote, where you can actually look at this in the future. I'll give you the URL for that, so if you want to go back down the road, and I'll keep this updated for Windows 10. This is where those images map to. So in the Unity editor interface, that's from the files you download. If you look at number 1 here, you're going to take and select this image. You're going to select this one here and choose Store Logo Scale 100, and so on. You get the idea. Small logo, you're going to come over here, Scale 100, select small logo, and number 4 and number 5.
Nice.
So let's look at that. This is a pretty cool tool. All you give it is an image. I should have probably taken a little screenshot here, and we can do that actually real quick. Let's take Matt, rightfully so, very proud of his little zombie friends.
Too bad he's not here to appreciate that comment.
I think he's sleeping over there.
Oh yeah, he is sleeping right over there.
Let's take the zombie here and just let's do something basic like this, just to get a squarish image. And grab a square-ish. That's about ish. We'll save this out to our desktop. We'll upload this to the tool, and then we'll get a whole bunch of images, more than you could ever imagine. File, save as. Love this tool.
The save as prompt.
No, this this particular tool I'm using here. I personally love it. You know, for Microsoft, I'm not endorsing or approving or denying any other tools, but there's personal tools that I personally love.
I like that one.
This happens to be one of them. Okay, so let's go over to the website here and choose Files and go to the desktop. And that was this guy right here. Now I'm going to download Windows Store Zip, so it's going to upload my file and download a zip that's got a whole bunch of these images in it. There we go. 2 megs. Remember when 2 megs took a long time to download?
I do.
All right, we've got more images than you could ever want here. We have 35 images in here, to be precise.
Holy cow.
Yeah, there's a lot of images in here. So why do you have so many images? There's different use cases. If you're on different pixel density displays, you know, one icon might scale differently than another, and so Windows will actually select the best icons to use in those cases. So you can provide them. If you're not making really different art assets, like if you're not using vector graphics and creating different scaled out graphics, I just use the basic ones here, and they work fine across. If you really want to be slick about it, then you would have your graphic artist, that guy back there, Matt. Then you would basically use some sort of vector graphic and just create scaled out images. So when you're running on these big high density displays, they look really good, high pixel density displays. All right, so we've got these images here. You go over to Unity, and you go to Build Settings. Let me go into a virtual machine here and load Unity up on there. While that's loading, I'll show you. It's virtually the same exact settings. So Build Settings here. Let that load up there. Windows 8, 8.1, Phone 8.1, Universal 8.1, and you'll see once we go back to the virtual machine here, Windows 10. Again, virtually the same options across the board here. Player settings, this is where we can set the name that we looked at. Now those images you'll want to set underneath your icon. And then you have your splash screen here as well. So again, that the slide I kind of talk about exactly. Pick these out. So splash image, Windows, scale 100. 620 by 300. We come over here and we say splash image, Windows, 620 by 300. I would unzip all those files and select that one. Make sense?
Yes.
Clear as mud or clear as water. All right, let's go back to that VM and see Unity's loading up here.
We're just, like 3 weeks away from Windows 10, aren't we?
Oh my goodness, tomorrow is July 1st.
Yeah.
Wow.
Crazy.
All right, build settings.
Good.
So Control-Shift-B, if you're a Visual Studio user, it's the same exact hotkey. Now notice here we have 8.0, 8.1, Phone 8.1, Universal 8.1. We've had a bunch of different builds, as you might notice. Finally, in Universal 10, it's one build. For all of the Windows 10 platforms, it's literally one build. So this, we can say goodbye to all this kind of stuff. We're looking forward to Windows 10. Let's go to our player settings. Splash image and our icons, all the same stuff I just covered. You say build, and this will create you your Visual Studio solution. Choose a folder. I'll name it something like Windows Store Build. That generates a Visual Studio solution for you, which I just happen to have open here. In the Visual Studio solution, Unity will only ever overwrite your data folder. So if you make changes to your game, you'll pick those up here. If you make changes to your images, those won't be picked up here. So that's the caveat. If you come back over here and after you've created your build, you change your images, you're going to need to go back in and either add them in Visual Studio or blow this project away and have Unity regenerated again. That works just fine too. When you want to test it, you can deploy on your local machine, or being that this is a universal Windows platform, I can plug in my phone and I don't have to switch over to a different phone project. This is one single project. I deploy it to my local machine. I can go to a remote Windows 10 machine, download new emulators. It's going to be kind of cool to see what emulators will be coming out. Device, plug in a Windows 10 phone, deploy it right out to my device. So all the same code, all the same project here, and it just works. Yeah, really, really sweet. Again, I'm not going to do the build here because it's going to take a little bit because of the .NET Native, and I'm in a virtual machine here. But I can show you. I like the new logo you guys added on there. The new splash screen. It's pretty good.
It kind of puts it together.
Yeah.
Yeah.
Yep. Now this was the earlier yesterday build, so I don't have the later characters near, but you can see.
I think it was earlier today build.
This is the oh no, this was the late wait for the long build. So notice the idea of having these displays that can kind of scale out like that are excellent because these run by default windowed. And so you want your UIs to kind of resize to this display here. Give it a second to pop over there. So the user can take these and scale them out however they want. So it's very, very important that you're using the UI system, as we talked about before, so you get this kind of dynamic scaling between your different sizes and all that. All right, back to these guys. So generating images, super easy. Building for Windows, also very easy.
Yeah.
Visual Studio solution is generated from Unity. Now, another option that you can do from the Unity side, and you can do this for any existing Windows build, Windows Phone or Windows Store build now or on Windows 10, bring up your build settings, and let's say I'm doing a phone build. You literally plug in your phone, your Windows phone, and say build and run, and this will generate a debug build, deploy it to your phone, and you're playing your game.
Yep.
So it's a very, very fast, iterative cycle. If you want to build your Visual Studio solution, you can do that as well. I typically like to run master builds because they're faster. So let's kind of talk about those settings here. I'm sorry, you're going to
get the profiler then too, right?
We'll check out the profiler too, absolutely. There you go. So resize over there. Let's close that out. So again, I can deploy really to any device here, remote device as well. X this out. Save this guy. Debug, release, and master. Debug, release, master. Debug, release, master. People that have been used to using Visual Studio for a while, you have a debug build and a release build. Release went to production, and debug was not optimized. Now, Unity, we have 3 different builds here. So if we look at the actual settings inside of Visual Studio, we have debug. These are not in order. Debug, release, then master. Debug has no optimizations, and it supports Unity's profiler. Release is optimized, still supports Unity's profiler. And master is completely optimized, just like releases, but has no profiler support. That's stripped out from there. A couple things to watch out for. If I'm going to deploy to a device like a Windows Phone, that phone is going to be an ARM-based device. So I'm going to be doing an ARM deploy here. If I'm deploying to my local machine, this is an x86-based machine. So you know there's just 2 options here, ARM or x86. If I try to deploy the wrong type, it will tell me that I've selected a build for the wrong processor architecture. So you have to be careful about that. Visual Studio will give you the message. Again, once you load this project up, these are the only settings you really need to look at, assuming you've set your publisher name in Unity and your images. This is what you kind of want to check out here. Where you're going to play to, where you're going to deploy it to, what your target processor type you're going to be testing on, and what your actual build type is. Profiler. Profile, 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 profile. I cannot stress this enough. Let's open up the profiler and run what we have kind of going on here. So window profiler. This is one of the most exciting things about Unity 5 being feature parity with the editor features between the personal edition and the professional edition, because the professional edition before was the one that had the profiler. So anybody that had the free version could not use a profiler, and now you can. So let's go ahead, and we are in our main scene. Let's run this, and let's just see. Give it a moment to start up. Okay, go, 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 go. Let it run. Now, let's go to the profiler here, and we can see we've got a couple different things going here. Third-person controller, wait for target FPS. I can see my rendering on here, how much memory is allocated here. So Unity's got 160 megs, unused total 365, Mono's using 9.5 megs. So some pretty cool lower-level details here. Audio system performance. Now, let's break this, shall we? Let's say, and I know this because this has happened to me before, so we will we'll make this less performant. Let's get a couple debug log statements here. Not that many. Maybe like 5 in here. Just debug log statements. Come back to Unity. Run that again. What was the catchphrase you said before when it would start up?
Oh, wasn't that. It was
one
more time.
See, look at that. All right, notice my performance is visibly affected from the last build. It's not the profiler doing this.
You pushed the turbo button on your computer.
The turbo button.
Turn it off.
Let's go to the profiler and pause this here. And kind of maximize, not that. Oops, that's not the view I want. Let's get that view back again.
Quite a wealth of information in there, isn't there?
There's a ton of information on there. But there's only one that I want to show you. And it was pretty apparent what happened, but you should see it in here glaringly stand out. Go, 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 go. I mean, our frame rate before, there we go. This is exactly what I want to show you. The top item here, responsible for 96% of the CPU. I open that up, and we look, and it's log string to console. And just to see, we can see it in our profiler here under our rendering. We have, where is our, so we've got our draw calls, and does it show us our frame count on here? We can view it here. Let's just show it here for simplicity. Okay, let's run this game, and we are currently at 2 frames a second.
Oof.
All right, let's get out of there and just come back here and undo what the profiler told us was the issue, these debug.logs. Just debug.logs. That's it.
You probably shouldn't use those, Adam.
Now watch this. I know, it's starting up. You're like, what? I'm on the edge of my seat.
Come on. 3, no.
All right. There we go. So roughly 40 frames a second here, and I can still optimize quite a bit of this out too. This is an unoptimized game as it stands. Although Matt did a good job with the combining the textures on here, so we're at 35, 40 frames a second here. Not bad for this one, and we have our effects still on the camera and all this kind of stuff. So yeah, there we go, 40 frames a second.
Very nice.
Very cool, right? That is an awesome, awesome, awesome tool. Awesome tool. Well, I think that about does it. Let's close up here. There's a porting document I have, aka.ms/Unity for Windows. Don't forget, on MVA, there's an existing porting course on there as well. But this, I kind of keep this as a live document you can go and see changes on. Check out aka.ms/Unity for Windows and visit that frequently and often. And we hope that you enjoyed your time today. We surely did. This has been a great day, a lot of cool stuff. We love doing this, and so hopefully that you get something out of this because we keep continuing doing this. Now, my buddy Matt back there is saying, you know what, you should play that game a little bit to see how far you get. He doesn't think I can make it to the end.
Well, Matt, why don't you come up here and you play?
Let's try it real quick here. And you know what?
Get out of the sleeping bag.
Out of the sleeping bag. All right, let's try this one time here. I'm going to ignore my dumb zombies.
Challenging that zombie right there. Matt probably wrote that AI, right?
Yeah, now he thinks that I can't maybe make this turn here. Ah! Now, I do want to be clear. When I said we know about 12 bugs on here, there's actually a bug in this code right now where if, when I jump and then move, it's actually always pushing me in that direction. If you notice, I was looking this way and it pushed me that way. So that's why you're... Excuses. Try the code yourself. You'll see. Turn it aside and jump. I'll have that fixed shortly. We just didn't have time before this. But again, this is visit the GitHub URL for that project. Let me throw that up here as well. GitHub.com/Adam Tuliper, and on there my repositories, and you'll find the VampKid 3D that we've all worked on for your enjoyment here. Again, feel free to check it out, use it. Check back often. I will be making, we will be making many changes to this going forward, so this will be a learning exercise for you. And if you have any questions, reach out. Our contact information was early on, Twitter, at Adam Tuliper. Any questions, issues, reach out to me, adamt@microsoft.com. Be more than happy to help you. And we'll see you next time. Thank you very much.
Thank you, guys.